faire au clavier, je vais rester pas loin.
Bah
oui,
j'essaye
ouais.
J'essaye de vous trouver ça.
Très bien. Au niveau de la caméra, ça se passe comment? Parce que si je fais des démos, je vais me mettre sur la machine. Je m'oriente un peu
Pour qu'on aille chercher ça?
Ouais. Non, c'est bon, je vais partager l'écran, mais c'est juste que je serai de temps en temps positionné comme ça.
Ah, alors, peu importe, nous on vous suit.
D'accord.
Après, l'idéal, c'est
surtout pour les micros.
Voilà. Si on peut éviter, si vous pouvez, on peut se rapprocher si vous le souhaitez.
C'est ce que je vais. Voilà, je vais me mettre comme ça. Je vais mettre un des micros. Juste pour info, c'est bien en anglais la présentation.
Oui. Il faut dire, c'est en anglais.
Oui, c'est ce qui me semblait.
Vous avez réussi à vous connecter, c'est bon?
Oui. Je me connecte juste à ça et c'est bon. Tout à fait. Ah oui, il y a un dongle. Ouais. C'est la première. C'est pareil pour moi, je vois. Si jamais, je vais pas être très très mobile, hein, donc c'est.
Vous avez une présentation binôme là? C'est ça?
Non, je suis tout seul. J'ai 1 heure de présentation et puis une petite démo, c'est pour ça que j'aurai besoin probablement.
Est-ce qu'il y a une personne après vous sur
Ah bon? D'accord, oui, parce que moi j'ai de 9h à 10h. Magnifique. Merci beaucoup. Oui, c'est bon, je laisse, ça fonctionne. Au niveau du son, il faut que je sois près du micro ou on entend là?
Raisonnablement, ça passe bien.
Très bien.
Pas besoin d'être collé, certains micros, il faut vraiment être comme ça, mais là, ça va.
Très bien.
Bon, c'est tout bon.
Eh bien, c'est tout bon, c'est comme vous voulez.
En fait, à cause de la pluie, il y a beaucoup de gens qui sont à l'entrée là, parce qu'en fait, il y a un vigile, il faut s'identifier.
D'accord.
Et on va attendre un petit peu parce que là, il y a qui font la gueule.
Très bien.
Ok.
Non, mais là, la circulation, c'était compliqué ce matin dans Montpellier.
Eh oui.
Du coup, c'est pour ça qu'il y a pas mal de gens qui sont pas.
Ouais, on a un peu de battement, je crois qu'il y a la pause après. Donc.
So welcome to all. This morning we start with Benoît Chauvet, who is a software engineering manager for the Software Heritage Project. He's responsible for the technical development and the technical roadmap for the technical team of Software Heritage. He will introduce the project and then make a little demo and show answers for your question. So this session will be followed by 2 parallel tutorial sessions. The session 2 will be in this room, and the session 1 to introduce to GitLab and Jupyter binder will be in a room downstairs. So after the coffee break, you stay downstairs, and we all go to the classroom. And the last information, you can pick your t-shirt at the coffee break if it's not already done. So, Benoît.
Thank you. Good morning, everybody. So, to start this second day, I will introduce you the Software Heritage Project, and so give you a quick overview of the project. In a few words, explain how it is related to GUIX. And then we will have a demo/tutorial of how to archive your code and the different archival features of Software Heritage. So to start, the project was created in 2015 on the initiative of Roberto Di Cosmo and Stefano Zaccheroli. And the purpose is to build the universal archive of source code. And until now, we are hosted by INRIA. So the project belongs to INRIA in collaboration with various partners, among them UNESCO for the preservation and cultural heritage part of the project. And we are, the team is now around 15 people, including 9-10 technical persons. So let's have a quick overview of the matters for software in the context of research. First, it's probably obvious, but software is everywhere in society, in any domain, any topic. Now we can find and use software. So in the research context, there are a few needs that needs to be covered. The first one is to make sure that software artifacts need to be archived. So one of the purposes of Software Heritage was to find a solution to properly archive research software, because publications are archived, but there are systems like HAL to archive publications, but for software it was not that developed, and it can be a matter. We'll see that. So first we need to make sure we can retrieve software, and one of the key point is to make sure that a reference to software in a publication can be found after years, which was not the case before the Software Heritage Archive. The second important need is to reference, to properly reference software, including reference a given software, but also a specific version of a software. For reproducibility, it's pretty important. So there is a strong need to identify software, and Software Heritage proposes identification mechanism called SWID that we will present. Artifacts must be also properly described. So there is a strong need to give tools to discover, to reuse and to describe properly the software. So how to document and to bring some metadata around software. And last but not least, the citation, the credit for software artifacts are essential. So there is a need to propose to systems to cite and credit software authors. So the reasons that lead to the creation of software heritage were a state where there are a lot of different platforms, different and with various technologies. So you have some Git, forges, some SVN, CVS, and so on. And a lot of different platforms and forges. And mostly operated by for-profit companies, meaning that there is absolutely no assessment that these companies will be sustainable. And history proved us that it can happen. For instance, Google Code decided to stop, and all the code hosted by Google Code was bound to disappear. And luckily, Software Heritage was already here to archive the code in Google Code. So even Google cannot guarantee sustainability. So, as I said, we need to make sure that some archived code can be referenced, and a reference must be sustainable. And the point is that projects, during the lifetime of a project can move to another forge, servers can change, and so the problem of concrete links can be a real matter. So as I said, with Google Code or Gitter use, and some forges can disappear. So the code hosted by a private forge can be destroyed. Even GitHub or GitLab are just private companies, so there is no guarantee that tomorrow GitLab won't lock down. The probability is low, but it's not a stable resource. And there is also a part for physical legacy software hosted on physical devices. So a part of Software Heritage mission is to collect the legacy source code on all the floppy disks or magnetic disks and so on. So that's the point. Where do you go if you lose the code? And that's what Software Heritage proposes. So the mission of Software Heritage is based on 3 main actions, which are collect, preserve, and share software source code to preserve it as an heritage, human heritage, and to make a universal source code archive. The purpose of Software Heritage is to archive all the source code and all the history of software projects, either public, private, open source or not. Obviously, the main focus at the moment is to archive publicly available and preferably open source code, but it's not the only target of Software Heritage. So to summarize the mission of Software Heritage, we are the great library of Alexandria of the software. That's the point, and we try not to burn. So to find and reference the code, we are building a reference catalog. We will just have a quick look under the hood to archive properly and find out source code. So this archive has a mechanism to make sure that we will preserve and share the code. So we also have tools to retrieve the source code. And it's also a research infrastructure. It's a bit like a big telescope on the history of source code, because software heritage is the biggest, the world's largest data set of source code and software projects history and metadata. So it enables a lot of research works around source code. For instance, Stefano Zacchiroli published a paper, I think it was last year or 2 years ago. It was a study on the gender evolution of software development. So he was based on the source code archive, analyzing the names of the authors and making a study to show how the repartition of authors' gender evolved in software development. So it's one example among an infinite possibilities of research. So the software heritage archive is open to four main pillars. So the first one is cultural heritage, hence the partnership with UNESCO. Software is an heritage. The second pillar is industry. So we also provide tools and features that could help industry. For instance, for cyber security. For public administration as well. This is the third pillar. For instance, code.gouv.fr references all the French public administration source code for softwares. And for each software reference on that platform, there is a link to software heritage to retrieve and access the source code of this software. And last but not least, the research. So software heritage is very active in open science and research domains. So to really to strengthen the software archival and to make software a first-class citizen in scientific publications. So a few figures to have an overview of the actual archive. Today we are around 17 billion unique source code files archived, which represents more than 3.5 billion commits and 260 million projects archived. Projects being actually origins, so sometimes you have several origins that are different forks of the same project. But this is the state of the archive, and it keeps growing. So this is there is a massive source of data. The Software Heritage Project is completely free and open source, so we are completely transparent. We are also working on, so the code is open and accessible. We are also open to contributions, to external contributions, and we are working on, we have replicas around, and we are also working on mirrors. So there will soon be some software heritage mirrors hosted by third-party partners to ensure the sustainability of software heritage. So there are a lot of contents which are all identified by intrinsic identifiers, which is a key point of the archive. And we also have projects to identify the provenance of source code and to provide features around these contents. The organization is non-profit, multi-stakeholder, so the purpose of Software Heritage is to be a foundation and to be forever non-profit. so to host a cultural heritage. Just a quick overview of how it works. The software heritage architecture is actually based on a Merkle DAG on the right side of this diagram. So we store file contents, all the source code file contents that are referenced in different directories. These directories being related to revisions, which are commits in the Git context. And some revisions can be tags or releases. And each time we visit a repository, a project, we create a snapshot. So this is a key feature of software heritage. We can have the state of a repository at a given visit by software heritage. So even if somebody rewrites history in their repository, software heritage keeps the state of the repository when it was visited. So this is the snapshot definition. And origins, which are the URLs of the repositories. So all of this is deduplicated. So if the same file appears several times in different projects, we store it only once. So this data structure is a Merkle DAG due to that. And so to fill this archive, we use some listers and loaders. So the first step is to identify different forges and package managers, like GitLab, GitHub, NPM, GUIX. And then we do some listing. So we collect a list of all repositories that we identify in these forges. These repositories can be you can use different CVS technologies. So it can be some Git, some SVN, and so on. So once we list all the origins, we have then some loaders. And the loaders, for a loader, takes one origin, collects all the data in the repository, and inserts it and updates the archive with the contents. So it adds the new content, the new identified contents, or it updates the graph. So this is the core business of software heritage, the way we collect the data. To give you an idea of the volume, this Merkle diagram is a graph with approximately 30 billion nodes and 300 billion edges. And the size of the contents, the volume of the contents is approximately 1 petabyte at the moment. So it's also, this graph can be downloaded and used for research and graph use. So it's probably one of the biggest free access graph online. So in a few words, how is software heritage related to GUIX? I won't get into the technical details, but to give a quick overview, GUIX enables reproducibility in the builds. So when you want to rebuild a package, GUIX will get the source code and rebuild the artifact. If the source code is no longer available, then GUIX will fall back on software heritage and get the source code from the archive. So in the software heritage archive, we have a feature called the vault that can reconstitute a repository in Git format. So it gives you a Git tarball of the repository. And so this is how GUIX uses software heritage to make sure that the code will still be available. And each time a package is created in GUIX, GUIX saves it, archives it in software heritage using a feature called Save Code Now that we will show in the demo. So this is a real key to reproducibility and sustainability. To using this mechanism enables to make sure that in 10, 20 years we can still use GUIX and the software source code will still be available. So it's really important to make sure that your source code is archived in software heritage to make it accessible. So now I propose you to have a quick demo of the different ways to archive your code, how to archive code in software heritage. So the first way to archive code is to use a feature called Save Code Now. So if your code is archived in github.com or gitlab.com, these forges are regularly visited. So your code is probably already archived. But we cannot guarantee that the visits are always up to date. So there can be a couple of weeks between two visits of one repository. So the Save Code Now feature enables first to renew the visit, to trigger a quick visit of your repository. For instance, you have a publication and you want to create, to reference a recent piece of code from your repository. So you can use Save Code Now to trigger a visit that will be done within a few minutes, and will update the archive with the last version of your project. You can also use it to trigger the archival of a repo that is not yet archived in software heritage, and we will see how it works. So when you visit the archive, so there are the links at the end of the slides. You will find all the necessary links. So when you go to archive.softwareheritage.com, first you can see which forges and which source code technologies are archived. And for instance, if you choose, let's say, GitLab. So on GitLab, we list all these forges. So all these forges are known and regularly crawled by software heritage. So you can browse the archive and look for your code. For instance, if I look for a project from Roberto Di Cosmo, ParMap, so I can see that this project, so this origin, Roberto Di Cosmo ParMap on github.com, it's been archived. We archived, so we know this project. It has 52 branches, and we can browse the history of the visits from the archive. Okay, this is a test project that is used also on our testing interface. So there are a lot of visits on it. It's a bit special, so it can. That's why sometimes there is an error. So you can see when the project has been visited. And yeah, so for instance, the last full visit of the project was done on the 7th of September at 10 p.m. So it's been visited super recently. So this is a way to check whether your code has been archived in software heritage. If it's not archived, you can use the Save Code Now feature. So either your origin is unknown in software heritage, or your project is already archived, but the last visit is out of date, and you need to refresh the archive rapidly. So you go to Save Code Now. You choose the origin type. We support at the moment those formats. So Bazaar, CVS, Git, Mercurial, SVN. And then you copy-paste the URL of your origin, and you submit your @forge now. You can see the queue of the last the Save Code Now request. And here you can also trigger a save again. So we have a button save again also on, when you visit, when you check an origin on the archive, you have a save again button that also triggers a Save Code Now. So you can either copy paste the URL of your repository or directly go and browse your repo and use this save again button. Okay. So this is the Save Code Now process to archive or update your repos. I'm going to go back to the slides. So this way, you need to go to Software Heritage archive website and search for your origin. Last year we published a browser extension that enables to provide a quick view on most known forges. So when you are on GitHub or GitLab, if you install this browser plugin, you have this little button with a color that lets you know whether the origin you are browsing on GitHub, on GitLab, so whether this origin is up to date in the archive, or is it known but not up to date? Is it not archived yet? Or is there an error because, for instance, your repo is private, so it's impossible for Software Heritage to archive it? So I will give you an example of that. So I installed it on this computer. So if I visit, I took a sample GitLab project. So I can see that this GitLab project, it's a bit small here, but you can see that the icon is yellow, so it says that the archival copy is not up to date. So it says that the last change was on the 29th of June, and it was last visited on the 24th. So in this case, I know that directly, without visiting Software Heritage, that this project is archived in Software Heritage, but it's not up to date. So if I want to update it, I can simply click this button, and it actually triggers automatically a Save Code Now in Software Heritage. So now the project is up to date. And if I go back to Software Heritage, and if the queue is not too fast, yeah, here I can see that I can see the project I just archived directly from my forge. So it's written as not yet scheduled. We can come back in a few minutes, and it will be updated in a few minutes. And so this is another way to make sure that your projects are up to date. So the purpose is to make it simple to avoid tricky manipulations, so you can have a quick overview of the status of your project in the archive, and without creating an account or nothing, you just archive your code. So there are also links on the references to download these browser's extensions. There is another way to archive to trigger Save Code Now, which uses the Forge's webhooks. So instead of manually triggering Save Code Now when you want to update the archive for your project, you can automatically trigger archival on specific events of your project. So this is restricted to major events. I mean that don't use it for any commit. Don't trigger an archival each time you commit something on your project, because it's not the purpose, and I'm not even sure it's possible. I think it's blocked. But for instance, on a tag or a branch creation, each time you create a release, it can be interesting. So to configure your Forge to trigger this Save Code Now, so that you don't have to matter any longer. You just, each time you create a tag or a release, you will archive your code. So there is a, we've published a quick tutorial to explain how to do it with the main Forges. So it's available on GitHub, on Bitbucket, on GitLab. And so I will show you on GitLab how it's done. So in this documentation, we give you the link to provide. So the way to do it is to, in your archive, in your Forge, you give the URL of an API at Software Heritage, saying your project that it needs to contact Software Heritage to trigger an archival each time a tag or a branch is created. So for instance, on my sample project, for the GitLab version, you go on the settings of your project. There is a webhooks menu. And here you can, so you can add a webhook. I already added it, so I will just edit this one. And you simply copy-paste the URL of the webhook that was provided in the documentation. And you decide, you check the events that you want to, for which you want to trigger an archival. So on my sample project, I decided to trigger archival each time I push a tag or I create a release for the project. So if I create a release in my project in GitLab now, it will automatically trigger a new Save Code Now. So this is the webhooks. So we've seen how to archive a single repository in Software Heritage. Now we will see how to archive a whole Forge. So you can have an instance of a Forge, for instance, a GitLab instance specific to a laboratory or to a research group. So rather than archiving each repository using Save Code Now, it's a feature we launched almost 2 years ago now. You can declare this whole Forge to Software Heritage. So it's a bit the same principle as the Save Code Now, but instead of pushing only one repo, you push your whole Forge. So there are a couple of differences. So I will show you how it works. So when you visit the archive, you can go to Add Forge Now. It's a bit less now than Save Code Now, because there is a manual curation. For this feature, you need to be logged in. So I will log in. Hopefully I remember my password, yes. Okay, so when you want to submit a request, you select the Forge type you want to archive. So this is a list of supported Forges. For instance, if it's a GitLab instance, you can choose that it's a GitLab instance. You copy-paste the Forge URL. Then you mention the name for curation purpose and validation purpose. We need to know who deposits the forge and who to contact to make sure that everything is fine. So you mentioned the contact name of the forge administrator, for instance. You mentioned the email, so it can be someone else. You can do it for, you find an interesting forge. It's not yours, but you declare it in add forge now, and then you mention the contact name of the forge admin. You can add a comment, and then you submit your request. Once it's submitted, it will go through a curation process. So we have some moderators that will check. First, they will check if the forge is appropriate. And then we will notify the forge administrator that we have been asked to archive the forge. So we ask if there are no blockers for archiving the forge, no technical blockers. If you wonder, if you're interested by these cases, if it's a small forge and you are afraid that the software heritage crawlers would trigger too many requests on your forge, the add forge now process uses specific workers that auto-limit the rate of the visit, so that we ensure that the visits by the archival will not overflow the servers of the forge. And so once we validate the process, we add the forge URL, we add the forge to the list of known forge, and then it's archived, it's visited the first time, and then it will be frequently visited like all the other forges. So it's a super interesting way to extend the archive coverage and to declare your forges. So if you know some specific forges that are publicly available, we need to have access to them, feel free and don't hesitate to mention them, to create some add forge now request. You just need to have a software heritage account. And it will ensure that all of this code will be preserved and saved, because small independent forges can be subject to changes and can easily disappear. So it's important to archive them. So this is add forge now. Okay, so we've seen the basics of archival. Now, once your code is archived, you may want to reference it, to cite it, because the interest of archiving your code is to preserve it, but it's also to provide links to your code that will be sustainable and that to make sure they won't disappear. So for that, we use Software Heritage created an intrinsic identifiers model, which is called SWID. So now SWID, first SWID meant Software Heritage Identifiers. It has been renamed in Software Hash Identifiers because it uses the hashes that identify artifacts. And it tends to be generic and not only dedicated to software heritage. So the important thing is that these identifiers are intrinsic. So you can recompute on your own the identifier of a source code file, of a repository. And so you can make sure that if you have a source code file and you want to know if it's archived in software heritage, you can use a command line tool that we provide that computes the hash of your source code file, and you get a SWID, you get an identifier, and so you can use this identifier and search in the archive to see if this content is already archived. So it's a quick way to find the code. And as it's an intrinsic identifier, you are sure that the exact content is archived. So if there is only one space in the source file that is different from the one which is archived, it will be a completely different SWID, and so you can make sure that it is the exact version of your source code is archived. That's the interest of the intrinsic identifiers. Each kind of artifacts are identified by a SWID in software heritage. So you can identify contents, but also a directory in a specific state. You can identify a revision or a commit. You can identify a release, a revision, or even a snapshot. So this is interesting because you can mention a software on a specific release if you want to publish a result explaining that you used some source code some code to find the result. You can mention precisely which version was used using the SWID of this version of the software. So a SWID has this format. So there is the SWID prefix, SWID protocol, a version of the SWID. So the actual version is 1.1, so SWID version 1. Then the type of artifact, so is it a content, is it a directory, is it a revision, a release, and so on. And then the object identifier, which is the hash of the object, and this is the way we identify objects inside the graph and the archive of software heritage. So this is the SWID format. I will provide you a quick demo of it. So if you browse the archive, okay, so I will browse an origin. An origin has no SWID. An origin is not an identifier. It's just the URL where the project, the repository was found. For instance, if I take this file, in that project. Here you have on the right of the screen, you have a permalinks tip that will give you the SWID of the content you are browsing. So this is the content, this file, so the content. You can have the SWID of this file, so you have a permalink that gives you the basic SWID. So you can copy-paste the link behind that. So you can browse archive.softwareheritage.org/ you paste the SWID, and you will find this content. And you can add some contextual information. Because, for instance, for a content, for a single file, this file can exist in millions of projects. For instance, if it's a GPL license file, you could have exactly the same content in lots of different projects. So this content, this file, in this version, will have only one SWID. So if you browse only this file, you cannot retrieve the context in which project it was found, in which to which origin it is related, to which commit it is related. So when you are browsing a content in the context of an origin and a revision and a release and so on, you can add the contextual information. So in the URL, it's a bit small here. I will check on the slides. Additionally to the SWID, you will find some information. So having origin, so you have the URL of the origin where the file is referenced, to which snapshot, to which visit it corresponds in the archive. And you can have the path, an anchor to give you the path in which directory you want to mention it. So it can be interesting because you can want to mention one source code file, but to specify in which context you mention it. I mentioned that file in the context of that project and that release and so on. And you have the same for a directory, a revision, a snapshot. So you can easily share and publish links to contents using this suite protocol. And last but not least, you can even use these permalinks to reference an extract of code. So when you are browsing a file in Software Heritage, this one is not a source code file, but no, never mind. You can click on the line number. So you need to the second click is a shift click. Okay, so you use click on shift click, and then you will have an extract. So from line 17 to line 21 of this file, and in the permalinks, you will find on the contents tab. Additionally to it, you will find at the end of the permalink the reference to the lines. So this link will bring you to this exact content. So if you want to quote an extract of a file, you can do it, and you can bring a link to that. And this link, using the suite, which are persistent, you can ensure that if you put this link in a publication, in years and years, it will still be available and it will still work. So it brings a strong tool for persistence and identification. So here you have the different context information that you can add in your permalinks for referencing. So this suite identification is essential for referencing quotation. And last, I wanted to talk about the deposit in HAL. So scientific publications in France have the duty to be published in HAL. On the HAL platform. And there is a partnership with Software Heritage for the software part of a publication. So now you can publish software in HAL. So there are two ways to do it. The first one is to deposit through the local method. For instance, your code is not on a forge. It's not in the Software Heritage archive. You just have the zip file. So you can upload your file, your source, your zip file containing your source code. You can upload it on HAL, provide necessary metadata, and there will be a manual curation process by HAL, and then it will create an entry in HAL, and it will archive your code in Software Heritage. So HAL will create a new entry in, it will deposit your code in Software Heritage, so it will be archived. The other method, which is the most recommended one, is that you archive your code in Software Heritage first, using Save Code Now or the different features we've seen. And then you get the suite of your project, of your, for instance, you get the release you want to publish. So you go on your project, you pick the release you want. Let's say, for instance, the tag 1.2.3. And then you get the suite. You get the suite of this release, and you just go to HAL. So it's on hal.inria.fr. It's a dedicated portal of HAL. I will try to demo it. I not do it often on HAL, but there we go. So you can deposit on HAL. Okay. Okay, this is the demo effect. You choose the kind of publication. So there we want to publish some software. So logiciel. And then you can either upload a zip file or paste a SWID. So I paste the SWID of my release. You can get the metadata, so you can ask HAL to browse your project to check whether there are metadata files to extract information. I'm not sure. Okay. Yeah, in that case, there was no, it didn't find authors, so there are missing metadata, so it asked to fill it. And furthermore, I won't do it completely because I don't want to publish anything on HAL, but it also verifies the content. And if this SWID has already been submitted to HAL, you will be notified. So if it's a project that impacts different researchers, maybe one of them has already published it on HAL, you will be notified that this project is already published. This software in that version has already been published in HAL. And so a crucial point is to provide the necessary metadata to give the context of your project. So the best way is to provide the metadata files in your repository directly. So you can provide a README file in Markdown or plain text, an author's file, and a license file. All these files will be analyzed and recognized by HAL. And you can also add a codemeta.json file. So codemeta is a standard for software metadata. And if you want to generate a codemeta.json file, so instead of filling the metadata manually in HAL, you can push the codemeta.json file in your repository. And you can also generate it using a small tool that is called codemeta generator. It's just a quick form where you fill all the metadata. You can have an identifier, the code repository, a programming language, the runtime, the operating system, and so on. And then you generate the codemeta file. And time is running. Okay, so this is just a quick presentation of the process of HAL moderation when you deposit some content in HAL. You can also there is a tool called HAL Tools, which enables to get a list of software publications in HAL. So you can use filter for a given research unit. You can get all the publication related to it, specifically for software and so on. So you can take a look further. And so I think we are done with the presentation of source code archival. You will find in the appendix various links to the resources I've presented to you. Don't hesitate to contact me if you have questions or if you need precisions. Are there any questions if we have time?
Thank you very much, Benoit.
Thank you for this very insightful talk. If I did a premature git push and now an API key that shouldn't be there is publicly available and it is scraped by the Software Heritage Foundation, am I screwed forever or can I get it out again somehow?
Excuse me, sorry, can you repeat it? I didn't get it.
So if I pushed an API key that shouldn't be there into my public repository and I want to roll back in time, I want to just rewrite the history.
Okay.
But it is archived the Software Heritage, what can I do?
That's a good question. You can contact us. We have a takedown process. So this is a pretty good example of a cause of takedown. you have some sensible content that should not be archived for good reasons. So you can contact Software Heritage. So we have a dedicated mailing list, which is takedown@softwareheritage.org. And you can require a takedown, and then we will delete it from the archive. The cases are really narrow. We don't delete just because you don't want your code to be any longer there. So if your code, you find that your code sucks because you were a beginner when you wrote it and you don't want to be, we won't suppress code for that reason, because the purpose of the archive is to archive everything. But if there is some offensive content, some personal data, some security issues, of course we will remove it.
And that will also be synced to the mirrors then?
Sorry?
That will also be synced to the mirrors?
So
you said there are mirrors or duplicates?
Yes, we actually, the actual strategy, but it needs to be refined, will be to notify the mirror that we received the takedown notice, because for legal issues, depending on where the mirror is located, it can have some specific regulations. So we notify the mirror, but for obvious cases, yeah, the mirror will also remove the content from the archive.
Quick question.
So a key argument is persistency. And so I'm wondering, what is the visibility of the project? Have you secured funds for the next 2 years, the next 10 years, the next 50 years?
We plan to secure the project forever. At the moment, there is no reason to adopt the perspectives in the middle or long term for the project. At least for the next years, we are sure that the project will be sustainable and funded. So at the moment, we are hosted by INRIA. So the INRIA ensures sustainability, but also by private partners, UNESCO funding, European projects funding. So yeah, the sustainability should not be an issue.
A last quick question, and then you can ask Benoit at the coffee break.
Thanks a lot for the presentation. I searched for projects while you were doing the presentation. I saw my public repository with some project archive, but they are not the most recent one. I was wondering what is the time that where archive are made, what is the, like, cron, let's say.
Mm-hmm.
And my second question is, you speak about webhooks. Did you plan to make GitHub Actions or GitLab jobs to use to post the archive from CI/CD workflows?
Okay, so for your first question, we don't have an exact metric of an exact frequency of the visits. So we use a scheduler. We have a module called scheduler that automatically decides which origins to visit among a lot of different criteria. So all we can say is that it's between a few days to a few weeks, according to the forge, the pace of updates on your project, and so on. So that's also why we have the safe code now that enables you to force the update in a few minutes. And for your second question about webhooks, there should be no blockers to use the GitHub Actions and so on, using the Software Heritage APIs. So you could fine-tune your usage and trigger some API calls to do specific action in the archive for your code. And use Safe Code Now, because Safe Code Now is also accessible through an API. So you can customize your pipeline.
Thank you again, Benoit.
Thank you very much.
Ouais, je sais pas si ça va. Parce que là, c'est plus fini.
Lui, je peux le dégager, lui. C'est ça qu'il faut que je récupère,
Oui.
c'est ça?
Et peut-être. Et si je récupère un portable?
Non, mais je sais pas.
Ah oui, mais je peux. Mais si, il y a du réseau.
Ah oui, bah donc tu peux prendre lui, ouais. Ouais, tu peux prendre lui. Après, normalement, je te dis...
Oui, oui, ben on sait jamais.
Bonjour.
Vous n'êtes pas prévu tout de suite là maintenant?
Bah, j'étais prévu à 10h15, donc on a un peu de retard, mais...
Parce qu'en fait, il y a deux salles.
Ouais.
Oui.
On a deux personnes différentes d'un
Ouais.
corps.
Mais c'est pas fini.
C'est pas filmé, du coup, c'est pas grave.
Les
Non, non,
TP,
c'est un
on a
tuto,
dit
c'est un
qu'on
TP,
filmait
donc...
pas,
du coup, voilà.
Est-ce que vous voulez le poser, c'est ça?
Mais du coup, je vais le poser là. Si tu te mets là.
Franck, c'est votre fauteuil?
Ouais, oui, allez-y.
Tac.
Juste histoire de poser ça. Vous avez besoin de... Ah ben le barcode, vous l'avez. Est-ce qu'il vous faut des plugins?
Ça marche, je vais essayer, puis...
Alors normalement, si vous voulez du c'est un backer.
Ah, de prise réseau?
Ouais.
Ouais, mais si, mais j'ai un adaptateur. Oui, il me faut... Ah non? Ouais.
Ou alors il faut que j'aille vous chercher.
Moi, j'ai du Rome, hein, donc normalement, là, ça marche dans l'amphi. Je pense que j'ai le Wi-Fi qui tournait à peu près.
Vous voulez l'affichage du barcode en fait.
Ouais.
Donc pour l'affichage du barcode, il vous faut peut-être le plugin. Il faut que j'aille vous chercher une clé USB avec le plugin.
Ok.
Je vais le chercher.
Ouais, hier, j'ai testé hier soir, il se passait un truc, mais bon, on verra. Non, hier, j'ai essayé de le brancher.
Ouais.
Et il m'a demandé, enfin il s'est passé quelque chose, c'est-à-dire il m'a demandé l'autorisation.
Oui, alors ça, oui.
Peut-être que.
Ouais, ça, oui, il faut absolument que voilà, il faut accepter en fait
Donc ça, je
le
l'ai fait hier,
branchement.
donc normalement ça doit être bon, j'imagine.
Vous avez fait le test hier?
Ouais, hier
Il
soir.
fonctionnait?
Ouais. Bah, l'écran n'était pas allumé, mais
Ah,
j'ai eu
d'accord.
le message.
Et est-ce que lui, c'était
allumé, ouais.
il était blanc?
Je
Enfin,
sais
blanc,
plus.
il clignotait plus?
J'en sais rien. Je me rappelle plus.
D'accord.
Parce que là, normalement, il suffit de cliquer là, c'est ça, et ça.
En fait, il faut d'abord qu'il soit blanc fixe.
Ok.
S'il est blanc fixe, vous pouvez cliquer et là vous basculez sur ce que vous voulez.
Donc tant qu'il ne l'est pas.
Ouais, mais là, ça veut dire il faudrait peut-être regarder si vous n'avez pas un message sur votre bureau ou quoi, non, c'est bon. Vous
Click
direz.
share. J'ai ça là, moi qui.
Ouais.
Donc hier, moi j'ai cliqué là-dessus.
Ouais.
Share format GUIX.
Ouais.
Donc
Et
je
il
peux
a
refaire.
Normalement, il devrait vous ouvrir. Ah, même si vous n'êtes pas il faudrait peut-être vous connecter parce qu'il va peut-être chercher. Le mieux, c'est que je vais chercher
Ouais, ok,
la clé.
ouais. Parce que là, ouais, il dit préparation en cours quand même, il se passe un truc. Hein. Non, c'est bon en fait.
Alors, si les gens me disent, où est-ce qu'il faut que ça va m'afficher un machin?
Quoi?
Ça va m'afficher. Toi, qu'est-ce que tu veux que je t'aide à faire?
C'est si des gens ne sont pas connectés.
Oui.
Enfin, te guenille un peu à. Voilà, il faut que tu ailles dans Manage, Members, et puis que tu valides leur inscription. Parce que normalement, tu vois, il y en a 49, ils ont tous reçu une invitation.
Oui, oui.
Avec l'invitation, si tu te connectes, tu te crées un compte, tu es automatiquement ajouté au projet.
Ajouter au projet.
Donc normalement, il ne devrait pas y avoir de problème.
Oui.
Maintenant,
Mais
s'il y en a qui
s'il y a un
guenillent un peu à
problème.
se créer un compte, tu vois, qui se galèrent.
Ouais. Là, je
c'est
peux
juste pour
le
les
valider.
Ah, là, c'est
D'accord.
rouge.
Ok.
Alors c'est devenu bleu fixe, puis c'est passé rouge.
D'accord, donc là, normalement, tout fonctionne.
Donc là, c'est bon.
Ok, il faut juste en régie. Alors, attendez. Jérôme, s'il te plaît, tu bascules le barco sur le PC pupitre. Merci.
Parfait. C'est cool. Bah, c'est nickel. Rien de plus à faire.
Alors normalement, vous allez en 206, non?
Ah non, c'est demain.
T'as rien écouté, hein?
206, c'est demain.
Là, on n'avait pas de 206, mais normalement, aujourd'hui aussi,
Ah bon?
on a réussi à avoir la 206.
Ah.
Mais c'est pas très grave, puisque tous les gens qui sont bons en 206 sont censés revenir ici. Donc après, la 206, il faut sortir juste là et prendre à droite.
Et ça rentre à 70
Oui.
dans la 206?
On a dit 140.
D'accord.
On met 140 personnes.
Ok.
Voilà.
Et du coup, c'est
Et
mieux que là.
tu branches et ça marche.
Mais là, ça marche.
Ouais, alors oui,
Oui, mais Marek, après toi, ça va pas marcher.
c'est par rapport au Linux.
Oui, c'est ça,
Nous
tout à
ici,
fait.
ça fonctionne Mac et PC.
Ouais.
Linux.
Ok. Bah,
Donc-
moi, je n'importe.
Donc quand les gens reviennent, vous dites suivez-nous en 206, vous sortez là, c'est à droite.
D'accord.
Ok. Donc,
D'accord.
c'était pas la peine que j'essaye. là.
Voilà, c'était pas la
Ok.
peine.
Très bien. Donc, je vais.
Non, mais maintenant tu es au point.
Mais
Et
du coup, ça marche. On a montré que ça marche.
Avec un Mac.
Pour les Mac, c'est pas de souci. Mac
Du
et
coup,
PC.
Non, mais ouais, pour Marek, ça sera mieux.
ouais, cela dit, après, il y a une pause entre les deux.
Alors, il est possible que quelqu'un vienne ici maintenant, avec un groupe d'étudiants qui avaient pris notre salle.
Ok, d'accord. Donc, il faut s'en aller.
Donc, de toute
faut aller en
façon,
206.
C'est ça, il faut s'en aller, il ne faut pas rester là.
Okay. So,
ouais,
for remaining people in the class, we will leave this amphitheater and go to another one.
Est-ce que vous avez besoin
So,
d'un pointeur?
You will oblige to leave the
Si on a
room,
un,
I'm
c'est
sorry.
bien, sinon, c'est pas grave.
Ok, alors sur le pointeur, il faut que je récupère donc là.
C'est pas indispensable, je peux me passer facilement.
Ok. Sur le 206, vous êtes en branchement direct en HDMI.
HDMI, ok.
Voilà.
Ça, ça marche.
Il faut
Il y a
juste-
un autre PC
Non.
non.
Non. Pourquoi il vous faut notre PC?
Ça m'aurait arrangé, mais je vais en trouver.
Vous voulez garder celui-là?
Ça vous ennuie?
Non, mais non, c'est qu'on n'a pas. Enfin, ça dépend. Vous allez où? Vous allez en 206 également?
206, oui.
Problème. Le tout, c'est de le ramener là.
Peut-être que
Quand
bravo.
on vient ici. Bon, après, je vous laisse. Voilà, il est à votre disposition. Il n'y a pas de souci. Vous avez le.
Ça va m'aider.
Voilà.
Je vais récupérer le chargeur.
Mais je vous en prie. Voilà, mais je vais venir en 206 avec vous. J'arrive.
Puis après, il y a des choses fragiles. Je préfère les tenir bien avant.
Finalement, on devrait être des poulpes.
Ça nous aiderait.
Voilà.
Alors,
C'est bon?
oui, très bien.
Ok. Est-ce que vous avez besoin du pointeur?
Non, non.
Non. D'accord, parce que vous avez la clé qui va avec.
Je vous rends ça, comme ça c'est vous qui avez ça.
Ok, ça marche. Ça marche. ça là. Oui, dis-moi. Oui. Ça marche pour aller sur le barco. Mais parce qu'il y a encore un câble. Il y a encore un câble. Un câble ben, pour. Ah, du coup, ah, là. Oui, d'accord. Ah, d'accord. Oui. Oui, oui. D'accord. Ouais, ouais, bah oui, oui. Non, puis ils ont la solution à côté, donc ça va. C'est pour ça que je voulais. Ouais. Bah, il faudra qu'on se le fixe, mais il serait. Ouais. Plus adapté, ouais, ouais. Je l'ai retrouvé dans le paragraphe. Ce matin, il est. Oui, oui. Ouais. Donc, à force, je porte le coq. Juste pour. Attends, pour. Jérôme de Saint-Maël. Jérôme. Très tard. Jérôme. Je vais monter voir ce qu'il a mis. Ouais, oui, je pense que c'est tard. Sorti. J'ai fait un peu plus en entrée de santé. J'ai créé une réunion. Ouais. On peut se connecter en temps rejoint. Oui. Et on peut se connecter en faisant oui, en direct. Oui, ça rejoint. Oui, tu écoutes. Oui. Ou alors, tu mets juste le mail de quelqu'un, tu lui envoies et puis toi, quand tu les. Jérôme, t'as balancé sur le. T'as laissé tout tourner. J'ai laissé le GUIX logo. D'accord, ça c'est pour le flux streaming. Ouais. Tu as arrêté l'enregistrement ou pas? Non. D'accord. On peut l'arrêter peut-être. Je vais l'arrêter. Du coup, ça reprend à quelle heure ici? Il faut que je me fasse contrôler l'horaire. D'accord. Mais je pense qu'il y en a au moins pour 1 heure parce qu'ils sont basculés sur l'autre. C'est peut-être pas à 14 heures, quoi. Je pense que ça sera 14 heures. D'accord. C'était pas très clair. Je vais quand même demander, parce que moi jamais je fais. Non, mais je pense que tu as une bonne heure. Donc je joue pas le truc, ouais. Je vois si je vais. Oui, alors, sur ce état, en fait, dire que la tablette est allée en direct, elle fait rejoindre la réunion. Oui, oui, non. Et ça tourne l'identifiant et les codes secrets. L'identifiant et code secret de la réunion. Mais tu peux le rejoindre sans identifiant et sans code secret. En direct. Comment en direct? Tu as le bouton rejoindre. Oui. Quand tu t'affiches sur rejoindre, tu demandes l'identifiant de la réunion. L'autre jour. Mais non, mais attends, l'autre jour, quand j'ai fait le test avec Fabien, j'ai juste appuyé et ça a ouvert le truc. Direct. Aller chercher le lien que tu viens juste de créer. Ah, mais j'ai pas créé de lien. Mais t'as pas rejoint la vidéo. Non, t'as juste rejoint une caméra. Non, parce que Fabien, je lui avais envoyé le mail et lui, il a pu ouvrir. Lui, il a rejoint. J'ai envoyé sur son mail le lien Zoom. Ah oui, oui, oui. Oui, en amont, oui. J'avais créé un truc et oui. On parle du hasard, mais moi je te programme un truc. D'accord. Ça marche aussi. Bon, mais il faut. Parce qu'on en a déjà programmé pour les jours à venir. Oui, mais il faut voir que c'est souple. Celle qu'on a programmée. Les tests qu'on a fait, il faudra voir si elles apparaissent sur l'agenda et si elles sont bien. Il n'y a toujours pas là. Non. Oui, mais parce qu'il y avait 70, il y avait cette histoire de 72 heures. D'accord, on la remonte. Exactement. Moi aussi. Mais l'autre chose, en fait, c'est que, par exemple, oui, on a, mais c'est après, c'est en novembre, fin novembre, on a des trucs en 206. Je crois, de mémoire. Sinon, après les premières, les thèses et tout, c'est début décembre. comme j'ai fait moi. Quand j'ai créé sur mon portable, il y a oui, tu devais être dans cette salle. Toi, t'as réussi à t'établir un plugin parce que voilà. Je vous ai vu là, je me suis dit, je préfère vous le répéter. Après, sur ton profil, tu l'as affecté la salle 206. Non, je l'ai pas suivi le mouvement. Il faudrait que tu montes parce que il y a des trucs. J'ai pas trouvé un justement. Sur mon. Ouais. Oui, il faut juste que je monte pour voir où est-ce qu'il en est là-haut. Il faut que j'arrête l'enregistrement. Je ferme la régie, il faut que j'arrête l'enregistrement. Ah, Guy. Hier, tu leur avais filé un pointeur. Tu leur as pas filé le pointeur, toi? Alors, c'était quelqu'un qui avait son pointeur à lui? Sûrement. C'est le mec qui avait un pointeur et après, ils se sont passés les uns les autres. Non, mais c'est toi, moi j'ai mis, c'est toi qui l'as fait. Le PC pupitre. Ouais. Oui. Oui, et là, donc, en fait, moi, quand je suis arrivé à faire ça, comme je les ai vus utiliser le pointeur, bon, il faut que je vois ça dessus. Et après, je vais sortir. Peut-être en bas alors. Parce qu'il y avait ça là. Vous attendez pour la session le workshop là. C'est la session 1. La session avancée normalement. Ben non, il y avait une session ici et l'autre dans une salle qui est au fond là. Vous êtes venu à la pause café. Vous avez entendu l'annonce du coup qu'il y a, enfin je sais pas, il y a, je sais plus comment il s'appelle, mais il y a deux personnes qui ont mis deux groupes, qui sont partis avec deux groupes séparés, vous avez vu ça? Ah, et du coup, la personne qui est venue avec le groupe... Ah.
Je crois que...
Parce qu'ils n'ont pas l'air d'être là, ouais.
Je pense qu'ils ne sont pas tous d'accord sur la salle.
D'accord, attends, parce que je crois qu'il y a des...
Il y a un accès ici?
Je sais pas, ouais, je pense. Je crois qu'il y a une salle dessous, en fait.
Benoît. C'est pas dans cette pièce. Hein. C'est pas dans cette salle, le tuto.
En anglais?
Sorry, it's not in this room. The tutorial is in the room just next door. 206.
206?
Yeah.
J'arrive, je l'attends.
Oui, c'est pas ici.
Non, c'est pas ici. So, twice on the right.
Je vais rester là jusque dans l'après-midi.
Oui.
Je devrais partir en début d'après-midi, mais je vais rester pour le déjeuner.
Oui. Oui, je pense qu'il y a des questions qui sont restées en
Bah
suspens.
oui,
Hein, ça a été
normal,
un peu
hein.
court la séance de questions
Bah,
de
c'est
notre
le timing
côté.
qu'on a.
Oui, très bien, c'est parfait. Non, c'est notre faute. Enfin, c'est notre faute.
C'est des aléas.
Oui, on est obligé d'attendre un peu que les gens arrivent.
Ah oui, c'est ça.
C'est pas facile d'arriver ici finalement. En fait, du centre-ville, je pense qu'il y a pas mal de gens qui ont
Bah
fait
oui.
des hôtels au centre-ville.
Bah moi je suis venu à pied en fait.
Oui,
À pied c'était 25 minutes et en bus ou tram c'était 33 minutes.
oui.
Donc avec les aléas, je me suis dit bah.
Oui, c'était bien.
Enfin, c'était 25 minutes en tram et 33 à pied. Je me suis dit moi à pied je suis sûr
Oui,
d'arriver.
mais on a failli en fait ce matin dans le bus, on était à l'arrêt, on s'est dit bon qu'est-ce qu'on fait, on descend et on finit à pied. Voilà, très bien, et ben à tout à l'heure alors.
Ben ça marche, à tout à l'heure.
Du coup, ça reprend ici, on reprend la captation, le streaming.
La captation, je pense que c'est pas nécessaire pour le but, c'est des TP.
D'accord. D'accord, ok. Et là, c'est jusqu'à la pause de midi.
Je sais pas si on changera de salle au milieu, ça dépendra.
D'accord. En tout cas, au niveau captation, c'est des TP jusqu'à la pause de midi. Donc la captation reprend à 14h.
Ça marche, ça ou pas? Allô? Oui. Tac.
Ouais, le collègue, ça fait qu'un mois qu'il est là, donc je sais pas.
C'est toujours compliqué, là, c'est jamais pareil en fonction de la salle. Là.
Ouais, moi, ça fait 16 ans que je suis là, donc je connais toutes les installations. Je sais ce qui marche et ce qui marche pas. C'est un peu emmerdant.
Ouais, c'est comme ça partout, après, faut... Ça marche. C'est bien.
Avec le marteau, pas de souci.
Tac. Quoi? Je vais faire un peu vite. Quelle heure il est? 11h. Ouais, normalement c'est bon, on m'entend là dans la salle, oui. Je vais me rapprocher un peu. Hop. Oui, non, mais c'est bon. Merci.
Je peux essayer de raccourcir un tout petit peu. C'est chaud.
Ouais. Wow.
C'était une question.
C'est une réponse. On verra, ça dépend s'ils sont déjà super forts en intégration continue. Je pourrais faire des sondages, tu vois, pour voir comment... Alors, tout va bien? Okay. Good morning. Sorry for this little delay. We'll start this tutorial session on how to set up continuous integration in your GitLab projects. Okay, do you hear me properly? Yeah? Okay. So this morning we are going to talk about GitLab and continuous integration, as said the title. So I assume that you're quite familiar with this tool and that you know what are projects, what is GUIX, what is Git, sorry, not GUIX, what are groups and so on. If not, it's still time to move to the other tutorial on the background. I will talk about continuous integration, and I will also take the opportunity to speak about some other features that I think are interesting. I don't have a clue about your background on this topic, so maybe that will be a bit boring for some of you, or maybe too fast, I don't know. In any case, please ask me during the presentation if you have some questions. You can keep your questions for the end, but you can stop me if you want to ask some things. I prefer if it's a bit interactive. So let's go. I will, during this presentation, since it's a tutorial, I will switch between my slides. This slide with an introduction about CI/CD and some focuses on some specific topics, like registries, workflows, and things like this. And sometimes I will switch to a GitLab project to show you some demos. The entry point for all these things is this web page. So please copy this and keep it in mind for the rest of the session. There is a web page with the introduction, with the presentation of all the stuff for this tutorial and the other tutorial. You will find the slides. You will find a place to practice, a sandbox. You should have received an email that invites you to this group. Some of you are connected, I think. You will find some other materials and the demo project that you can use after the tutorial when you will back at home. You will be back at home. So this place to experiment is. Feel free to do anything you want in this group. It's a place where you can try everything. You can make some errors. You can delete things. It's not a problem. And this group is where you can find things after. Try to let all the tutorial with some comments so that you can reuse them after to be in a reproducible in the reproducible way. Okay, so let's get started. These are the prerequisites, so hope it's okay for you. And today I hope you will learn how to set up a CI in a GitLab project. Maybe first, are there some of you that have never heard about CI or that have never tried to write some CI scripts? Just to know, please, hands up. Okay, so much of the people are aware of CI and have already written scripts. It's good. I will try to give you some advice, to show you some examples, and to give you some project that you can take away and reuse after to understand all the stuff. Okay, so let's start with a very simple use case that maybe you know. Let's suppose you want to publish a website, to create and to deploy a website. If you want to do so, you have to provide the HTML file, to write some files and to produce a HTML file. Then you have to copy them somewhere on a server. You'll probably have to ask to some IT guy the authorization. You will have to ask for the opening of the server, to open some port, to give access to the world to this server. It's not very complicated, but it's a bit boring for you, since each time you want to change something on your website, you will have to ask him to change things. You will have to redeploy things. With CI, the idea is that you remove all the stuff in the middle. You just do your job. You write your files. You give this to GitLab, and at the end you enjoy with the result, which is your website. This is the point of continuous integration. It's automate a lot of actions to provide you with a result. This is kind of summary of what I've just said. You can find on the right your work. You write some Python code, C++ code, some text files, some anything, and you want to get the result on the left with test reports, web page, Shiny app, whatever. And in the middle, that's where continuous integration takes place. You put your files on the GitLab project, and you get the result in the end. A more precise definition of continuous integration is the idea, the practice of systematically and automatically check the result of any modification in your Git repository, in your sources. So it means that you change something, then some operations are launched, and you will get an answer that tells you that okay, it still works, the performances are still okay, or no, there is a problem. That's the idea of continuous integration. So it's a GitLab project, some scripts to run the test, and a push that triggers the action, and finally a report generated and published. But I think it's much more than that, because this was the origin of continuous integration, mostly dedicated to people working on softwares. But it could be much more, because it's quite easy to use. And in the end, you can use it for many other different practice, like to get to the idea of associating with each modification a sequence of operations that you define, and that will be carried out automatically each time you modify your sources. So it could be the example I've shown you just before with building a website, generating some PDF files from LaTeX or other things, deploy a Shiny or notebook application, and so on. Continuous delivery is quite the same thing, but it's just what takes place at the end of the process when you want to automate the deployment of software, for example, or to provide end users with some ready-to-use images like Dockers or things like this. It's the deployment to production of your environment or software. So why should you use CI/CD? I think it's quite obvious, but I put some ideas there. The point is that to help you to identify and fix some potential problem in your software, to have a log of everything, of all the actions that are run when you modify something. You can ensure that the changes in the code won't break what the software is supposed to do. So you end up with a cleaner, more stable, more portable code. It will help you also to anticipate some specific contexts, different environments, different parameters. You can try many different contexts of working. It will help you to deliver and to deploy some ready-to-use Docker-like images, as just said before. And finally, it will make some happier developers and users, and it will help you it will be a good step to provide a software reproducible, I think, with good quality, and it will free up a lot of time for you also. It's a bit of work at the beginning because you need to prepare the CI and to write things, but when it's done, you will free up a lot of time and everybody will be happy with that. So, concretely, what is CI? CI, the central point of CI is what we call a job, which is a sequence of operations that are to be executed each time you modify your sources. Each job is independent of the others, so and each job has its own context of execution. Context means a set of parameters, a specific operating system, whatever. On the other side, you got a runner. A runner is a machine that will host the execution of the job through an executor like Docker or some other things. And the idea is that you got your runner, which is listening to what's happening on your GitLab server. The runner will watch the activity of your project or your group, and each time an action is a push is done on the server, the runner will clone your project and launch the operation you ask him to do. Okay. So now, I'm sorry, I'm a bit fast because Céline asked me to shorten my presentation. So now, how to set up the CI. The first step is to create a .gitlab, .gitlab-ci.yaml file at the root of your GitLab repository. Once you create this file, CI is on. So if you push something on the server, it will start. In this file, you will list all the tasks, the jobs that you want to be executed by the CI. So it's what, where, when, in which context, and so on. Then you need to define and register some runners, the hosts for the jobs. We'll see that in details later. And finally, you need to write things. That's the most complicated point. You need to write in YAML to describe the job in this GitLab CI YAML file. There are many templates. The documentation of GitLab is quite good, so copy things and try them. It's the best way, I think, to make it work properly. A bit of vocabulary just to be sure that everything is clear. Donc first job, you should have understand this now. It's a sequence of actions that will take place, that will be executed in a specific context on a runner. Each job is independent from the others, and everything will be removed at the end of the job. So you launch things, operation takes place, and then it's removed, except some specific things that will be defined in what we call artifacts, which are directories and files to be kept between jobs, and that can be transferred between jobs. For example, imagine that you have configure steps with the result of a CMake or configure things. You want to keep the build and send it to another job, which is the place where you will run make, for example. These are artifacts. You got the runner, so I've already told things about this. You got the executor, which is the program that will run your script on the runner. You got the idea of pipeline. Pipeline is a sequence of jobs, potentially parallel. Pipeline is more or less a commit. Each time you got a push, it will launch a pipeline, and there is only one pipeline per commit. And in this pipeline, you can have different stages. So, for example, a step with configure, make, CMake, and so on. Make, install, and so on. So let's start the demo to see how it works. So this will take place in this group. I show you. Yes, just one thing. You should have access to this sandbox things where you can do whatever you want, and you have access to this materials and demos group with this project. Which is it big enough, or do you want me to increase it? No. This is the place where I will put my demo and add things step by step during this session. And there you got the 1 and 2 tutorials, which are the final results. So you can try them after if you don't have time to do it during the session. And you can fork this project into the sandbox group if you want to try it now. Okay, so demo is there. Just a word about something that I think is quite interesting. It's not CI, but it's a bit of related with, because it's GitLab. It's the API GitLab that I use to add all of you into the group. So GitLab API is a way to interact directly with the GitLab server through an API. You can use something which is called Python GitLab package. So in Python, you can connect to the server, connect to a group, to a project, and automate some actions with some Python scripts. So it's very useful, I think. I put a project which is called GitLab API in the group, so you can use this project if you want, just to learn the basics of this API. The point is that you need to create a personal access token, just that will be used to check that you are allowed to connect to the server and to use the project. And then you can use some scripts to register, to control your project, add people, whatever. It looks like something like this, for example. So this is Python. I just connect to the GitLab server I use, which is GUIX GitLab. Then I download a group with its ID, and I can operate on this group. Like there, I just send you an invitation with your email. I give you some type of access and a date of expiration. So with this, you can automate things, and I think it's quite important to know this interface because it's very useful. Okay, so let's go now to the continuous integration with a very simple job. So a job is just something like this. You got a name of the job. Only you got, and then you got keywords where, for each keyword you describe some parameters. The most important keyword is script. With script, we list the actions that are to be executed during the job. So, and that's it. We can just try this thing just to see how it works. So this is the tutorial demo. As I told you, I need to create the .gitlab CI.yaml file. I will do this with a specific editor. Here you got this build menu with all the things concerning CI, pipeline, jobs, editor, and so on. We'll try the pipeline editor. So I want to create a new CI. Okay. It proposed me a default template, but I won't use this one. I will use the one I propose. So here, I just put one job, which is named my job, script keyword, indentation is sometimes important with YAML. So, okay, the interest of this pipeline editor is that there is an automatic control of what you write. So you can write things, and then you can try to visualize what's happened. So here you can see that there is only one job. You can validate, just to try without running it. So it seems that everything is okay. And then I can commit with the edit. Okay, message, I commit change. And the continuous integration starts. So we can check with pipelines there. Okay, we got the pipeline. So we find the pipeline corresponding to the commit number in the main branch. I was the creator of this pipeline, and this tells us that everything went so well. We can have more details by clicking on the pipeline. We find all the jobs, and we can click on the job, and there we have the log in the some kind of terminal session where we can see what's happening really on the runner. So it starts a runner, which is I don't know, it's this workshop runner. I will explain you later where this runner is and how it works, but it's some runner. It starts a Docker image. We'll see that later also. And then it clones the repository and execute what I've asked. So ls, who am I, and so on. You can notice that I'm root on this thing because it's a Docker image, and okay, everything is okay. The job succeed. We can relaunch it here. We can delete it. We can see the other jobs if there are some, and that's it. Okay, it's okay for you. Okay, let's go to something more interesting. We'll try to do the use case I showed you before with the production of a PDF file and the production of a website. So now I will add another step in my GitLab CI.yaml. I put some templates into the repository. These are all the steps for the demonstration. Yeah.
Is that for us to watch, or shall we follow along?
You can watch, or you can try it in the sandbox if you have time to do. It's as you want. I'll try to comment, but I think we don't have enough time to do everything, and I cannot go and answer all the questions. I think because you're too numbered. But you can try it. If you are already okay with continuous integration, you can try the templates and run them. But I will keep this open for a few weeks or months, so you will have time after if you want to try. Okay, so second step, I will add this. No, not this one, sorry. So for this second step, I will try to produce. No, it's not this one. Sorry. Okay. I launch it, and then after I will comment. Okay, so there. I've added three jobs. First job is something to create a PDF file from some text files. So I keep this script keyword. I ask to run PDF LaTeX on my tech, and I ask to move the result into some docs directory. And I add this keyword, which is artifacts, to ask to the job make PDF to keep some things, only the PDF file, and to keep it for 1 week, and to keep it available for some other jobs. okay? And then I write a job which is named pages, and there I tried an image. I will get back later to this image, where I asked to run some tool which is called mkdocs, which is something to provide to build HTML files from Markdown files, whatever. It's not important. In the end, I will have some HTML files saved in a repository, a directory which goes public, and I keep this public in the artifact. Okay, let's have a look to the result of this build. It's running. So now you can see that we have 3 steps: the my job steps, which was the first job we asked for, the make PDF job with the LaTeX thing. It's still running, and we got this paging which is waiting because. For the simulation, I added, no, not this one. I defined some stages, 3 stages: prepare, build, doc, and to each of my job, I attach a stage, which means that the job will take place in this stage, and all stages are executed sequentially. So it means that you can't have a job starting in the build step if some job failed in the prepare step, for example, okay, by default. But you can change this behavior by using the keyword needs here. Needs means that you will have a dependency relation between jobs. So if I put this, I tell the CI that to run this job, pages needs make PDF, so it will never start without make PDF. But I also tell that if some other jobs in the previous stages that are not in the needs fail, it's not a problem. It can start this pages job in the stage doc. Okay. Let's have a look to the results. Yeah.
If you specify the same job
sorry. Can you say again?
If you specify same job name multiple times, the last one wins?
No, you cannot specify multiple times the same name for a different job. So it will fade.
You have that in that file?
No.
My job is that file.
C'est vrai? Ah oui. So it's an error. It's a mistake. Okay. I think.
Is it because it's different stages?
No, I don't know why it's that. It works. Maybe it's because it's after stages. I don't know, or because I forgot to commit. I don't know. I don't know. But no, you can't have 2 times the same name. Okay. So it's quite long. I don't know why. Okay, let's wait. What some other comments? So that's okay. The needs. Okay. Do you need a word about Docker? Are there some people who don't know anything about Docker? Or please tell me. Okay, so just a few words about Docker while the thing is running. So Docker is some kind of open source platform used to create some virtual, it's not really virtual, but you can see that as virtual environments to run some applications. You have something which is called an image, which is some kind of definition of a system. You download this image, you start this image, and it provides you with a container, which is a lightweight environment, execution environment, where you can run things. Just like here, you can see this. In my script, I put the keyword image. I ask for this Docker image, which is something created somewhere by somebody, but that embeds LaTeX and all the tools I need to create my PDF. And there, the CI script download the image, start a container an instantiation of this image, and run things inside the image. Okay, it's okay for Docker. Okay. Right. So here it works for the PDF file. And what is very interesting is that independently of CI, you can use Docker on your laptop to start some environments which are not the basic OS you use usually. For example, I can try Ubuntu, Debian, whatever on my Mac, on my MacBook. So it's very practical to try some specific environment, and it's available as an executor in CI. So you can use any image of Docker and try your software inside this image. So it works like this. When you have you can have some things that are called registries. Registries are places where images are saved. It could be the standard one is Docker Hub, which is public with some available images. But you can have registries associated to your group or project. We'll see that later. Anyway, when you start a job, when there is a push, you start a job, the runner clone the job, the runner start Docker image, download the Docker image, start the container, and then run the job inside this container. Okay, and that's it. Last step of this first part of the demo is we want to build and publish some web pages. It's very easy with GitLab CI. There is a tool which is called Pages that you can use to provide some static website, public or private. You can choose, and you delegate the publication of these pages to GitLab. The procedure to do so is just choose some site generator like Pelican, Sphinx, Memcadocs. There are lots of them. Something which is able to generate HTML files. You save your sources into a GitLab project, and you write a job named Pages, like this. Pages. And in this Pages job, you ask CI to create your HTML, and you save it in a public repository, and you keep this public available with artifacts. And then, if you try this. If you have this Pages job, GitLab will automatically create a Pages deploy job, which will take this public repository and put it on the GitLab server and make it available to everybody or to a limited amount of people. You can use settings, general, features here, to choose who have access to your pages. So here it could be only project members or everyone. You choose if it's private or public. Okay, I can put it public just to check. And once it's done, you got in the deploy menu, you can find pages, and you can find the address. You can find the address of your website there. And if I click, it fails. Okay. Why? I don't know. I can try to start it again. I've got several ID opened at the same time. That's maybe the problem. Okay, this one is okay. Stages, blah, blah, blah. We'll add this. I'll command this just after. Just notice that I create a commit with some specific keyword. Fail. Okay, I missed that. I think I put stage doc. This is a demo, so I have to make errors. Okay, so it's running. Same thing as before. Let's wait for it. And okay, so it's pages. Okay, about this you will find the complete project with comments in this project, which is number 1 I've shown you before. About this rules keyword. In fact, CI is quite easy to set up, so it's very easy to write things with a lot of jobs, and you launch each time you commit something, you start a lot of jobs, you ask for many resources, and I think it's important to pay attention to the footprint of this action. And the best practice is first to think when you write things, and then to add rules to run only what is really required, really necessary. To do that, you can use different ways. First, you can control the CI with the commit messages. There are some default keywords like skip CI. If you put this skip CI in your commit message when you commit with Git, CI jobs won't take place. It will be stopped and nothing will happen. So imagine that you just change something which is not important. Use this to avoid the execution of many jobs. This is the first way, and the second way is to add some rules in the YAML file where you tell run this job only when these things happen, or you can add things like run it when somebody click on the interface, run it every Sunday. I don't know. You can put many different rules. The syntax is this one. For the job, I just tell that if my commit message contains this string publish, then the job will be executed. If not, nothing will happen. So you can choose rules per job, or you could choose general rules. We'll see that later for a bigger project. I think it's very important to do this and to try to avoid useless things. And the syntax is if something happens, then you put the keyword when. Here it's always, and if this is wrong, it steps to the next stage, and in any other case, no publish, then nothing happens. Is that okay? So the page is okay. Let's have a look to the results. It fails. I don't know why. It's supposed to work, but believe me, it works. Okay. Okay, let's go back to the runners. So a runner is the host where the job will be executed. Its job is to collect things and to run CI tasks. There are two kinds of runners. First, shared runners, which are runners available for the whole server. It means that if there are some, it's not always the case, but if there are some, the runner is available for all the projects and the groups saved on the GitLab projects. For GitLab.com, you got some available runners, for example. And there are some self-managed private runners, which are linked to a single group or a single project. So it means that you can choose any machine you want, your laptop or a server in your lab, and declare it as a runner for your group. Okay? The only important point is that you need to install some specific tools, we'll see that, and to connect the runner with the GitLab server and to your group. Okay, you can have as many runners as you want for your group or your project. You declare them, and they are all listening to the activity on the GitLab server, and they will query things, and if something happens on the server, then one runner will pick the job and execute it. So it means that your jobs could be dispatched on many different runners. Okay. So I've already said that. It's cloned. Report is sent. The artifacts are kept, and that's it. I don't know if I have time. Yes. We'll see how to install a runner. So to install a runner, you need first to find a machine which is available. You need to install a package which is called GitLab Runner. It's quite easy. For the standard distribution, you just have to run something like apt-get GitLab runner, and that's it. The documentation is very easy to find. Then you need to ask for a new runner in the group. You can try this with the sandbox group, for example. So here I go to build runners, and I ask for a new group runner. So I choose Linux system. You can add some tags. It means that if you put tags on your runner, it means that you can specify the tag keyword in your job, and these jobs will be run only on that runner and not on the other runners. It might be useful if you, I don't know, for example, if you have some GPU jobs, for example, and you want them to be run on a machine with some GPU cards, you can add this tag, and this job will be dispatched on this runner. Here I want something quite generic, so I use run untagged jobs. This runner will be able to run anything, and that's it. I could put a description, but I don't care. Up. So the runner is created. It means that GitLab, the group, is aware of this runner, but nothing has been done on the real machine. So on the other side, we need to run this thing on the runner to tell him, okay, this is a runner. This runner is linked to this group. This is done thanks to the token which is there, and then this runner will be able to pick jobs. Let's try it. I need to connect somewhere. So I connect onto some machine. More or less long. Okay, and then I execute this thing, and that's it. Then it, yeah, that's not really it. It asks you for the GitLab server name with a default value. It's okay. It asks you for a name to the runner, and it asks you for an executor. So here you have to choose how jobs will be executed on the runner. The default habit is to use Docker, but you could use shell or other things. Shell means that the jobs will be executed directly on the runner without any virtual environment. And then you can, if it's Docker, you can choose a default image. It means that if you don't write the image keyword in your job, this is the image that will be chosen. Okay, so now it's okay. So if I go back to my project, I can see that this runner is there. Okay, it's online, it's running. And now if you launch jobs on the sandbox, in the sandbox groups, jobs will be executed in this runner. You can set many different things, like you can choose if you enable shared runners or not in the group. You can choose things at project level, for example, for this one. Let's choose this one. Runners. Here you find the runners. Shared runners are disabled, so it means that jobs will be run only on the group runners available for this group. There are two of them, one which is off and the other one which is available. There are other groups runners here which have been declared at the top in the top group at the top group level. Anyway, you can declare as many runners you want. They could be totally different with different OS, and you could choose different executor on each runner. So it's quite easy to use, and you can end with many different way of running your jobs and choosing some context. Okay, is that okay for this? Right. So now we got a project with CI. We got different runners available and ready, and I think it's okay for the basic keywords to know and to understand to run CI, like image, artifact, scripts. So now let's turn to something much more interesting than generating a page, a web page. I'll try to show you real software with the standard things you need or you want when you work on the software, which are, for example, to configure, build, and test the software, like CMake, make test, for example. Normally, you want to try it for different systems, like Linux systems or Mac systems or even Windows system, why not? You can try different parameters, different configuration, like debug mode, release mode. You can choose different way of making your software work. This is the development part. You may also want to provide things interesting for your users, like generate documentation, publish software web page. You can want to control and automate release publications, as that was said just before during software heritage talk, and so on. So we want to do all these things. So to do that, I've put in the project, still always the same, this one. I've put a lot of files, like CMake files, some code with the C++ and Fortran code. I've put some Python code, many different things. It's not important. The point is that you got a CMake stuff to configure your software. You got make stuff to build it, and you got make tests, some tests that could be run to check if everything is okay, and make install to install it, and make doc to produce a doc. So we can download this, execute it locally, and have a result. The idea is to ask to CI to do this for you every time you push something, and to do this in different contexts. Okay, so let's start with what time is it? C'est jusqu'à quelle heure? Hein? Midi. Ok, midi et quart. On a commencé tard. Hein? À midi 12. Okay, so let's go. So I will step directly to this template. Okay, so for this first example, I will, no, not this one. This one? Okay. I launch the CI and then I will explain you. So I need to modify my GitLab CI. Okay. Hope it works. So there. I produce many different jobs. So first job is something to configure my soft on Ubuntu server. So I give a name which is Ubuntu configure. I ask for a Ubuntu 22 image, and my script is just run this thing, which is the script is there. It will run a CMake with some specific environment variables that defines the place for the source dir, the binary dir, and the configuration file, debug or things like this. It's not important. The point is that you need to launch this with these variables to configure your software. This is the first step. I ask some artifacts. I ask for some artifacts. I want to keep the build where the result of the CMake is. Then I define the second job, which is build, where I run make. Indeed, it's hidden in this script. I still want to keep the artifacts, and there is a last job, which is test, where I want to run make test. Okay, 3 different jobs. I did the same thing for another config. It's still the same image, but with another input in another set of parameters. So same OS, but different parameters. And finally, I try another pipeline with another OS, Debian, and with a set of parameters, and I do still the same thing. It's config, build, test. Okay, so there I've got 9 jobs. We can have a look to the pipeline. Where is it? Build, pipelines. Sorry, it's running. You can see that we have the 3 different stages. You can click on stages, configure, build, test. I declare different runners, so there are different jobs that are running at the same time. It's okay. I can have a look to dependencies, because here I use the needs keyword here. Ubuntu jobs depends on Ubuntu previous jobs, Debian jobs on Debian previous jobs, and so on. But each line does not depend on the others. I mean, this job just depends on the previous one, this one on the others, and so on. So here it's working. Okay, should wait a few minutes. One thing which is important is that on all these systems I need some specific tools like CMake or Boost or some libraries, and I need to install them on the default Docker image. To do so, I use this before script keyword with some specific command to install some dependencies like CMake, Fortran, whatever. And this means that each time a job is started, this command will be run, okay? Which is not very smart, but we'll see that later. So the point is that for all our CMake and make and so on things, dependencies will be available and it will went fine, okay? Just wait a few minutes. Sorry, it's okay. Debian test. So imagine you have this just for your software. You push, or somebody push, somebody who works with you. You just have to check this page to see that everything is okay or not. So it's very useful, I think. Okay. Here is for the first demo. What is important there? Okay. Yes, I use variables. This keyword variables in your CI script. You can use some predefined variables, and you can define your own variables. There are a lot of predefined variables by CI, by GitLab CI. If you want to see them, just add this dash env command on your job, and you will see the list of all variables. You can find the name of the guy who has made the commit. You can find the name of the branch. You can find the ID of the commit. You can find the name of the main repository, which is CI project here. You can find many interesting things, the date, whatever. So you can control the way you run your jobs. And you can define your old variables. It's like environment variables. It means that they will be available in the script, in the CI script, and they will be available in the container, the Docker container. Okay, so you can do many interesting things by using these variables, and you can control quite accurately the way things work. Okay, I think it's now everything went fine. It's good. This was a word about CI/CD variables. Okay. In this demonstration, two things are quite annoying. The first is that we need to execute this for each job. So it's kind of testing the apt tool, which is not what we want. We assume that Debian or Ubuntu works fine. So we don't want to do this each time. And we repeat almost the same things for all jobs, so it's not very interesting. So to change this, we'll use two things. First thing is templates. You can define templates in your GitLab CI scripts. So templates are just things that you define, and you can apply them to specific jobs and reuse things. And we will try to build our own images. So the idea is that we'll start from a Docker image. We'll add in this Docker image what we need, and we will save this image into our project. So it means that next time when we want to start a job, we will use this image, and we will just test our software and not the apt stuff and so on. And it means that we can use other systems that do not depend on apt, like Fedora or something else. Let's do this. Up. I think it's so to have templates, we need to define a specific file. As before, I will just launch it and then I will comment it. So to do so, I create a specific file, CI templates. You can name it whatever you want, but I use CI templates. Okay. and I will change my GitLab CI file. Is it the good one? No, it's not the good one. Okay, so let's comment it now. In this CI template, I could define all my templates and all the common things for all my jobs. For example, I can use some global variables. It means that this variable is available for all jobs and will be available in all Docker images. I can define all the stages, and I can use these keywords starting with dot and some name. So this means that this is a template, it's not a job, and I could define later a job like this one with the keyword extends, which means that this job is based on the template which is named soft.soft something, and it means that all the things that are defined in the template will be applied to the job. Okay. Here, for example, I define some specific variables. I put the scripts, and I ask for the artifacts, which are all the same, whatever the operating system or the Docker image is. So I create, and you can put templates in templates. For example, here, this is the basic template, and there I use the configure step to define, starting from this one to define the configure. I use the build template and so on. So you can define as many templates as you want. Okay, and there in the GitLab, in the main YAML file, I include the template file, and then I create all my jobs, which are much shorter than it was before, with some specific variables, the name of the image I want to use, and I think that won't work. That was not the good template, but whatever. And the template I want to extend. Okay. So it means that this time it will be exactly the same, but the writing is better, I think. Second point was the problem of trying APT at each job. So to avoid this, we are going to build our own images. To do so, we are going to use something which is named Canico, and we are going to ask to GitLab jobs to build the image, to save it in the specific registry of the project, and then we will ask to our other jobs to start from this image and to execute things. To do so, I will just change my template. I think this is this. Well, I'll take the last one because. This one is a bit longer. So I add this this template, which is here. I named it Docker create image. To use this, just copy paste, because it's just like this in the doc. Don't try to understand everything. The idea is that you start a specific image in the debug mode. That's what the documentation said, using Canico. And this will start some kind of Docker in Docker. So it will start a Canico things that will get a Docker file, build the image, save it, and push it into the registry of GitLab. So here, the important thing is that you give a Docker file. This Docker file is there. I add inside my, my repository some Docker files for different distributions, like Ubuntu, for example. There you can find the Docker file. It means that when a job will be executed with this Docker file, an image will be produced, and with the installation of all these extra dependencies. Okay. So this is a template to create Docker image, and I add a specific rule because I don't want to build Docker image at for each push. So I ask for a specific behavior. I told GitLab that I want to build Docker images each time there there is this Docker build keyword in the commit message. You can add some other rules like do the job each time the Docker file is modified by somebody. For example, it's possible to add this, there is a changes keyword in the rules to ask for a very specific behavior. You can check this in the documentation. So here I got a Docker build template which asks for the creation of a Docker image with these rules, okay? Let's go to the YAML. So I need to I add 3 jobs, which are Docker build jobs, where I ask to build Ubuntu, Fedora, and Debian. So I will have after this 3 images. And if I commit, and if I add this Docker build keyword, this job will be added, I hope. Let's go to the pipeline. No. I did not commit CI templates. CI.templates. Ah, j'ai mis un. OK. Merci. Hop. So you can see that each time you get a syntax error in your YAML file, it fails at the first step. Okay. Go to the pipeline. So now it's running. You can see that there is an extra stage with the building of the Docker images. Okay. This one fails because I forgot to add the need things, but for the where is it? Here, for this job, I ask to GitLab to pick images in CI registry image which corresponds to the registry of this group or this project. And since I haven't run the job Docker before, the image is not yet available. So we'll need to wait for these jobs to be finished. And once this will be done, you could check in the deploy package registry menu and find the images. Maybe I can show you in another project, for example, this one. Here you can find all the images that have been generated by the CI and that are available. They are available for your jobs, but you can also load them on your laptop. I can try this. There, Docker pull this image. I can get it and try it locally. So it's a kind of a library of images, and it's quite useful. So there you can save some ready-to-use images with all the dependencies for your soft, and you can test it against these images. That's it for images. We'll wait GitLab to finish. I won't talk about this. Yes, about CI workflow, you could. We have seen some rules before to control what's happening when you at the job level to avoid unexpected behavior. You can add a default behavior for all the jobs using the workflow keyword. Where is it? Here, it's a quite complicated workflow, but I will try to comment it quite rapidly. The idea is to take into account that when you use Git or GitLab, you have a workflow. It means that there is a main branch, there are some branch for people who are working on specific features. You should use merge requests, you should use issues, you have to work in some specific, you need to have some method, and you need to organize the way you work on your GitLab project. And if you let it like this and you don't tell CI anything, each time somebody is asking for a merge request or somebody is pushing in some branch which might be not important, all the CI stuff will start. And with this workflow, you can specify some rules to ask for specific behavior depending on who is doing what and in which context. Here, for example, I tell that when the pipeline is a merge request, I don't want to do anything. here I asked that when it's an somebody open a merge request, I want to launch all the CI, and so on and so on. This is the default behavior, and you can overwrite this behavior with some job level rules. You can have a look to this later because I think I'm running out of time. Anyway, it means that if I can try this with this specific, just change things. With this this workflow and these rules, if I create a new branch, okay, this will start the CI, but only for the Ubuntu pipeline, not for all the others. Where is the pipeline? Je sais pas, une petite demi-heure? Mais en 10 minutes, je sais pas, 10 minutes, non?
5 minutes, c'est possible?
Bah, oui, mais ce sera incompréhensible, mais oui. À 13h, c'est ça? Ouais. Bon, ben, ok, moi, je vais sauter directement. I will step directly to the end because I can show you this in the final project which is available here. So here, this is the whole pipeline, for example, for a specific branch. This one. No, I haven't got a branch. Oh, let's comment. I will just comment the files. Okay, so the keyword. The last step was the continuous delivery, which means that what I want to show you is that how to propose a Docker image with the whole installation of your software and ready to use. And another point was to ask to GitLab to provide a release of your code each time you add a tag, for example, to your Git repository, and how to produce documentation and how to trigger jobs in different projects. So I will try to explain this in 5 minutes. Okay, let's go to the template. In this template, you will find all the workflow with the rules, and these two specific templates in the end, which are templates used to install your software. These templates will be based still on Canico. You will ask for some Docker in Docker. And the difference is that there I will use this Docker file. In this Docker file, where is it? This is this one, I think. I install my software and set some specific environment variables that may be needed to make it run. Okay. Once it's done, I build a Docker image with this software, and then I push this Docker image into another project registry. That might be useful if you have a private project, but you want to provide some public images. So there, I told him to put this in this destination, and this destination is set in the main program there. Where is it? I told him to put this in another project, which is CI example trigger, and I asked him to build the image and put this in this other project. This will work. I can show you this just after. I add 2 other jobs with Python, just to provide some example with Python, where I install things and I run some tests. And I ask for the installation of a Docker image with a notebook, a Jupyter notebook. So when this image is okay, you can download it and execute it. It means that if you make this continuous integration work, you can give people with a link to this Docker image on your project, and they could just run Docker run this image and start a notebook Jupyter with your software inside, which might be quite useful for people who don't want to bother with installation and things like this. This is this job, and last interesting job is the release job. Here, this job is very specific. I told him that each time I put a tag in my project, then it should run a release. The example is there. This one. Here, for example, you can see that I create a release tag like this. To create a tag, you just go to. You can do this with Git or just with the interface with tag, create a number, and save it. If I do so, it will start a job release, and it will produce a release. We can find here. The job will produce this with some zip or archives of your software that will be available to be downloaded. This is the release point, and to trigger, the last point is to trigger things. You can use this trigger keyword and ask him to, this means that when this job starts, it will launch a job, it will launch the CI into this other project. So you can cross-project things, and it looks like this. Where is it? When it works, the pipeline looks like this. So we still have all our stages, the standard ones, but we have this release job because that was a release, and this bridge, and this job is something that asks for a downstream activity, which is in another project. If I click there, I step to this project, which is a CI example trigger, and you can find the result there, and you add in the continuous integration. That might be useful if you have a full software and you want to you build, test your software, and sometimes you want to produce some more advanced tests or examples for your users, and so you ask to start another build, a more complete build in some other projects, which might be public or not, but you can connect things like this, and it's quite interesting. Okay, and here I just ask him to run my soft. So in this project, in the triggered job, I download the Docker image generated by the other project. I execute it, and I just execute my binary, my software into this new image. That's it. Comment? Je vais m'arrêter. I think it's over. Okay. So have a look to this complete project, because I think it was a bit too fast to understand everything. What have I forget? Okay, there is this software edge thing, so that's okay. Okay, thank you.
So I'm really sorry, but there is no time for the question. So I'm really sorry again, but you have to change your amphitheater and go to the 206 on twice on the right. Pas cool, ni pour toi ni pour l'autre en fait. Non mais oui, c'est super chiant, je suis désolée. Parce que les gens ne sont pas arrivés en fait. Il n'y avait personne. Et demain ça va être pareil. Mais là, lui, il a... Ah oui, bah oui, c'est sûr. Il nous l'a dit en fait, Alexandre, il nous a dit que les gens en fait, ils étaient jamais là. Il y a beaucoup de Montpellier. Hein.
Ah oui, mais s'ils sont pas là, tant pis pour eux, quelque part.
Quelque part.
Parce
On aurait
sinon,
dû.
là,
non, mais on était 5 à 9h01. En fait, c'est ça l'histoire.
À 9h, on était 5. Dans le film, ah non, dans le film, en bas, oui, par contre. Ouais. So you can use it and c'est bordel sans animation.
Ouais.
Bon voilà, du coup je pense qu'il m'a regardé.
À la fin.
Au début, parce que du coup j'ai quand même bâclé les trucs.
Bah, du coup, tu avais prévu 2 heures, non?
Non, ça rentrait. Ça rentrait en 1h15.
Bon, l'autre, il est prêt. L'avantage, c'est que l'écran est allumé, tout
Ah
ça,
oui.
donc il
Oui,
va
parce que là,
démarrer.
aussi, le capteur, on aurait dû rester là en fait au début.
Mais ouais,
Je
faut
machin.
pas savoir, en fait. Là-bas, un pauvre HDMI, ça marcherait pas, quoi. Et en fait, la dernière fois aussi, au Jugle, et ben, tous les Macs, c'était la grosse merde. Et en fait, il a dit qu'ils ont... Apparemment, Ludovic il disait ah ouais mais c'est classique comme. Tu veux aller à l'autre TP là?
Je sais pas. C'est quoi ce truc
En mode, ouais.
Je suis pas sûr.
Ça va? J'ai rien compris, il n'y a pas plus Antoine qui dans un truc.
Si, mais dans l'autre session. Allez-y.
Parce que sur le programme, c'est marqué que c'est affiché.
Oui, je sais, mais on a été obligé de changer.
Il y a une salle.
Oui, il y a une salle au rez-de-chaussée. Non, je crois pas. Ah, ok. Thank you.
Mais ça doit être la même question, mais de Jupiter.
C'est salle 108 au rez-de-chaussée.
D'accord.
Vous allez vers les toilettes, là, vous continuez le couloir et c'est à gauche.
Très bien. Merci. Donc, par là.
Oui, je pense que ça a déjà dû commencer. Non, pas fini. Ça a commencé parce que...
cet après-midi à la pause café, par exemple. Ça serait l'occasion. Il n'est pas occupé cet après-midi.
On va regarder un petit peu suffisamment pour.
D'accord, ok. Merci beaucoup. À tout à l'heure.
À tout à l'heure.
cours pour aller à la sortie? Au parking là-bas.
Sortir par où? C'est ça le truc. Le plus en fait.
Le gardien, l'entrée principale en fait.
Ok, alors en fait.
C'est la voiture à côté.
Ouais, bah vous tournez là à droite, prenez les petits escaliers en collimation, vous atterrissez vous prenez au niveau 0 et puis vous sortez par la porte sur votre droite. Ça devrait être bon.
si vous voulez faire un test, vous avez l'affichage de barcode derrière vous.
Non, enfin, je voulais juste...
Non, on vous l'enlève le barcode derrière?
Attendez, juste 2 secondes. Ça, voilà, mode plein écran. Ça, c'est la personne qui va commencer. Qu'est-ce que vous voulez... J'ai pas compris en fait ce que vous voulez enlever.
Non,
qu'est-ce que vous voulez que je fasse?
Non, pas du tout. C'est pour vous en fait, pour voir si vous avez bien l'affichage derrière vous, de partager le document. Normalement, vous avez le bouton du barcode qui doit être blanc.
Oui.
Voilà.
J'appuie?
Ouais. Et après, il faut faire la transition. Voilà. Ok, vous l'avez.
Voilà.
C'est juste ça.
Ok, super.
Voilà.
Merci.
Je vous en prie. Est-ce qu'il vous faudra une télécommande?
Je sais pas. À voir avec la personne.
D'accord, je vais vous la descendre, c'est mieux.
Ok. C'est un peu le pointeur ou...
Ouais, c'est ça.
Voilà. Bah,
J'arrive.
Ça, je sais pas.
J'arrive, à tout de suite.
Voilà, j'ai récupéré les slides.
Oui.
Elle est pas, c'est pas en plein, voilà.
Si.
Ah oui.
Voilà, tout va bien. Hop, j'ai juste coupé pour pas
oui, la
les
pile.
piles.
Ouais, super. Merci.
Voilà, vous avez les micros qui sont là, les cols de cils sont ouverts en permanence.
Ouais.
Voilà.
Merci.
Je vous en prie.
Oui, d'accord. Oui, oui, oui. Non, mais ce matin, en fait, je suis montée, mais il y avait des personnes, je ne savais pas où vous trouver. C'est pour ça qu'avec ces téléphones, en fait, je ne peux pas. Oui, mais pas dans
On ne nous voit pas quand on est assis derrière l'ordinateur.
Non, c'est vrai. Oui, mais c'est juste que voilà, en fait, je pensais que le barcode, tout à l'heure, c'est vous qui l'avez fait en 206, c'est vous qui l'avez allumé depuis la salle. J'avais pas fait gaffe qu'il y avait les trucs de commande à côté du tableau, donc voilà, on aurait pu ne pas vous déranger. Non,
C'est censé savoir que le mec, éventuellement, quand il est on,
Sorry. Aber da fehlt doch ein Jahr. Wir hatten noch letztes Jahr die Ästhetik. Ja. Ist ja von 2014 bis jetzt. Ist nicht ganz eine Dekade. Ah ja, okay. Na gut, wir können ein bisschen runden, das geht. Ja.
Notes.
Ah, okay. Okay, der müsste funktionieren jetzt.
Wie macht man das?
So. Genau, ja. Aber warum das jetzt da nicht erscheint, das weiß ich auch nicht, aber das macht wahrscheinlich der Fernseher.
Okay.
C'est pour le mettre sur l'écran, c'est l'équipe des vidéos qui fait. Ah oui. Oh, c'est juste un bouton. Ah oui. C'est le bouton magique.
Do I need to do anything to make it big?
Yeah.
How do I...
Il faut mettre en plein écran.
Oui. Affichage. So you can switch with them.
Welcome back, everybody. So we are trying to catch up a bit on the delays from this morning. Sorry for those, and hoping to have fewer technical problems because the first afternoon session is purely talks, no exercises. You don't have to take out your computers, no installation necessary. And the general topic of this first afternoon session is experience reports from people who have been working on improving their research practices in computation. And we'll start with Ricardo Vomos, one of the veterans of GUIX, I would say, who will talk about a decade of experience with GUIX. There are many people in this room who can claim a decade of experience, so please listen to him.
Thank you. Yeah, this talk is called A Decade of GUIX, a subjective retrospective. And as you can see, I'm an unreliable narrator because it has not been a full decade. So that's where the subjective comes in. Okay, it felt certainly like a decade to me. The abstract of the talk says that this is a story of a quest for predictability, reproducibility, and stability through unpredictable means, ad hoc hacks, and an embrace of the quirky. But actually, it's a story about values that are encoded in software and how we perceive those values and how that makes us change the software and how the software changes us in return.
since this is a story from the perspective of me, and you don't know me, it may make sense to start by introducing myself, going all the way back. So, this is me. This is my name, at least. I'm Ricardo on IRC, and I've been a GUIX contributor since 2014. I've also been a sysadmin at the Max Delbrück Center in Berlin since 2014. Coincidence? I think not, but you'll see. But this is not where it started. It all started much earlier, not in 2014, but with my first computer, depicted on the left. Actually, this is another lie. This was not my first computer. I had lots of first computers. My father worked for IBM, not in any important capacity, but in an office, and the late 80s were a period of innovation at IBM. There were lots of new computers coming out all the time, so the previous generation was obsolete very quickly. So my father would take home lots and lots of different computers all the time, so we always had computers around. I was very lucky to have grown up this way. Computers were not something I thought about. They were just there, like my bed or the kitchen. There was a computer there. Computers were fun. Sometime, starting from my 7th birthday, I started writing little programs, little games for fun. Actually, this thing on the left there, this is a screenshot of my game that I finished when I was 10. Of course, it was a Star Trek themed game. And this is the last project I actually ever finished. My work ethic has gone down since then. It actually has a beginning, a middle, and an end. It's a real game. It's in German, though, so I've got the code here, though. Computers at that time, to me at least, were self-evident. They were immediate. They were reliable, but we come back to that later. And they were fun, most importantly. Reliable, not in the case that they wouldn't break. They would break all the time. But I had so many of them that it didn't really matter if I broke this one or if I installed OS2 Warp on the other one and it wasn't usable for a while. New computers would come in and be deposited in the basement eventually all the time. So I was not afraid of breaking things. This is called foreshadowing. We'll come back to that later. At that time, I would have never guessed that someone serious would be using a computer for anything else than just writing games for their own entertainment. But at the time, this was not an unusual thought to have. Lots of people just didn't take computers very seriously, at least not in my circles. Computers were always around, though, and the manuals that accompanied them at the time were always around. And sometimes there would be some very dry, very, very boring IBM introductory materials to Linux mixed in with them, or Unix. And just, they were completely unappealing. So I didn't read them, and I didn't use Linux until 2007, when Ubuntu Studio came out. At the time, I was very much into music, so I played with Ubuntu Studio because it was way cheaper than the paying for all that music software. You may have noticed yet another piece of foreshadowing, the attire, right? Yeah, this is, or is it foreshadowing or is it Chekhov's gun? We'll get to that. When I played with Ubuntu Studio, I installed all the software that was available in the repositories. One of them was GNU Lillipond, which was how I first encountered Scheme. Lillipond is a composition software, a notation software, and you can extend it. You can write your own engravers in Scheme. But at the time, I didn't use Scheme for anything but writing little programs. Then I encountered the SICP video lectures by Gerald J. Sussman and Hal Abelson. This was a course accompanying the book of the same name for HP employees, I think, at the time. And for the first time, I felt that computer programs could be beautiful. This sensation didn't last very long, because the contrast between this platonic ideal beauty of what software could be and what I later encountered at work could not have been harsher. Because software is not beautiful. In 2007, I was working my first job at a joint venture of Siemens Energy in Shanghai. And over the years, I slowly drifted from what was at first a poorly defined workshop factory automation position into what would now be called DevOps. So eventually I would build internal web applications and deploy them to internal servers, and we would eventually have one Linux server there. By the way, it was running Arch. This is what people do. This is part of the transition from Ubuntu to Arch. You have to announce that you are using Arch, by the way. Eventually, we switched to RHEL, Red Hat Enterprise Linux, because it has enterprise in the name, and there's nothing more enterprisey than Siemens. We also had Linux eventually on a couple of R&D workstations. And computers had become work. Programming was still fun, but whenever an upgrade of the system came along, things would break and they would turn into stressful puzzles. And I don't like stress. Eventually in 2014, I left Siemens. Not so much because of the stress, but because they decided to install spyware on all of the machines there to prevent leakage of R&D material. And this is when I remembered what I did not know was called Conway's Law, which is that the software systems deployed by an organization reflect the culture of the people who deploy them. Right? So Siemens is a very hierarchical organization, of course, would deploy spyware and spy on people to enforce their hierarchy. Yeah, and computer work at the time had become a chore. It's not just work, it's just completely unappealing to work in an organization that is so out of alignment with my own personal values. If computers couldn't be fun anymore, perhaps at least I could be programming them, breaking them, and fixing them in the support of goals that better align with my own. So I left China and I moved back to Berlin. And for a while I didn't do anything. It was fun. A while later, though, I noticed that there was a biology lab, a bioinformatics lab at the Berlin Institute for Medical Systems Biology, short BIMSB, at the MDC, which is the Max Delbrück Center for Molecular Biology in Berlin. They were looking for a person who would compile scientific software, mostly bioinformatics tools, for use on a HPC cluster. The cluster was pretty small, just 100 nodes running CentOS. They had a couple of labs using Linux workstations running Ubuntu at whatever version was current then, or probably outdated at that point. And so the decision was made to prepare RPMs so that we could install them the official way on the cluster to a user local BIMSB prefix. Everybody was happy because they could run their tools. And then the demands came in. Then people wanted to have more software because that's great. We have our own software. We don't need to compile it anymore ourselves. There's somebody who does this for us. And there were more requests and requests for software that demanded versions of GCC that were not available on this ancient version of CentOS at the time. Different variants were requested for different groups. They thought this would scale. It did not. So this is a picture of me maintaining an ever-growing collection of software, of RPMs. And it's only been a couple of months when I had to admit that this is never going to scale. Like, there were big system upgrades looming in the distance, and I was not like a member of the RHEL release community. I had no idea when they would do something and what breaking changes would come. So I was in front of the decision, do I heavily invest in RPM build infrastructure, continuous integration, or do I do something else? Even if I manage to stay on top of operating this local RPM repository, I would never be able to match the diversity of requirements from the researchers, because you can only install one RPM. So do I do like multiple repositories or different prefixes? It would never be able to match the high variability that was requested by researchers at the time. Also, remember the cluster was running an RPM-based distro, but the workstations were on Ubuntu. So all the work that I would have done for the cluster would not be applicable to the workstations. That's bad. So the dissonance between what I once saw as fun and potentially even beautiful and the reality of scientific computing could not have been louder. And it was then that I remembered an announcement email of a quirky GNU package manager written in Scheme. Even the email was written in like schemy things, schemy syntax. A short web search later, and I was playing around with an early version of GUIX. After an encouraging chat on the IRC channel for GUIX, I realized that I could probably replace our custom RPM repository and build different variants of scientific software on a much more solid ground, on a system that is designed for having different variants or different versions of the same package installed, well, each to their own prefix. So there would never be any conflicts. And all the while, I would be contributing to a project that felt like a new and exciting take on GNU. And here I need to take a short detour to talk about GNU. In my Ubuntu Studio days, all I knew about GNU was that it was dead. In forums, GNU software was sneered at. It was seen as relics from a bygone era. Yeah, back in the 80s, they did something with a license and something with GCC. But everybody was seemingly trying to replace GNU software. There was these GNU tools. How hard could it be to write LS, right? So while I was learning Haskell back in Shanghai, because I wanted to do Haskell for web development, don't ask, I switched from Vim to GNU Emacs on the third attempt in the same year, because I heard that it had great support for calling out to external tools. It did, but that was not why I stayed with Emacs. I discovered the 1981 Emacs paper by Richard Stallman, where he claims that an extensible editor would boost computer literacy as it lowers the threshold to programming. So people who would not otherwise be in a position to exercise their freedom to change a program to better suit their needs would find themselves almost by accident writing useful programs in a domain that mattered to them so that they could get immediate benefits and immediate results. In the 80s, this seemed like a good argument because computers did not look like they look today. But the idea, I think, is sound. That if you give people a domain that they're familiar with and low-effort tools, a language that they can use to express themselves with, to change their workflow, they will become literate in that language. And the GNU manifesto that was published a few years later expanded on the concept of user autonomy. And many GNU packages since have made user autonomy a guiding principle. It's not by accident that GUIX felt to me like a continuation of this original GNU philosophy, because its original goal was to build the GNU system and extend the individual user's autonomy to all software on the system. At the same time, it would not compromise security or encroach on the freedoms of other users on shared systems, but it's by design. And many of the properties that GUIX has today make it really useful in scientific computing, and those are the results of optimizing for user autonomy. Right? So user autonomy, users will no longer be at the mercy of one programmer or company which owns the source. You can change it yourself, or you can commission somebody to make those changes for you. It doesn't have to be you who becomes an expert, as long as you've got the freedom to modify things and you've got the tools to modify things. You can act on that freedom. So to this day, this is the core value that I hold, by which I judge software. Whenever I see new software that's introduced to me or it's announced somewhere, I ask myself, does this liberate users from needless restrictions? Does this increase user autonomy? Does it make any of the 4 freedoms more practical? For GUIX, the answer is yes, and my opinion anyway. And for shared HPC systems, this really makes a difference. It's not just extremists, right, who say, oh, I want more freedom, don't step on me or whatever. You know, it really makes a big difference for HPC systems. And well, let's take a look at how. So one obvious restriction that GUIX lifts, that we saw in the RPM example earlier, is that it lifts the restriction to have just one package variant at a time in one location. So package conflicts on shared systems just disappear. Every user can decide for themselves what version or variant of a package they want to use and for how long, without any ill effects on other users that are using the same system. So it also goes beyond shared systems though, right? Because if you're just using your own laptop, what do you care, right? About other users, it's just you. But there's not just you using the computer. When you have an operating system, this is the output, this is an artifact produced by lots and lots of people who have created this distribution, who made decisions for you. And sometimes these decisions might conflict with your needs. On GUIX, since software environments are mutually independent and they can resolve mutually incompatible requirements for different projects, even on the same system, you can isolate your requirements for one project from the requirements of another project, so you don't step on your own toes. And you're no longer restricted by decisions that were made by people who maintain, say, Ubuntu or Fedora. In HPC environments, this also resolves, or at least alleviates, the age-old conflict that we have between the users and IT. There's this power imbalance, right? IT makes a decision, users just have to suck it up. They can't really do much about it. It just evaporates because a significant chunk of the means of computation is in the hands of those who compute. I'm not trying to be political here, I'm just saying things. So moreover, there's the core freedom to modify the source code, right? It becomes a practical option in GUIX. We recall the 4 freedoms that make software free. Freedom 1, that is the second of the 4 freedoms, is the freedom to study how the program works and change it so it does your computing as you wish. Change it, right? Who has ever changed their browser? And I don't mean installed a different browser, but modified the source code of your browser. 1. I have not. It's completely impractical. For most software projects are so incredibly large, so incredibly complicated. You can't just go around changing something without breaking things. It also, when you do that, when you exercise this freedom, you're operating outside of the confines of your package manager. So say you install your Firefox through Ubuntu normally, and then you want to modify Firefox. What do? Like, you get the source code for Firefox and you compile it yourself. You wait a day or 2 for it to finish compiling, and then you do this again because it didn't work the first time. But now you have a Firefox artifact and it's frozen in time. And Ubuntu keeps moving on. And eventually things break because there's a system upgrade and your artifact is still stuck in the time that you made those changes. So it's impractical to act on this freedom that theoretically you have. But this is not an advertisement for GUIX, okay? It's just that thanks to package transformations, even complex entangled environments can be patched in GUIX. Otherwise, this would be terribly confusing and frustrating. GUIX removes this existential dread that you feel in adventures like this normally, because you just can't break your existing software environment. It just happens on the side. If it doesn't work, you just keep using what you already have. It takes the stress out of the puzzle and it becomes fun. Even HPC system engineers, they benefit from this because they can build custom systems with custom kernels. This becomes easy because there's no state to worry about anymore. Prior to using GUIX system, I had never touched the kernel configuration. It's just something I don't do because I know I'm going to end up breaking my system and then I can't boot anymore and then I have to get another computer and it doesn't have my key bindings and it's not something I want to do, but with GUIX just takes the stress out of updating. And for systems designers, this is a great boon. Now, some people dismiss GUIX outright as impractical, HPC systems designers included, because it does not include proprietary software by default in its main channel of distribution. So some even go as far as to compare this solid free foundation that we offer to a delusional quest for purity. The old man praying on the left. So it is true that GUIX does not include non-free software by default, but the conclusion that people derive from this is often wrong. So not only is GUIX not preventing you from building and running whatever software you like, including proprietary software, but it maximizes user autonomy by providing you with a number of fully supported ways to extend its features to software that is not part of the main channel. So in the last decade, I graduated from the simplest of these features to the most excessive, and back again because simplicity is nice. So I'd like to show you some of these mechanisms that GUIX offers for extending it and for breaking out of the decisions that were made by the GUIX developers, going beyond that, like the craftsperson building their own tools to become autonomous. So I have to go back, unfortunately, a little bit. The institute where I started working in 2014 relied heavily on R for bioinformatics packages. And I had at that point already decided that using GUIX would be the best option for handling research software reliably. The only problem was, aside from a really solid foundation of math libraries and compiler tool chains, GUIX only had very few of the packages we needed. It did not have R. And since GUIX without R would have been a non-starter for the MDC, one of my first big contributions to GUIX was to add Java in 2014. You see, I was under the assumption that I would need Java to build R, because the configure script for R looks for Java, the makefile mentions it, and there are Java bindings that are provided by R. And Java was written in Java. So, of course, we had to bootstrap the JDK from something that is not Java. Luckily, at the time, we had the GNU compiler for Java, GCJ, which is now defunct. It's no longer part of GCC. And it doesn't matter. At the time, we had built Java. We had bootstrapped it. And once all this work was done, I finally realized that Java support in R was completely optional. So, but still, at the time, we had successfully extended GUIX with non-trivial packages and used them at the institute already, well before these patches were merged. At the time, the best way to extend GUIX was to, it's kind of embarrassing, right? You just clone the Git repository, you patch it, you make your changes, and then you run this patch GUIX. There's really nothing to it. It's just that. This is what we ended up doing at the GUIX, at the MDC when we deployed GUIX. We had a virtual machine because those are cheap and nobody would miss a server. And we would mount an NFS share on some proprietary appliance that hosted /GNU. And we would run GUIX and the GUIX daemon from a modified Git checkout. And every once in a while, I would git pull or rebase my changes until they were merged. It was brittle. It was not good, but not worse than having lots of RPMs, right? I think. So the cluster nodes, they would then mount this NFS share as read-only, and we had a cluster deployment, very easy. It was very slow because we would write to NFS, but it worked for the most part. Clearly, this is not great. Right? You don't want to run GUIX off of a modified Git checkout and have like one version of GUIX for everybody, and then rebase it and maybe have some merge conflicts. You haven't tested this well because there's no CI. Since December 2014, GUIX respects the GUIX package path environment variable, which separates things a little bit. You could be using a stock version of GUIX and extend it with an additional repository. When this became available, I started the GUIX BIMSP repository, which is just a repository holding packages and package variants that were just too gross, too ugly to submit to GUIX proper, or that were just not mature yet, like that hadn't really worked out the kinks of. On this virtual machine, we would just be setting GUIX package path so that everybody who used GUIX through our central deployment would also get those extra packages. And most researchers, they would just do that, use our centrally provided fixed version of GUIX. And there were some intrepid users who would do this themselves. They would get a version of GUIX for themselves by git checkout and extend it with GUIX package path, and then it would break. Because GUIX package path and GUIX itself, they don't know about each other. They grow out of sync eventually when we add packages to GUIX that conflict with what we have in GUIX BIMSP. Not great. So we needed definitely something better than that. And today, we call this kind of improved extension a channel. Today we've got more than those, but this is just a sample of popular channels that provide scientific software, non-free software, old software, gross software, so bioinformatics software, tuned package variants, automatically generated packages, like the GUIX CRAN channel contains all of CRAN as GUIX packages. And the core, so a channel is still just a Git repository containing package definitions and, in the case of GUIX Science, also custom build systems and services. But the novel idea here is that the channel itself is really well integrated with the GUIX pull command. Now, GUIX pull is the way that a user can manage GUIX for themselves. And the core idea here is that we're using GUIX profiles for GUIX itself. So you get rollbacks. GUIX pull also does a couple of more things, like it validates commit signatures and all that really good stuff. It's not just using GUIX for GUIX itself. The key outcome of this was that users could now upgrade and downgrade or switch versions of GUIX without things breaking, together with their extensions to GUIX. No more modified Git checkouts needed. Any and all of these packages that we made available either through channels or through GUIX package path, they can be used with the package transformation framework that was introduced in early 2017. And this is perhaps the most extreme way of extending GUIX, because it's not just adding something to this large collection of packages that we have in GUIX, but it just uses this body of connections between packages as a template and lets you rewrite connections and lets you change nodes in this big graph so that you can create something entirely new that is inspired or that retraces parts of the connections that we have encoded in GUIX. So package transformations, they bend this tangled graph of dependencies and extend it or shrink it in novel ways. So we can express packages this way that never were part of GUIX. So at MDC, we use this feature more often than you would think. And it is not reserved to experienced programmers. It sounds really complicated because the domain is complicated. Right? It's messy. Software is messy. It's many, many connections. But this doesn't mean that our handle on this messy problem can't be beautiful. It is often at the MDC new users who are untainted by experience with existing package managers who come to me and who ask for getting a list of packages installed at particular versions. And I look, oh, GUIX doesn't have it. In the Git log, did it ever have it? Nope. So there are some packages at older versions that never had been in GUIX before. And with package transformations, I can create a manifest that declares the environment that never existed, and I will it into being. Right? And it's declarative, and it's reproducible. So usually, what I do then, I go through this with the user who approached me, and they come away with an appreciation for the complexity of the software environment that they were previously unaware of. It's just like, normally I just do conda install and I got a binary and then, but actually when they see, not necessarily the graph, I don't show them that, I don't want to scar them for life, but when they see how long it takes, for example, to build all of these packages from source, they understand that it's not lightweight, what the README of that project said. Oh, it depends on this foundation. On top of that, yeah, the code that is added on top of that might be lightweight, but everything else, not so much. They understand their environment better. And at that point, when they have this manifest file, which is a scheme program, they feel empowered to make tiny changes to it. Add a package, for example. And voila, they have started coding. They have started writing and taking charge of their destiny, the software environment, right? And this is where I'm, again, reminded of the Emacs paper from 1981. This is called Setup and Payoff. So the Emacs paper, right, said a layperson who ends up programming as they mold their editor to their needs. Here it is not the secretary or newspaper article writer, but it is a biology student who has gained just enough confidence to mold their software environment in ways that previously would have been reserved to a collective of distro maintainers. It's a lot of power in the hands of a user, right? So I tried to simplify this, to boil this down to a catchphrase, but I fail at this. So, but there's like when you have a low barrier and a domain-specific programming language, and people learn that vocabulary that the domain-specific programming language expresses, then this is practical software freedom. It becomes actionable. You can actually do something with that freedom. But I said I was talking about ways to extend GUIX. The final mechanism that GUIX provides to grant users more autonomy is the aptly named GUIX extensions path environment variable. You set this to a location that contains a GUIX extension, a subcommand definition, and it becomes part of GUIX. You can just provide an extension that is called random, for example, and then type GUIX random after setting GUIX extensions path, and it installs a random package, for example. Very useful for I suppose, for reproducibility. Perhaps the most ambitious example of an extension like this is the GUIX workflow language, which provides a single command, the workflow subcommand. And that command supports a whole new domain-specific language for defining scientific workflows. And these processes in the defined workflow, they run inside of reproducible GUIX environments. So this is deployment-aware workflows, okay? So these workflows are deployed to HPC systems together with their environment. Traditionally, workflow languages are designed to designed around specifying links between artifacts, right? So like, as in GNU make, for example, snake make, for example, does it this way. You have artifacts that are being produced by running some commands. and these artifacts are linked in some way. One produces the other. And the assumption for a long time has been that the user would be well aware of what tools are needed to run this whole thing. They were assumed to provide the environment in which this workflow runs. Today, this is a little different. Today, most of them are Docker enabled, if you will. You can specify a Docker image that is supposed to be used for a particular workflow step. But when we started this GUIX workflow language thing, that wasn't really a thing. Deployment-aware workflows were not a thing. The GUIX workflow language just inverted this traditional approach, and it started out with taking reproducible and flexible deployment of software provided by GUIX, and then extending GUIX with just a wee bit of code that defines the workflow language extension. So all the good stuff is really provided by GUIX. The little bit of extra syntactic sugar to deploy that workflow and specify it is in that extension. But today it's questionable if this is still something one would want to be doing this way, because workflow languages today are much less about expressing relationships between data processing steps, but they're more about running workflows on a wide variety of platforms. And much to the frustration of HPC system admins, today's generation of researchers is frustrated often with batch scheduling, with job schedulers that are traditionally deployed in HPC systems. And there are many people, at least in my experience, who call for cloud-native systems. And the term cloud is so vague that it means different things to different people. People never agree on a shared meaning. So some it means they want scalable infrastructure as code, or it means they want infinite storage without broken disks that they need to take care of. For some it means they want to have on-demand compute in different regions wherever they are. To others it means just freedom from the local IT department, and yet others mean just AWS. It doesn't mean anything else to them. And no matter how often a well-meaning IT person will say that we've got the cloud at home, we've got OpenStack, to the user who's asking for AWS, it does nothing to satisfy their demands. I'm not judging either way, okay? Users can have legitimate reasons why they would want the cloud platform promises to be true. And HPC admins, they have legitimate reasons to question the dominance of Amazon and Google. But the fact is, no matter what platform we end up having to use and support, we run the risk of being forced to leave behind some of these practical freedoms that we fought hard for, and leave them behind at the platform boundary, right? So this includes OpenStack, by the way, because the common currency on cloud platforms is still the lowest common denominator, and that is the humble Docker image. Right? And most of the common system administrator idioms that we rely on to make GUIX a near perfect fit, I would say, for reproducible research on single user machines as well as HPC systems does not translate all that well to cloud platforms. If you want to retain this practical software freedom that I tried to express earlier, that we gained with GUIX, then we need GUIX to become not just a thing that's running on our local machine before we push a Docker image to the cloud. It needs to be something else. The good news is that GUIX already has a good number of tools to get us there. The bad news is that there are a couple of gaps. And these gaps, they keep highlighting the fact that we are walking a path that was not envisioned by the platform providers. Examples. We've got GUIX deploy to deploy GUIX systems to remote machines that already have GUIX installed on them. So getting it there is still not trivial, even though we have an automated installer script that we could run. some friction there. And friction adds up. GUIX deploy does not let us push GUIX itself to the remote and install it. GUIX deploy also only works with GUIX systems. So we define a system that we want to deploy, and it deploys it to a system that already has GUIX as a package manager installed. It does not let you deploy, for example, a remote profile. Say I have an application that I built, and I just want to push that. I want to build it, and I want to push that to the cloud. And I don't want to go through this detour of Docker. On the other side, we've got the lower level GUIX copy to copy over store items, including profiles that we may have built. So maybe we can get there through GUIX copy, right? But we can't, for example, have a remote profile with generations that we copy into to install an existing profile as the next generation for the remote profile. So this means that our deployments would lack the safety net of carefree rollbacks that we've come to rely on so much. And being able to just break things without consequences is what liberated me. And I would like to have this on the cloud as well. But why resort to copying at all if we could use GUIX directly on the remote, right? So we have ways of changing that, of changing GUIX so that it could, for example, use S3 as a backend to cache the things it downloads in S3. But there's a couple of things missing for us to make this really happen. Because at least for AWS, the core limitation of the platform, despite all of its flexibility, is that it becomes only useful and feasible to use it for HPC workflows if you stay in there, if you stay on that platform, if you confine yourself to the resources that the platform provides. Doing things locally and pushing it in there is very costly. You incur ingress, egress fees for that, and nobody does that. So everybody wants to stay within the confines of the platform. And in doing so, because they leave GUIX behind at the boundary to the platform, they lose all of the advantages of using GUIX. So extending user autonomy to any compute substrate, this is not a word, by the way, I just made it up, to any compute substrate requires playing to its strengths, so the strengths of the platform. In AWS, for example, this is flexibility, on-demand computing. One of its strengths is not cost, right? Or it's a remote machine, you don't get to fiddle with it the way you would a regular server. But its strength is something that we can use. If we agree to play not by its rules, but by the constraints that it has. I hope this makes any sense. This sounds weird. Summary. It's time for a summary. So with a decade full of hindsight, I can say that the choice to go with GUIX for the MDC, the HPC, reproducible research context, was a full success. I think I would have quit long, long ago had I had to use RPM. Right? It's just something that would have been a non-starter. There may have been other solutions at the time that were budding. Maybe today they would be alternatives. I don't know. I only know my own experience. I just know that GUIX was a perfect fit at the time, and it still is. And it only has become better for the HPC use case. So what I really like about it is that there are no end users in the GUIX philosophy. Once you have a person who is interested in taking charge of their software environment, a person interested in being autonomous, they have the tools. All you need if you want to deploy GUIX at an HPC environment is somebody who teaches. It is not somebody who does all the work for them. So it is enough to get them started. But this doesn't work for everybody, obviously. There are some people who have a reluctance to overcoming this initial hurdle, this hurdle, or the self-perception as somebody who is not good with computers. We can only help them to get there eventually. But I think the values that are encoded in GUIX strongly support those who are willing to exercise their four freedoms. Many of the challenges that we faced in the early days at the MDC, like this running GUIX off of a modified Git checkout, for example, they have provided good data to inform the direction that GUIX should be taking, or at least provide confirmation for the features that were added to GUIX that these were in fact useful. So the core value of maximizing user autonomy is manifested to a high degree in the extensibility of GUIX. And this is what I mean here by saying GNU values make for better tools. It doesn't really matter if GNU is seen as a project that is still alive and kicking. It's really the values that matter. And I think the best manifestation of those values, no, let me not say the best, the best in terms of package management, right? I think is displayed in the structure of GUIX itself. The final point is the most controversial point that I made today, this whole cloud computing nonsense. Right? If we see cloud as the continuation of HPC by different means, to see it as a platform that users are in fact using for valid reasons, then perhaps we can make slight adjustments to the features that already exist in GUIX to better support users there so that they can keep using those systems, keep using on-demand compute systems without paying the price of leaving behind practical software freedom. And this is where I end the talk. We can talk later. I don't have to do the talking. You can tell me something. You can also contact me via email, and I'm always on this IRC thing. Not right now, but I will be again. Thanks for your attention.
Yeah, thank you very much for this explanation of liberating, dependable, and hackable. Everybody's convinced, but maybe some have questions.
Thanks for this nice journey that you presented to us. I might be poking the hornet's nest. Let's see how it goes. So you stressed the value of the GNU values in the application of what you did so far and how it helped you. From the examples that I saw, to me it looked like more like the value of open source in general, which is broader than that. So can you elaborate a bit on how specifically the GNU values supply value to you or the projects that you did?
Yeah, I'm not that keen on this division between this free software and open source. I just think that the term free software tries to capture some of those values that result in the artifact that is open source software. Whereas if you take this framework away, this way of looking at open source software, at the artifact, you're kind of missing the culture that made it happen, that pushed for certain developments to take place. But it is true that today, we saw it in the software heritage presentation, the GNU repository, right, or the contribution of GNU packages to this vast heritage of software that we have now that is free is minuscule compared to, say, all this free software that's out there for Python that is not as affiliated with GNU. And to me, this is not a contradiction. This is not a problem. I think when you put user autonomy in the first place and not, I want my code to be used by Google so I'm successful, if that is the primary driver, I think it informs decisions that will be reflected in the code that, again, propagates those values. I don't know if this makes any sense, what I just said. These were words, though.
It's very subjective.
Yes, hence the name of the title, yes.
Thank you very much. It was really a lovely talk and lovely presented. I have two questions. Can I be liberated by GUIX without using Emacs?
Sure. Yes, absolutely. I think it was a misstep initially at the way we communicated GUIX. Some of you may have heard of the Emacs of distros. I think it's perfect. It's the perfect title, but it just conveys Emacs baggage to people. You can use GUIX without Emacs. It is some of these values that are present in Emacs at full display that are also present in GUIX though. So yeah, use whatever, right?
Thank you very much. That was just like a little joke.
No
but
need
the
to
real
use
question
Emacs.
was regarding to the usage of cloud and cloud providers. Is GUIX, for example, trying to build EC2 images, AWS EC2 images, or on a regular basis?
We are not doing this at this point. I don't know if it's worth doing. So all I have done so far, the past year or two, I had to work with AWS, and I always felt this boundary, this platform boundary, where I had to leave behind all of the tools that I know well. And I was always reduced to building Docker with GUIX pack, for example. I have a Docker thing and I push that. Building GUIX system images for EC2, these AMIs, I think they are called there. Sure, I think it would be lovely to have something like this so that we don't have to jump through hoops just to get GUIX on there and to use the framework that GUIX has for defining operating systems right on AWS. But I think there are simpler ways to get there that don't require doing a lot of custom stuff like that. So we could still be using Amazon Linux, for example, and on top of that have containers be deployed. And these are spawned by GUIX system, for example. This would be a more immediate way to get started with that without having to deviate too much from what the platform wants you to do.
Thank you.
Nice Nick sticker. I like that.
I don't have a GUIX one. You could give me like...
We'll get you a bigger one.
Challenge. Does anybody have a result with GUIX stickers? Downstairs. Okay, so you can pick up a GUIX sticker downstairs. Well, maybe one more if there's one question before we move on to the next talk to limit our delay. You have convinced everybody.
Okay, good.
Thank you very much. The slides on there, I think. Yeah, that's it exactly. And put it back into full screen mode.
Can I close the
this is closed. Acrobat close the tabs. I have closed everything, but good.
How do I get full screen?
Playing call. What do we call here? Control P? Control L. Excellent. Okay, our next speaker is Aaron Isaac from University College London, and he'll talk about how GUIX manages the software deployment in bioinformatics.
So hello everyone. So thank you, Ricardo, for reminding us why we do GUIX. It's been so long that it's easy to forget. My talk is about G network. I'll explain what it is. So we write code in G network using GUIX, and we also deploy servers and run HPC clusters using GUIX. So this talk is mainly an experience report where I will explain what we do and how we do it using GUIX, and hopefully convince you that all this is possible, and you should probably try it too. So. Yes, okay. So first of all, what is G-Network? So this is the G-Network website. G-Network is one of the oldest bioinformatics web platforms. It essentially includes a lot of experimental data and provides compute facilities to users who don't want to actually download the data onto their own computers, install everything, and do the analysis themselves. So bioinformaticians who don't really want to directly handle software can use the G-Network web interface and do some analysis. People even publish science using output obtained from G-Network. So it is hosted and maintained by the University of Tennessee Health Science Center in the US. It's largely maintained by a fairly small team of programmers, less than 10, I'd say. And it's a very old code base, mostly Python, but these days a little bit of Rust and more Scheme as well. 43,000 lines. And there is a lot of legacy code all the way from G-Network, the earliest version 1, which included Python 2.4, I think. So the code base has been slowly migrated to Python 3 and other languages as well. So you can imagine that we have a lot of old code to maintain. We can't just get rid of old code because there are still users who are used to our really old interfaces and don't like change even if the change is nice. So you have to run all old instances and not break anything in the process too. Managing a huge complicated dependency tree like that would be totally impossible without GUIX. And finally, we are really big on autonomy. We don't use any cloud machines whatsoever. All our servers run free software, and we actually own the hardware the servers run on. Yeah. So what do we use GUIX for? We use GUIX for everything. So that's obviously the packages, which is the most popular part of GUIX. And then we use the GUIX for maintaining development environments like GUIX shell, for example. And then we also use GUIX for CI and CD, for continuous integration and continuous deployment. I'll explain how in later slides. And we're working towards full production deployments of G-Network using GUIX only, but that's currently a work in progress. And like I said earlier, we also use it for HPC clusters. So packages, so you must have heard from the tutorials and talks yesterday. So when you have a lot of domain-specific packages that are hard to compile and hard to maintain, something like GUIX really is extremely helpful. So we have our own channel, the GUIX Bioinformatics channel. It has a lot of pretty obscure bioinformatics packages packaged in there. Sometimes we contribute some of them upstream when they are more popular or more polished packages that are probably useful to the larger community as well. So keeping things on our own channel means that we can quickly fix things without having to go through the GUIX review process. And sometimes when things break due to changes in the software environment, we can quickly fix things, and we can do things like disabling tests, which we often don't have the patience to fix. So it's helpful to have user autonomy where you have things close under your control. And development environments, obviously we use GUIX shell with manifest files or with GUIX.scheme files. So we use it so much that any project we start, even before a git init, the first file you edit is either a manifest.scheme or a GUIX.scheme. And all programmers on the team use GUIX and use GUIX shells. So it's really easy to reproduce any bugs. If there are if you need to communicate exactly what version of the environment that one person is using, we can easily do that using GUIX describe, and it just outputs the hashes of all the GUIX channels that is in that environment. This is extremely useful. So this is something we slowly moved towards doing, and before this, reproducing bugs was always a pain. Now it's a lot easier. And we also pin specific versions of upstream GUIX. So yeah, here you go. So yeah, in the GUIX bioinformatics channel, so in our experience, we used to find that GUIX upstream moves so fast that sometimes packages break in the environment. Sometimes suddenly Python is upgraded, or even some package you've never heard of is changed, and that breaks our packages that depend on those packages, and suddenly one morning you wake up to find that GUIX shell no longer works. So so to avoid that, we pin specific commits of GUIX upstream in our channel dependencies. So that means we always have a fixed environment that we are working against, and once in a while, let's say once in a few months, we update this commit so that we have a controlled update, and when things break, we actually have the time and mental bandwidth to fix things. Yeah, as far as I know, I don't think anyone, I've heard anyone actually pinning GUIX commits like this, so maybe it's something interesting for others as well. So we also use a lot of GUIX system containers. So GUIX packages are the popular and most widely spoken about part of GUIX. But GUIX also has system containers. So what does that mean? So you see here an operating system definition. So it specifies things like host name, time zone, all that stuff. And most importantly, it specifies services. In this case, it specifies a CGIT service, which is a Git web viewer, and a laminar service, which is a really simple, minimalist continuous integration system. So when you have a service system configuration like this, you can actually use GUIX system to build a container that fits this description. And then this container can be run on any machine. It could be, it can even be run on foreign distros, or it can be converted into the Docker images if you like, and so on. So you get all the benefits of functional package deployment in system deployment as well. So all our servers are actually specified by or described by GUIX system configurations and deployed using GUIX system container. So the functional deployment model is really not unique to just the packages. It's really anything, and I think that is sometimes missed in descriptions of GUIX. So on the Metal, our servers all run Debian, but we have GUIX installed as an additional foreign package manager. That's mostly fine because so on a newer servers we are hoping to install GUIX directly on the Metal without any other distribution. But our older servers have always had Debian, so it's kind of a easy way to get started using GUIX. And this is not a problem because you can still use things like GUIX system containers even on a foreign distro. So, so on the screen you see commands showing you how to do this. So you have the first command, which is GUIX system container, -n is a network flag. It builds a container script in the store, and then you link this container to some convenient path like user local bin something my GUIX container. You also need to register this container into the garbage collector roots, which is at /var GUIX gc roots. If you don't do that, the garbage collector can clean up the and delete the container. It's possible. And finally, you can just so this is just a simple script. When you start it, the container starts. Usually, it is good practice to have something like a systemd service to manage starting these containers at boot time, monitoring them, etc. So we have a really simple systemd service like this. Just all it does is run the command. That's all it does. So all the code that we use for that we use to deploy our servers is published. So we like to work in the open, and so they are actually published in this Git repository at this URL. I'll probably show it again later if we have time. Yeah. So onto how we actually do CI using GUIX. So this is the basic flow, which is common to any CI system, really. We start with some commit being pushed, and then either a webhook or a post-receive hook triggers our CI system, which is running laminar. And then the laminar CI system builds the tests, and if the tests pass, the continuous deployment of our development instance is restarted. So this is a very generic laminar flow, really. What's GUIX specific about it is how we build the tests in laminar. So each one of our repositories is a GUIX channel itself, and so these GUIX channels contain just a single package, which builds the latest version of that package. So all the CI does is it pulls this channel and builds the one package that is defined in there. So this is described in one of Ludo's blog posts, From Development Environments to Continuous Integration, the ultimate guide to software development on GUIX. So you should look at the blog post to get the full detailed description. So since the CI is really just doing a GUIX pull and a GUIX build, it's really easy to replicate even on your laptop. It doesn't have to be on the server that's running the CI. So when things go wrong on the CI, because sometimes there are bugs that are detected on the CI, but the one who pushed the commit didn't notice, it's really easy to replicate that on the development laptop itself, because usually in CI systems, there is a lot of pain involved in figuring out what exact environment the CI server ran the tests in. You don't really have that if you're using GUIX, because to be honest, there is no real difference between GUIX on the server, GUIX on your laptop. It's all the same. It's just building a derivation somewhere. Yeah, this is a screenshot of our CI system. So this is just laminar. You can see that there are 3 jobs currently running. I'll again probably show this later in a demo if you have time. This is one specific job. So I have the screenshot here to show you this. Oh no, yeah. So these 2 lines here. So once the tests have passed, we actually restart the CD system. The CD system pulls in the latest code and starts up again. Then onto our production deployment. So we have a Sparkle endpoint running Virtuoso. Virtuoso is an old but still functional RDF triple store. So it's like a graph database, but more specialized than that. So we run a public Sparkle endpoint. We have a Virtuoso GUIX service for that. This runs in its own container, also managed using GUIX. We still run our old legacy GNetwork 1 instance in a container because, as I mentioned earlier, we can't get rid of our old servers because some people still depend on them. and it's good to have these servers running for reproducible research and all that. This is only possible because we have access to really old packages from the GUIX past channel. So the GUIX past channel contains packages that that existed before GUIX was a thing. So if you want to go back all the way to the 1990s, you probably want the GUIX past channel. So the complete GUIX full production service is still a work in progress. We are working on it. And we also use GUIX for HPC clusters. I don't think I need to explain it more than Ricardo did. So, yeah, this is our Sparkle endpoint. Just a screenshot. Yeah, we have a lot of documentation. We pretty much work entirely in the open. So we have a lot of ad hoc documentation. I mean, this is not complete documentation, rather the quality of a wiki. So you can, if you're interested in finding more details about how we do things, maybe you might find it here somewhere in this at issues.gnetwork.org. It also comes with a search engine. You can search for things, and it actually works. If you'd like to learn more, here are a few useful links. The first one is the issue tracker that I just mentioned. Then GUIXForge is another, is a channel that we use to, it's a GUIX channel that provides all the services that you need for running the laminar CA and other things. And then the GUIX bioinformatics channel contains lots of bioinformatics packages. And finally, the GN machines repo, which contains the GUIX system, operating system configuration that I showed you. So if you have time, I think we have time, so I'll probably show you some code. How do I make this bigger? Is there a
Control plus should do it.
Yes, great. So this is the code for pretty much all our services. This is one specific container, but this is our largest container. I'll jump straight to the end. That's a lot. Yes. So yeah, this is the operating system, the actual body of the operating system configuration. We have added things to the sudos file. Yeah, so this is the actual part with the GUIX services. So you see the laminar service here, and then the Seagate here. So the good thing about GUIX services is that, the first thing to understand is that GUIX services are not just daemons. In other distributions, that's what service means. But in GUIX, a service really can do a lot more things, like set up configuration files and maybe set up directories, set up permissions, things like that. So all that is encapsulated as code. So setting up infrastructure is really the same as writing code, and then you just run GUIX system container, and it all comes into existence. You don't actually have to go and open up a shell somewhere and start mutating configuration files and starting the service and restarting that service and so on. So while the GUIX, while GUIX system containers, this code can seem long and intimidating. Once you start doing it this way, you will never want to go back to mutating configurations files on some SSH shell. So the secret service really just takes two parameters: the directory in which all the repositories are stored, and the domain name in which the cgit is hosted on. So you'll notice that this is git.gnetwork.org, which is the same as what is showing you the code right now. So this is code to that is hosted using the code that you just see. And then Lamina, the CI system, some cron jobs, so on. We have webhook. This is the virtuoso service I mentioned. Some number of buffers, server port, data directory, and so on. So I mentioned that it's not just it's not merely just a. I mean, GUIX services are not merely long-running daemons. So here's a nice example of that. You see the last one. It's an Acme service type. So Acme is the protocol behind Let's Encrypt. So almost everyone uses Let's Encrypt TLS certificates these days. So the Acme service sets up cron jobs and sets up it automatically sets up some way to get TLS certificates. So there is just one field here. The other fields are optional. So the one field is my email address, because Acme needs that to contact you if your certificates are about to expire and all that. This seems like just 3 lines of code, but what's behind it actually does all the automatic updating of the Acme service and so on. So you don't have to actually be aware of all the things Acme is doing, of all the things Acme service type is doing transparently behind your back, and at the same time you don't have to commit to some complicated package that tries to integrate web servers and Acme servers all into a single thing. You can use really the GUIX Acme service is really powered by very minimal tools. Tools like, if you've heard of it, there's one called mu Acme, which is what the GUIX Acme service uses. So yeah, that's that. Oh. Yeah, this is the laminar CI system from earlier. Yeah, I can look at things like all the configured jobs, past runs of jobs. You can go back and yeah, you see that it's a laminar CI, but it's really running GUIX to build the test. So if you have ever looked at GUIX output, this is from the GUIX command line output. Yeah, it's running all the tests. This can take forever. I don't know where the page down button is, so. Yeah, there you go. So it's really building the GNetwork 3 GUIX package. That's how the tests are run. So it's extremely easy to reproduce, even locally. So yeah, that's it. If there are any questions, I'm happy to take them.
Yeah, thank you very much for this demonstration of how GUIX can do much of the work for you. Any questions?
Thank you. You said that in your channel you are pinning your base system dependencies. How do you manage like security patches for those?
Well, we don't. That's the thing. So, so most of the packages in GUIX Bioinformatics are HPC packages, and so we update the pinned commit once in a few months, but that's about it. We don't do anything special for security. So the commit pinning is essentially because when we're working on something, you don't want the environment to suddenly break on you, and you'll have to abandon all your work and go and fix the environment. So it's just to get around that. It's not really helping security in any way.
I get that. Thank you very much.
Yeah.
I should put myself in a better place for viewing. Looks like you have convinced everybody. I think I saw a mistake in 9500 of the log you proposed. That was just a joke.
9500. Okay.
No. There are no line numbers in there, so just made it up. Well, if there are no more questions, we can thank Aaron again for this quite impressive work and putting GUIX everywhere.
Yeah. Thank you.
How to manage all of your life with the GUIX. And is the next speaker around? Okay. Control arrow, all right. Control I, Control 3, it's already done. Okay, so our last talk for the session before the coffee break is Lars Dominic Baun talking about a project that did not survive, as this graphic illustrates, and I don't know if there's any relation to GUIX. Well, we'll see. Let's just listen to it.
Of course there's a relationship to GUIX. But I will get to that. I will get to that in a second. So yeah, I'm glad I'm here. I'm glad you're still here, even after two talks. And I was going to show a demonstration, but it's unfortunately not possible. So I will just show screenshots. And I was also going to scribble notes onto the slides. That's usually what I do, but I cannot use my laptop. So you will see everything in advance that I'm going to show you, which I hope will still work. So this talk is about PsychNotebook, and I'm pretty sure that no one in the room has ever used PsychNotebook. Anyone? No, not even you. Okay. So that's what I have the demo for. And so since I cannot use my laptop, just imagine that I'm typing these commands to spin up the demo. And then I can go ahead and show you the UI of PsychNotebook. And the thing is, I cannot show you the real PsychNotebook anymore because it doesn't exist anymore. It was turned off in end of September this year. And I will get to the reasons why. And what I'm showing you here is kind of a mocked interface. That means we're using this to just show changes to the user interface and just to demo the user interface. But it has the advantage that we don't need the server anymore, right? Because it's turned off. So we started the main page, which introduced our goals and the features we had. And the idea was that that your code is organized into so-called projects. So let's just head over to the projects page. And yeah, you see artifacts of the fact that this is a mocking UI through the very weird titles and descriptions. But nonetheless, you can see here that we have a tab called My Projects. These are private to myself. These are my private projects. Then we have a tab called Shared Projects, which are projects which have been shared with me by other users of this platform. And we have a tab called Public Projects, which are, for example, I don't know, tutorials for R, for example, which every user of the platform has access to and can use or copy. And since my demo is not working, I cannot create a project, but I can quickly show you around what it looks if you would click on the project. This is a project page of one of these imaginary projects. And first of all, a project consists of a set of packages and a set of files. So what we have here is, first of all, a button to manage your projects, your packages. And it's a pretty standard thing. You have a search UI and you can type foobar and then you get a set of packages that, in this case, don't match at all. But again, that's due to the mocking. And you can install them and then just, apply all of your changes. So far, so good. We also have a simple file manager, so you can upload your files, download them, create folders, whatever you're used to from your standard file manager as well. And other features of projects, or what also was possible with the project, was that you could share the projects through a link with some other users on the platform. So they would appear in the other users' shared project tab that you saw earlier. And you can also publish the project. That's what the public project tab was for. So if you have a nice tutorial for R, you can just share it with the world and everyone can use it or try it. You can also export your entire project as a table, or you can make a copy if you don't want to break anything and work on some experimental stuff. And then on the bottom, you have applications. This one's called Louis. I have no idea what it does, but just imagine that it's, I don't know, RStudio, Jupyter Lab, why not Visual Studio Code, or we also had a request to install JASP, which is a kind of a click-through statistical program for statistical analysis. So whatever runs in the browser, you can basically install here and run. And if you click that button, you get to this full screen view, which again, since it's marked, doesn't show an actual user interface, but that's what it would look like from the user interface perspective, at least. Yeah, and that's already most of what we show to the user, most of what the user would interact with, because most of the user's work would actually happen here in RStudio or Visual Studio Code or Jupyter Lab. So I have to go through a small disclaimer at the beginning as well, because I'm not here in the name of my previous employer, which is the Leibniz Institute for Psychology. They built, or they paid for this to be built, and I built it. But I'm not talking on behalf of them. I asked them nicely whether I could give this talk, and they said yes, apparently, because I'm here. But whatever I say, please don't try to hurt them. Just come to me if you disagree. And secondly, like many of the other presenters here, I'm also a contributor with Git access to GNU GUIX. So that kind of skews my views on how reproducibility should be approached on the software side, just as a quick remark. So let's get back to Psych Notebook. The talk's title, which I actually made up before the platform was turned off, thus the correction in the introductory slide. The title is derived from the job advertising for a single developer position I applied for in 2019. And it said, Psych Notebook is intended as a web-based research application to support collaborative, low-threshold code-based, and easy-to-archive study planning and data analysis functionalities. And it was published by my then employer, Leibniz Institute for Psychology, which is a German, maybe let's call it infrastructure institute for psychology. So they provide psychologists with a way to archive their work, a way to research, find research papers, and various tools around psychology research. And Psych Notebook was supposed to be one of them. And so, yeah, the intended users of this application were obviously students and scientists from psychology. And it was supposed to have 3 features: collaboration, low threshold coding, and archival. Collaboration means that multiple people can work on the same code. For example, I don't know, I can share my work with my colleague and we can work together on it. Or even the instructor can share some homework with his students. And they have to fill out some Jupyter Lab notebook and do the coding in there. And easy to archive, because Leibniz Psychology, as I said, also offers a service to archive your work. It's called Psych Archives. And that would be the natural target for archiving software projects to this Psych Archives platform. And low threshold code-based, because, as I said, the application was aimed at people without any formal computer science education. And without computer science education does not mean they're not programmers. I have met people who run their own Linux boxes, who apt-get and git clone all day. But sometimes it takes them some fiddling and it's not very easy for them, right? It's also not their main job. It's not what they're supposed to do. They're supposed to do research and not mess with software dependencies. And a lot of the psychologists really are not software developers, especially the students who are just getting started with their data analysis and who are just learning how to even use R, for example. They're not programmers at all. And part of that can be solved through education, like tutorials and introductions to programming. And as I said, we used Psych Notebook to publish these introductions. We used Psych Notebook to have a group of students sitting in front of it and doing R introductions. But that's kind of not the topic today. The other part is getting the software to the user and allowing them to code and collaborate without guessing and without fiddling with these dependency. And this is Psych Notebook. You will note that we are attending a workshop about reproducible computing, and reproducible is kind of absent from that list. That's why it's crossed out. But I feel that reproducibility is already in there, because both collaboration and archival lead to reproducibility as a requirement, as I hope we will see by the end of this talk. And just some quick words about how psychologists work, because I feel that is probably not something everyone knows. So a lot of them actually work with proprietary software, like statistics software, like SPSS, for example. And obviously, as a open science institute, Leibniz Psychology tries to push them away from these solutions and towards more open software, like R, for example, which is the de facto programming language for statistical computations. And the most natural choice for an IDE in the R ecosystem is RStudio. Jupyter Lab, as I mentioned, is also used, but mostly for teaching. And as I said earlier, as we over the years, we've also had requests for different software, like the statistics software JASP, which also runs on Psych Notebook. So obviously, we are not the first ones to tackle the problem of providing software environments to users. So why not just use Jupyter Hub or Binder? I think we've heard a talk about this, which, despite their name, can actually also run RStudio. And there's also RStudio Cloud, which is the commercial offering of POSIT. It's the parent company of RStudio. And as for RStudio Cloud, I have never used it. It's probably fine for this purpose, actually. I believe they do implement collaboration, even this fancy Google Docs style collaboration where you can edit the same code at the same time. And archival and, to a certain degree, reproducibility can probably be solved through renv and its friends, which basically record the installed R packages you have right now. But, well, buying RStudio Cloud and then basically giving it away for free was really hard to justify because, well, we're still talking about public money, and so that was out. And next up, Jupyter Hub. When I looked at it in 2019, Jupyter Hub was a very, very thin layer above whatever technology you're using to run Jupyter Lab or Jupyter Notebooks, which is basically the same. And all it did was user management. You still had to manage the installed software yourself. You still had to upload data and code yourself. And it wasn't, at least in my feeling, it wasn't easy at all. It wasn't low threshold. And often you had to resort to using the shell to achieve something, like, for example, installing packages. And from an anecdote I heard, it's also not very easy to administer, as this diagram shows. So administrators of a university told me they have a custom course management, and then they spawn a custom Jupyter Hub for every course they run. And then this Jupyter Hub, for every user they have, spawns a Docker image. And you can either use the Docker image that is blessed by them, kind of, which hopefully contains your software, or maybe not. And if it doesn't, you have to basically build your own Docker image, which is not really low threshold and easy, and then publish it to a Docker registry as well. And I don't know how to do that, to be honest. And I built all of this. So I think that's also kind of out of scope for psychologists who just want to do their statistic stuff, to expect them to do that. So when I started my job and I looked at how the Jupyter Hub prototype someone else installed worked, I wasn't really happy, to be honest, because it simply couldn't provide what we wanted to have, what we needed. It couldn't provide persistence, so if you copy and paste that apt-get command from your first hit of Google, it would just be gone after you restart your Docker instance, for example. And package installation is a total mess of language-specific package managers like pip and rs install packages, as well as I mentioned, Debian's apt-get, and then maybe mixing in some custom software that you fetched from a random Git repository. And collaboration is also tricky because Jupyter Hub basically expects you to implement this yourself through shared folders, at least when I looked at it. And the final reason we didn't go for Jupyter Hub or Binder Hub was that there was no Kubernetes installation at that time, and my colleagues were still trying to figure out OpenStack, which is a very hard problem, and so we also didn't use that. What I did do was I looked into OpenStack, which is providing virtual machines, and I tried to use that to, I experimented with it, and I I tried to provide a static base image and then experimented with snapshots and to have this persistence when you turn off the machine and turn on again, that you have all of your installed software again. And yeah, I also wasn't really happy with it, with how it worked, that it used a lot of storage, that it was rather slow, and that there was no way to collaborate really. And so I discarded the idea of using OpenStack and virtual machines as well. And side note, in the end, OpenStack was actually discontinued at our institute, and everything moved to a managed Kubernetes installation. Ouch. So let's take a step back from existing solutions and see what we actually need. For example, to simply run our studio on a remote Linux machine. And this is what I would do. I would just SSH into the remote PC. I get a shell. I start RStudio, and I point my browser at the port that I started RStudio with. So far, so simple. Now, as I said, the command line is not really a suitable tool for psychologists. So imagine I have no idea what SSH is and how to use a command line. That means we need some kind of abstraction, maybe like a fancy web app that magically starts RStudio for me and also provides file uploads, for example. Then I could simply connect to this fancy web app with my browser, and I don't have to worry about SSH anymore. And this is basically what the Psych Notebook front end does, what I showed you, the UI. It literally, with some magic in the backend, connects via SSH to a remote server and issues a command to start RStudio or Jupyter Lab or any other application that you might want to start. There are some issues though. We can easily secure the web app with a proper TLS certificate, but we would also have to do the same for every application, right? And then what about Joe, who also wants to run his RStudio? Which port does he bind to, like when I'm also running my RStudio? And if RStudio binds to a port and there's no authentication for ease of use, obviously, then can't Joe connect to my RStudio as well? And what if we have multiple Linux boxes because there's so many users and we just need more compute resources? How do I know which RStudio, and I still have to connect to this particular instance, how do I know which instance I have to connect to actually? And so on and so on and so on. So in essence, we need a solution for the problem that is, how can each user securely access his own and only his own application? And there's two components involved in the solution for Psych Notebook. First of all is a very quite boring SSL reverse proxy like Nginx, which handles traffic to the web application and also to the second component. And to ensure the second component, that is a self-service reverse proxy. And to ensure that only the user who started an application can talk to them, we bind them to Unix domain sockets instead of ports. And for these Unix domain sockets, file system permission checks apply, and so no unauthorized user can talk to them. And then the client, which is started by the fancy web application, the client to this self-service proxy, connects to the proxy machine, again via SSH, because we already have that, we already have authentication, we already have users, and ask the proxy basically to create a new route. For us, it was under the subdomain user.psychnotebook.org. So if you start an application, your application maybe runs at joe-rstudio.user.psychnotebook.org. And this route can only be accessed when you know a secret in the form of a cookie that you have to supply. and the secret can be fed back to the web application. And so the web application can simply redirect you to the appropriate destination with the appropriate secret. And we can also use wildcard certificates for this user.psychnotebook.org domain. So basically every route, even as short-lived and as custom as they are, they can be protected by SSL. And now for collaboration. So imagine I and Joe, we want to collaborate on some project and want to share our code and data. And we can assume that all of our data is on the same server. I can just give Joe access to my files via access control lists. And that works as long as it's just Joe and me. But as soon as we want to invite Alice, for example, we kind of have a problem. Since we, Joe and me, have been working on the project together, there's now a mix of files owned by me and Joe. There's like the purple and the blue over here. And neither of us, since only the owner of a file can grant access, neither of us can really invite Alice because neither of us can change the access control list for all of the files. So the natural solution for this would be Unix groups, because you can just assign a default group to each file, and then Alice can simply be added to the group instead of just giving her permission to every file individually. But usually only administrators can add groups, and so we need another self-service for that. And that's what we do in PsycNotebook to share projects. We actually create a new group for every project that's shared and simply add the users to this group. And all of our users and groups live in LDAP because that's generally well supported, and our custom self-service can just ask to create a new group, and if you're already a member, you can also add new members to this group. And while we're at it, this self-service also handles user creation. So if someone registers through the web front end, we just ping the self-service and ask it to create us a new group, create a new user. And also delete users, obviously. There are some challenges with this approach, though, because some applications, as we found out, will always set wrong permissions so that only the owner can access files. And that's why we had to patch, for example, JupyterLab, because only the first person in a shared project to start JupyterLab could actually use it, because then it would create a file that was only readable or writable by this single user. And every subsequent user who started JupyterLab would just get a blank screen because it didn't have access to this crucial, apparently, file. So we patched the project and it worked. And it's kind of also caused by what a project actually is behind the scenes, which I'm going to show next, or which I'm going to motivate through this example, rather. Because very early in the project, I noticed that code supposed to introduce students to R looked like this. And when I was preparing this talk, I actually searched Google how to load a CSV file in R, because I'm not an R expert, unfortunately. And this is exactly what Google gave me, again. And imagine an instructor now shares this code with his students, and they copy the code to their home directory, which is not Joe, probably. And it will simply not work. It will refuse to work because it cannot access Joe's home directory. So basically, user habits could totally break project sharing if we didn't account for them. And another issue is package management. In theory, we could just install all required packages on the server globally, visible for all users. And that would work fine until that instructor from last year would try to teach his course again, unmodified. Because in the meantime, we probably upgraded R, installed some packages, upgraded some packages, and yeah, it will just break. And also, we don't really want to deal with package management as administrators of the platform, because we would get a lot of requests, please, can you install this package? Please, I need this RPM, for example, right? And so a project needs to be self-contained in terms of the code and the data it contains, and also the packages that are installed, so you can move it around and share it. And when using a project, it must present itself to the user and to the code that is running exactly the same way, no matter which user is running it or where he is running it, so which file system location it's located in. And PsychNotebook uses GNU-GIX to solve all of these issues, even though the users never know that they're actually using GNU-GIX, as you've seen in the screenshots. There's an attribution page, but from just using PsychNotebook, users will never know they use GIX on the back end. And to solve the package management problem, we use the channels.scm file to pin GIX to a specific version for this particular project. And we use the manifest.scm to declaratively list all of the packages that are installed. So the web front end basically modifies the manifest.scm file and just adds a new package if you tell it to install a package. And if you then apply the changes by clicking the button, it will merge these two, so the channels.scm and the manifest.scm, into the GIX profile directory, just as a normal GIX installation would. So this is exactly the same for every project as you would have in your normal user home directory, for example. And then RStudio and Jupyter Lab are also packages in that sense, even though they contain a hidden metadata file to tell our web front end that it can actually start them and it can actually present them to the user. That's how the web front end knows that, I don't know, Bash cannot be run, but RStudio we can run and show. By caching these two files into the GIX profile, starting an application is almost instant because we don't have to, I don't know, build a Docker container first or fetch some files from a registry. It's all cached, and yeah, application starts are pretty much instant. And we also have a file called workspace.yaml, which contains some basic project information like the title you saw, a description, and this is mostly intended for the web front end to show what this project actually does. And to achieve separation from the rest of the system, we literally call GIX shell in the front end. So the front end literally tells the server to run GIX shell and create a new Linux container, mount a project directory to home Joe user, and change the apparent user also to Joe user. And so every project will live under this home Joe user, and it will always run, or it will always appear to run as Joe user, which means the problem I showed earlier of people using absolute paths, for example, it's fine, because if you copy the project, it will also be at the same location. And that also comes with kind of a downside, though, because if the project is basically your home directory, then all of the applications think that they can store their settings in the project directory, which means that if you customize an application, I don't know, you need that special color scheme for your RStudio editor. It will also be confined to this particular project, which means if you create a new project, the new project will completely not know about your change in the application settings. So this is kind of I guess a mixed bag, because you never have any problems with applications depending on data or configuration outside of the project. But yeah, you have to do all the configuration again. Yeah, and it also means that we can be pretty sure that the project is going to work for Alice, though. And I think that's what matters in the end. And I think that's about most of the important architectural decisions that we made. There's lots of small stuff that's probably not very interesting. But yeah, these are the big architectural strokes that we made. As you've seen, we have a lot of custom separate tools which nicely uphold the Unix philosophy, even though we're basically running a web service or web platform. And I feel it's rather unorthodox, but it's also the reason why administration and maintenance is mostly orthogonal to just running a standard Linux system, and therefore rather uninteresting to talk about. One thing that definitely helped keeping the platform running, though, was structured logging. And all of our tools basically output or log JSON encoded data, and thus analyzing these logs is very simple and very fast. You can also automate that pretty well. And for example, we often had courses running on Slack Notebook, and I would just be streaming the log and running my automated analyzer on the log and seeing live which applications failed and why they failed. And even while the course was running, I could fix the problem without anyone submitting a bug report or even noticing, because they just saw, oh, it didn't work, let's try again. Oh, it works again, nice, thank you, right? Yeah. And so I feel that's a very, very nice way to proactively investigate reasons why the platform failed and to fix these issues before, as I said, someone even has to report a bug. Another thing is that in the beginning, we also had users requesting GUIX packages for existing R packages quite frequently. And that was so frequent that I decided to create a GUIX cron, which is a GUIX channel, as we've already been introduced to. And using GUIX's excellent importer, a script runs every night to turn all packages available on cron simply into a GUIX channel. And we then just add this channel to the default project template, to this channels.scm, so that every user can install basically every package from cron into every project without having to ask us. And that reduced the maintenance effort for these requests like, oh, can you please install, or can you please make a package for this, to basically zero. We had some where packages are not available on cron, for example. They just live in a Git repository, but I don't know, that's a no-brainer then. Packaging, though, in general, is a pretty big topic, and upgrading RStudio, for example, or JupyterLab, which rely a lot on Node and NPM, the package manager for Node, so the JavaScript environment, is a very big pain point, to be honest. And for NPM, the problem is that the dependency graphs are usually so big that you have to automate creating these packages. You cannot go and create 600 dependencies by hand. And thankfully, some fellow Geeksers wrote an importer for NPM, And we use that, for example, for our studio package. And still, to me, it seems the world has kind of moved on from distributions and to a weird state of, oh, we have a Docker image, just use that. And often that goes hand in hand with the fact that there's no documentation to build packages. You have to figure this out yourself. And that's a real pain point when maintaining such a platform and maintaining packages for RStudio and Jupyter Lab, which heavily rely on this node infrastructure. Yeah. Next. So I think I have to turn to the inevitable topic of death. Because as I mentioned in my introduction, PsychNotebook does not exist anymore. It was turned off end of September, I think. Even though we had a few users and we had used it for lectures, and we even had talks going on with some universities about them basically doing their courses on our platform. So the question obviously is why? And I feel this was twofold. First of all, it was an organizational failure. And secondly, it was a technological failure. Maybe not. I'll have you judge that. So as I mentioned in the introduction, I was the only developer for this project. And obviously the institute I worked at employed more developers, but they were mostly PHP developers and they had their own projects and their own applications. So they didn't have to do, they weren't involved in PsychNotebook in any way. And yeah, for PsychNotebook, I've been writing JavaScript for the front end, Python for the back end, and Scheme for everything GUIX related. And so being sick or going on holiday meant that if something would have broken, it would not be repaired until my return, or I don't know, until I got my laptop out on my holidays and fixed it, because there was no one else. Fortunately, that never really happened because the platform was stable enough to survive my 2 weeks of holiday. What did happen though was that I had to leave the city of Trier, which the institute is located in Germany. And 100% remote job was not possible. So through leaving the city, I also had to leave behind my job. And a successor was never really searched for because we assumed that someone with the skills required to maintain this platform. As I mentioned, we have lots of different technologies involved here. Would be very hard to find in a kind of remote city in Germany. And there's also like an Amazon next to it in Luxembourg, I think, where you can get a lot more money for doing a lot more boring work, I guess, but well, it pays more money. And a lot of people go there, actually. So it's very difficult to find good developers in this particular city for governmental work, essentially. So when I left the project, it was basically left on its own because there was no one left to maintain it, even just to the degree of keeping the lights on, like looking after it and restarting that service that crashed. And so they had to turn off. And I feel that's how a lot of projects in science end up dying, with the original creator leaving. And because they're usually one-man projects, at least in Germany, I feel the situation is better in France, at least from what I heard. So with the original author leaving, no one is able to step in and continue this work. Secondly, maybe we also saw a technological failure here, or a failure of choosing the right technologies, right? So, as I explained earlier, the technology we used was rather unorthodox, and GUIX, I'm very sorry, Ludo, is still rather unorthodox. Like, not a lot of people use it, and not a lot of people know how to use it, how to deal with it. And for that reason, staffing would have been very difficult, and maybe choosing an existing standard solution like Jupyter Hub on a Kubernetes, which people at our institute knew how to use, both Jupyter Hub and Kubernetes, would have been a wiser choice in that sense. And yeah, essentially we had to turn off for that reason. And we did consider moving PsychNotebook to Kubernetes actually, but I felt that these two worlds, the world of Kubernetes, the cloud world, and this GUIX world that we created of assuming that we have local users and have a service that creates users, didn't really match, didn't really fit together, so we couldn't really move the project to Kubernetes. And also, yeah, choosing SSH and Unix users, as I said, all of these little decisions that I showed, maybe choosing them differently would have allowed us to continue this platform, to keep it working. But yeah, it died. And so I'm standing here today wondering, and usually it's you asking the questions, right? You're the audience. But yeah, I'm standing here wondering, like, what did go wrong? And I try to present the answers and try to present what we did and what I know as best as I can, but I don't have an answer for the questions I have here. I might have a gut feeling, but it doesn't mean I'm right. So one of the questions is that, like, should we even build platforms, or should we maybe rather build tools? Because as we've seen, platforms die, and I don't know, Google is very good at killing platforms, for example. And yeah, platforms tend to make things easy, and PsychNotebook was definitely easy for the users, easy to install packages, and easy to run Jupyter and RStudio. But yeah, it doesn't exist anymore, and all the users we had to move somewhere else and cannot use their code and their data anymore because it's gone. And I feel that around tools we can build communities, and the maintenance burden can be distributed, even though it's not the case. Often it's not the case because there's like a small maintainer group, but in theory it can be. And even if someone from the maintainers moves on to a different project, other people can step in and do the work, which is not possible if you have a platform because, well, it died. And the second question is, should we use exotic technology, or should we rather use mainstream technology, which everyone knows, which might not solve the problem 100%, but maybe we get the 80%. Or should we use tools like GUIX, which I feel personally is the 100% solution, and the solution that gets us, yeah, very, very, very close to shareable code, but also that ultimately no person from psychology would ever use if we didn't have PsychNotebook, the platform. So yeah, I don't have any answers. Maybe you have.
Yeah, thank you very much for this thought-provoking questions in the end. So turn things around a bit. Does anybody have an answer?
I have opinion.
Opinion. Let's start with that.
I'll take opinions.
We'll synthesize the opinions to make an answer in the end.
So I don't necessarily have an answers. I have opinion. I will not claim they are the right ones, but I do have some. So I will start from the second question because I believe that is easier to answer. I think exotic technologies are completely fine because they allow unlocking doors leading to interesting results. Like what you presented here seemed like a really interesting tool, which off the top of my head I have trouble thinking how to detailedly replicate based on RPMs or whatever. That would be annoying to attempt. So I think exotic tools are fine, which leads to answering the first questions. Platforms are also fine, assuming there is enough stuffing, which was the problem here. One thing that stood out to me, you mentioned that fully remote position was not an option. Like, I don't know what's the policies at Leibniz Institute, but I'm wondering why. Like, if it would be remote positions, wouldn't it be easier to find two people across the whole of Germany that would be able to at least learn the stack?
Yes, I definitely agree that that it would be much easier to find people if you're not confined to a small location where the institute is located. But unfortunately, these policies are not made by people like us who think this way. They're made by people who believe that in-person communication is very important because they work this way, right? So people at the managing level, I feel, work a lot through communication, through meeting people, and not through writing code. And so they don't see this this opportunity that you can do things fully remote. They see the lack of communication. They see the lack of in-person meetings. And so the policies they set are obviously reflect that. And yeah, that was one of the policies that was set by the institute management, obviously.
Thank you. I just wanted to agree with my colleague that it is perfectly okay to use whatever, however you call it, like exotic or experimental, whatever, but like at the moment when you are starting some kind of software project, you need to architect or design like sustainability as a feature into it. And you need to be clear how you are going to do that. Like if you are starting with like well-used technologies, like let's say Kubernetes these days, you can say, okay, like there's enough companies supporting that, enough developers around, like they wouldn't vanish in the moment, and you have less work to do. If you are starting with like some technology which is niche, you need to basically immediately start building some kind of community around it. Like if you think that like it will appear sometimes later, and if you bound everything to yourself or single person, you are just like planning for failure basically. So like this needs to be done since day one as a key thing in a project, and then you can be successful, or you can evaluate after some time. You see like you tried to build larger, like at least few people around you and nobody is interested, like you can evaluate like, okay, maybe it's really bad idea, but like, yeah, you need to think about it from the beginning, basically. And I did it a couple of times with Nix, for example, and I saw the negative result and I saw positive result, and it was always tied to the building community around those people, basically. Thank you for presentation.
Hello, thank you for your talk and for your energy to build this kind of platform, because I'm not really an informatician, but I try to explain to students why they shouldn't use spreadsheets to perform their analysis, to make it reproducible with a script, etc. And in our university, we have RStudio on every computer, but each time they have to install packages, they have to install everything. So the first part is, actually I will do that to make him happy, and then I will go back to my spreadsheets because it's too complicated. So why should we build these platforms? Only for teaching, maybe, because it's really, it would be really interesting for guys who don't really know how to start, and being able to connect to a platform with every package you have required for a teaching course or anything would be really great, because a student could load their data and start learning programming without having all this stuff of installing things or dependencies, things or anything. So I think it's important to move on like this. Thank you.
Yeah, we've seen that with courses actually that are being taught, and then students bring their laptops, and the first half an hour you're there setting up RStudio and installing packages. So yeah, true.
Hi, thank you for the talk and for interesting experience. I wonder if you're not giving too much weight in your analysis to your personal perspective on the issue, whereas maybe for the management it was more about the added value of having such a tool, because it was and that's actually connects to the fact that you didn't show in the presentation. I mean, I say that because I don't have an information that you could have shown is how many people were using it, how much, maybe I zapped and you showed that and I didn't. But what was the uptake and how was it perceived comparing to other alternatives? Because in the last few years, we've seen other kind of automated code on browser code platforms emerge from Google, and people have been using those, and maybe just from their perspective, it was like, we're doing this, but it costs us something, and we can do the same. People are doing the same on Google Code wherever, so why keep on? And maybe it wasn't really a technical issue. It was more like a political management issue. You know, how would those things interfere, and how do you think this could happen?
I don't want to like badmouth psychologists, but I feel they're very low-tech people, right? So even going there and be like, hey, use some Google tool for that, usually that doesn't happen. Like they really install RStudio on their PC and do all of this manually. And so your theory was that we didn't add enough value, kind of.
I don't know. Had people update and were using constantly this platform?
Yeah. So as I said, we had users. I don't have any numbers, unfortunately. I think we had like 120 concurrent users at one point, and like, I don't know, 30 or 40 daily, monthly active users or something like that. And it would rise and drop with the courses and with the semester, obviously, because this tool was used a lot in coursework for semesters. And as I said, we had talks with universities to expand this. Yeah.
And now that it's gone, why are they using it in the course?
I think they're going back to just installing RStudio on their PCs, which is a shame, but yeah.
The first question, should we build platforms or tools? I've got an opinion on that, because I've been building something very similar to what you have built. I mean, we've talked about this before.
Yeah.
Because we're also using RStudio, we're also using Jupyter Hub, and this idea is very persistent throughout bioinformatics, to have a platform like that with data sharing and so on. It didn't help us that we used more mainstream technology, and you were using mainstream technology in SSH, for example. That didn't help. We are using AWS rather than local
servers, which is more mainstream, but it does not make the whole project that we have any more sustainable. The big problem we saw with building platforms is that adoption is take it or leave it. So you either take the whole platform as is, or you don't. And it's what we started doing, because we found the same sort of issue with staffing, that we should split up the platform into independent projects. It seems like more maintenance work, because you've got project management for every single component now, but there are people who can adopt individual components that don't care for the whole platform. And perhaps avoiding this tightly interlocked components in the platform, and instead building independent tools that can have their own following and live or die on their own terms, would be a way to keep some of the parts anyway alive for a little while longer than the platform would be alive.
Yeah, and that would also be the idea of Jupyter Hub, for example. It's a tool that people deploy as a platform, so it's not a software collection built for a single use case. So it's one of the bit strange.
I mean, technically you can go to this address and download all the components and install it yourself. So we were lucky enough to free all the software we built for this, but it's a bit of work, to be honest, and I'm not sure it's worth it for a lot of people. But go check it out and see if you can reuse some of what we built.
Yeah, maybe we should take this as the final word and continue discussion during the coffee break.
Thank you.
Thanks again.
On va vérifier tous les deux, parce que moi il faut que je vérifie aussi le mien.
D'accord. Mais comment on fait pour vérifier?
On va le projeter, enfin moi je sais pas, il doit être sur
le l'ami Céline, je l'ai envoyé à 15. Pardon.
Je sais pas.
Je te l'ai envoyé sinon. Quelque part pour être filmé?
Ben là, a priori, je pense.
D'accord, on peut prendre un micro pour se déplacer, j'aime pas rester statique.
Moi, pas trop non plus, mais ouais, je veux pas prendre de risque.
Ouais.
Bon, attends, je vais essayer de faire.
Qui c'est qui? Tiens, je vais poser la question.
Oui, j'ai reçu, je regarde. Oui, il a envoyé comme j'arrive. Non, je me connecte en mail là, et puis je le télécharge direct. Quoi?
you're going to be able to try it. Did you have a certain
Ouais, c'était 7 mégas, donc je sais pas si tu l'as vu, du coup. Non, mais c'était juste comme je l'ai mis en compteur.
Alors, non, parfait.
Bien sûr.
Parce que j'ai vu qu'ils avaient rien.
Je peux essayer la présentation? Ouais. Je fais comment alors?
C'est l'autre onglet en fait.
Super. Et après, je fais passer en plein écran. C'est F5, c'est ça ou pas? Non. Un problème? D'accord. Super. Et pour le... Là, comment je fais pour envoyer là-dessus? Pour envoyer ça là-dessus? Marche pas? D'accord. D'accord. Oui, mais c'est bon? Oui. Ouais. Et donc du coup, ouais, je peux prendre un micro, elle m'a dit, je l'allume comme ça. Ah d'accord. Vous coupez pas pendant les pauses? Vous coupez pas pendant les pauses? D'accord. Bon. Ça marche. C'est par là, c'est ça? C'est par là?
Oui, en fait, Céline m'a dit qu'il y avait un problème sur une fonte.
Ah.
Mais a priori, il y a l'air d'être... En fait, je sais que j'ai un slide.
Oh, regardez, c'est cliquable. Ça t'embête si je.
Ah, vas-y, je t'en prie.
Est-ce qu'il y a des trucs qui sont cliquables ou pas? Internet.
On va avoir du code tous les deux.
Ah oui, mais il y a pas mal. Attends. Clique là. Est-ce que ça marche? Autoriser. Et ça marche, c'est cool ça. Ah oui, mais est-ce que ça sera diffusé? Tu le sais si c'est diffusé si je prends un navigateur à Paris?
Oui. Normalement, c'est l'écran qui est en screen share.
Ah, génial.
Tout à l'heure, les gens ils ont fait avec
Ouais. Ça, d'accord, ok, super. Cool.
C'est CTRL L si tu veux.
Ouais, ça, j'ai.
Oui.
Ouais, c'est vrai que c'est plus simple, c'est mieux quand tu connais.
Qui utilise Adobe Reader en même temps.
Oui, et Vince, tout le monde.
C'est ça.
C'est pas Vince non plus.
Ah bon?
Ocular ou
PDF
Tools dans les Macs, non?
Ben oui, mais théoriquement oui, mais non. Mais oui, avant j'utilisais ça juste là.
C'était le PDF View qui de base qui est quand même dégueulasse, mais
non, c'est comme il faut des dépendances natives et moi je n'utilise pas GUIX pour mes paquets Max parce que j'ai jamais fait le switch.
Alors j'ai fait un, justement j'en avais marre, j'ai craqué ce mois-ci, j'ai fait un Emacs en X, mais un Emacs préconfiguré en X.
Parce qu'en fait le truc c'est que ça m'arrive d'utiliser Max Windows. Et donc là, si tu pars du principe que tes paquets sont...
Après tu as WSL.
Ouais, mais j'utilise un Max natif.
J'utilise jamais des trucs comme X2Go qui permettent d'aller te connecter sur une machine.
Déjà, non, mais en plus, souvent j'utilise Max sur ma grosse machine parce que c'est plus agréable et surtout parce qu'en fait elle est plus puissante, c'est ma tour. Enfin, voilà, après peut-être que juste je vais me dire à un moment, bon, on va utiliser Max Windows. Et puis voilà.
De toute façon, c'est toujours sympa d'avoir un lecteur externe, parce que même PDF Tools, il est quand même moins.
Typiquement, le scrolling est chiant. Ouais. Tu peux afficher l'image à la fois. Il y a des gens qui travaillent là-dessus, mais c'est un peu en. Il y a des gens qui ont mis des PR sur PDF Tools.
Ah ouais, c'est vrai, d'accord.
Mais c'est très instable.
D'accord.
Mais oui, je me suis fait critiquer pour ça.
Ah ouais?
Hier, quand j'étais en train de préparer mes slides, quelqu'un regarde et fait tu n'utilises pas PDF Tools. Alors que c'est vrai, j'utilisais Emacs, quoi.
Moi, j'utilise pas Emacs, figure-toi. J'ai utilisé Emacs il y a une vingtaine d'années.
Faut pas dire ça trop fort.
Et non, j'ai du mal. En fait, ne serait-ce que pour l'histoire de scrolling à la con.
Alors ça, c'est réglé, ça t'a
Ah ouais, parce que l'autre jour, j'ai essayé ça et c'est pas possible.
C'est vrai que c'est de scroll par défaut sous Emacs, c'est un peu
nice. Ne serait-ce que pour vérifier, tu sais, les parenthèses et tout. En fait, ok, ça scrolle tellement de trucs que tu vois plus où est ta parenthèse. Donc
mais en fait, moi, j'arrête de scroller à la souris. J'utilise juste CTRL-V, MetaV pour scroller de... Ça dépend de ce que tu scrolles. Ça, plutôt pas mal. Mais bon, enfin, je commence vraiment à avoir une lexite aiguë où dès que je suis dans un navigateur, j'appuie sur CTRL-W pour couper et ça confirme mon onglet. J'ai l'air super malin après.
C'est marrant, j'utilisais beaucoup quand j'avais fait mon mémoire d'AG. En fait, j'ai tout fait sur Emacs et la tech et tout, et tu perds quand même assez vite les habitudes.
Ouais. Maintenant, du coup, moi, je tourne, en fait, j'ai plus rien installé sur la machine. Je lance un Emacs, enfin, ce que j'ai configuré, enfin, que j'ai mis dans mon X HPC là, et je rajoute X4 et éventuellement les Vince et Ocular.
Mais t'as besoin de quoi d'autre en même temps?
Non, mais tu vois.
Tu fais tout ça dans les GUIX, j'imagine?
Dans un GUIX,
ouais. J'ai de moins en moins de trucs dans mon profil et en fait tout est sur des GUIX. Et puis, même tu vois la compilation complète de ces machins-là, en fait elle est faite dans un GUIX.
Ouais, après GUIX emboîté parfois c'est pas...
Non, c'est génial, parce que c'est pour moi quand on dit d'application seconde, c'est pas par projet, c'est ça. Et du coup, c'est Gérard, qui est la version, il y a deux versions, la même qui est bien et la version qui est pas retard.
Après, j'imagine que vous mettez un git commit sur vos GUIX pour éviter que... Parce que l'autre jour, là, j'avais fait un GUIX pool, je reviens, je relance mes compilations de slag et là je dis oh merde. J'ai mon chrono normalement, ça me permet de regarder un petit peu.
Tu te lèves au bout d'une demi-heure.
C'est 45 minutes, c'est 40 minutes.
Si tu veux, moi j'avais prévu 30 plus 15.
Mais tu gardes les liens dans un coin et je les mets chez les autres. Oui, bah, la surprise, j'ai récupéré demain.
Ouais, voilà, t'hésites pas à me coacher. T'hésites pas à me coacher. Je suis parti de coach.
Enfin, je note que si je vais plus vite que... Oui, je note que si je vais plus vite que prévu, c'est pas grave.
Non, bah une autre, ça sera pas trop.
J'y crois pas trop. Le J4, je l'ai passé en 22 minutes, mais c'est en français. C'est pas la même chose. Du tout. C'est quoi la sensation que tu vas bientôt utiliser?
Bah, moi je sais pas, je fais ça.
Non, mais tu pourrais en fait.
C'est vrai. Mais après, vous voyez une fois qu'à
On va avoir le plaisir de travailler sur tes ancêtres.
Ah, mais ça, je suis d'accord. Mais souvent, en fait, une fois que tu as expliqué une fois et que tu fais un petit changement, bon, tu n'as pas besoin pour expliquer, etc. Mais déjà, c'est pas très pareil.
Je suis parti de gens qui travaillent sur les en phase sur la section numérique, les algorithmes numériques,
Moi, je travaille avec d'accord, je travaille avec toi, enfin, ça m'arrive.
il y a des liens pour ça. Je ne connais pas les sites. C'est pas des gens que je connais bien. Moi, c'est peut-être pas mal de les deuxièmes, c'est tu vas connaître des animatistes. Même pas. Ouais.
Ouais, en bas. Ouais, c'est ça.
Ouais, mais alors ça c'est pareil, à un moment, est-ce que c'est bon, tu vérifies sur du code, je l'ai laissé, je suis pas sûr. C'est des tranches d'investissement qui sont assez flexibles. Flexible, mais après ça fait flexible, ça fait pas part de gâteau, tu vois. C'est-à-dire que c'est un investissement, en fait, un budget d'État qui est découvert par oui. Nous, on est tiers 2. On est les deux points. J'ai pas de traduction.
Exactement.
Non, c'est le contraire.
Tiers 0, c'est...
Tiers 0, c'est européen, tiers 1, c'est national, tiers 2, c'est régional, et puis tiers 3. Sur ça, c'est tiers 2 aussi. Oui, oui, c'est ça, ouais, je pense. En fait, grosso modo, tiers 3, c'est plutôt des machines d'équipe, donc c'est plus des petits clusters. Tiers 2, c'est plus régionaux, donc on va avoir pas mal de cœurs, on doit être à une quinzaine de cœurs. Et puis bah, après, tu as les centres nationaux qui, eux, sont, tu rajoutes un 0, voilà, 2 0, mais ce soir, ne t'inquiète pas. Ou même tenir, souvent on est parti avec des... Après, quand tu es bien implanté dans une communauté, tu finis par connaître tout le monde, c'est pas le cas ici. Moi, je connais comment ça arrive. Ce qui est bien, c'est que maintenant, je connais des communautés.
Hi, so welcome back for this last session of talks, because tomorrow we'll only have tutorials in the morning. So it is my pleasure to introduce Yann Dupont, who works at GUIX, an HPC center in Nantes, which has been including GUIX as part of its offer for its users, and who will be talking about how they used GUIX recently to configure their VMs reproducibly and what their experience with the tool was. So, please.
Okay, thank you very much. Don't know if display is okay. Oh, yes, I have to click. Okay, disclaimer, so we won't talk about science. just a plumbing session. I define myself as digital plumber. So I'm mainly doing sysadmin, and sometimes quite a boring activity. So you saw a nice picture of a gas plant. In French, we talk about usine à gaz when we want to talk about some hard to comprehend systems. So sometimes system administration is quite difficult. So we would like to explore how to make this activity more fun and more reliable. Sorry for the accent. Okay, so I worked at GLICID, which is an HPC center for the region of Pays de la Loire. So it's west of the France. We address 300 researchers, and we have currently 3 clusters. We have an old cluster which is not migrated yet, and it's a historical cluster with 6,000 cores, 50 GPUs. We have a brand new cluster which is named Nautilus, which is 50,000 cores and 16 GPUs. And we will have a new cluster in 2 weeks, I think, with 300 cores. So as you can see, we have different networks, all kinds of GPUs, all kinds of CPUs. So it's a very heterogeneous cluster. And this HPC center, GLICID, is part of a bigger project. In French, we talk about CPER. It's a 3-part contract with the region, the French state, and the university, for example. It means only money. We have money for our project. So we have the first part of this project is the Nautilus cluster, which was installed in June this year. And we'll have 2 other slices of investment in the next years. All the hardware is on 2 different rooms in Nantes, 3 kilometers distance between the 2 rooms. And we have only one link between the 2 parts of the cluster. Okay, so I said we have 3 slices of investment. 3 slices of investment means, in French, 3 public procurements. So we have each time some surprise. And we have no guarantee about the fact that we have the same hardware and the same software, because in general, when you buy a cluster, we have the whole package, that is hardware and software. So we took the decision in 2022 to be as much as possible independent of the solutions of the providers. So we have to start a new infrastructure in which the new cluster will be integrated. So this new infrastructure has to be distributed, shared, redundant, because we have 2 different rooms. We keep the previous cluster, which is named Waves. And in parallel of this cluster, we start a new network, open networking fabric. We start storage, which is Ceph storage with SSD, NVMe, and also volumetric storage, multiple petabytes. And we had a lot of service to start, and we want high availability. We have to start a new identity management because we address searchers from the whole region, that is different university, different schools. So we have to start a brand new identity management. And we want to start new services, Slurm servers, for example, for HPC jobs. And one of the goals we want to achieve is simple to redeploy infrastructure, and zero adherence to solution provided by manufacturers. So we made a choice. All the infrastructure of the clusters are virtualized, yes, with KVM on Linux, and it's used by Proxmox servers. And of course, we use GUIX. And why we use GUIX? GUIX was provided on Waves cluster since 2019, and it's really right suited for HPC. It gives autonomy to users, and they can manage the software without having to phone us to install software. It's a good way to escape the dependency hell, because sometimes when you have to compile programs, it's really quite difficult. And the team at Glicid manage some software with GUIX, and we have a channel for that. Didn't start my watch. Okay. So the channel is here. When you make GUIX pool on our machine, you see we have the channel here. What is inside this channel? We add software and services. So some non-existent services like Slum CTLD and Slum DVD, for example. Some scientific packages. We have newer or incompatible version of software. For example, we add libfabric because we use a specific high-speed network which is called Rocky. But Ludo has made sufficient modification on libfabric, and we don't have to change this now. We have specific derivation for software. For example, we have a special version of Slum because we use OpenPMIX. And one benefit is when we define a derivation, this derivation follows the evolution of the main branch. For example, we have QEMU with RBD. RBD is a block storage of Ceph. When we write the package, QEMU was at version 7, but on the main branch, QEMU has evolved, and our version has also evolved. You see, for example, right now it's a 8.1 version. So GUIX is really useful for us, and it does wonders for software reproducibility, but it will be a good idea to try to do the same for operating system deployment. And GUIX, as you can see, when you do the GUIX help, okay. There is a lot of options, and there is one which is GUIX system image to build an operating system. So let's try this. You have just to provide a scheme program to return an operating system object, and then when you use GUIX system image with this file, you generate an operating system. Of course, you know by now, but you have to use guide for that. Everything is its guide in GUIX. At the very beginning, you don't have to really master guide to write an operating system definition. But of course, the more your operating system is complex, the more you have to dive into guide. But there is a lot of documentation and a lot of online help. We have a mailing list. There is in France Café GUIX, which we do every month, I think. So documentation for operating system is really large. You have lots of options. But we have also nice default options. So really, how much option you have to define to make an operating system? So the answer is here. You have only 3 fields. for generating a complete system. And they are quite easy to understand. First is the host name of the machine. Second one is the type of bootloader. So with virtual machine in general, you use grub. And you have the root file systems. And you have only to say it's ext4 file systems. Okay? So when you do that, you just have to generate with GUIX system image the virtual image. The definition here and the result image is here. And you have to launch QEMU with this image. And you have the result. You have a working virtual machine. So it works. We have regenerated a complete image, complete system, complete working system, sorry. We don't have to download something. We have a system which is up to date. We don't have to add something afterward. It works. It just works. Only in 15 lines of code, which is really great. But when you explore the VM, you see that there is a lot of things integrated. So in production system, you have to make some adjustment. You have to remove, yes, it's a bad French joke, sorry. You have to remove some packages, some services which is not relevant in virtual machines. And of course, you have also to add new services and new packages for your needs. And when you want to make a large deployment of virtual machines, you also have to factor lots of definition between the different images. For example, for us, we have, 12 administrators, and we want that on each virtual machine, the keys are included, the SSH key are included. So it's a kind of it's a kind of configuration we want on all our VMs. And of course, previous slide was launched with a QEMU on CLI, but you have to use a more advanced system to launch and deploy VMs. So you can use libvirt and virt manager or Proxmox. We choose Proxmox. I said we use a common template. So what are the definition on these templates? You have a lot of constants. For example, network definitions. You can see here. We have services that are common to all our VMs. For example, I said we use case for all our administrators. So it's here, defined here. We have customs NTP service for time servers. And we have some templates of operating system with we choose packages and services. This operating system is ready for inheritance because we use a lot inheritance. For example, here you can see the definition of a full debug virtual machine. You see we use a module-specific glycid template here, which is this one, but there is a lot of lines. We just have to define a custom network with the definition of the IP address here. So this is the service with the custom network. We define a base OS, base operating system. We define the inherited services, which are taken from the base OS. And we just have to define a new operating system which inherits the base OS with a new host name and the services where we add to the list of the inherited service the custom net. So it's sufficient to define a new virtual machine with all our services. So what do you get with the definition? We get virtual machine with network setting, DNS are set, NTP are set, SSH and the admin keys are set. We have specific syslog configuration, we have Zabbix configuration, we have QEMU agents, we have GUIX channels, and when you use the debug variants, it's the case here, we also add NCC LDAP, NSCD, config by Git, editors, numeric, and lots of debug tools. To build the VM, it's quite simple. We have a shell script. It's just a GIS system image with some tweaks. You see how it works. It generates a disk image, and then we make a DD to save. Takes not much time, 1 minute. So the idea, when you use GIS system image, you generate a VM image on GIX store, on a GNU store image. Oh, sorry, on the GNU store. But we use Ceph, so we have to DD the resulting image on our Ceph cluster. And then we make an image clone with a special name. And we also, once this image is on the Ceph store, we can rename this image to match the name of the Proxmox definition. Who is using Proxmox here? Okay, not much. Once the image is in the Ceph store, we can use this image on all our machines because all our machines in the 2 rooms have access to the Ceph store. Here is Proxmox. So we have a VM definition with processors, RAM, and so on. And the hard disk, which is, this is the safe name of the hard disk. You see, we have the same name that the slide before. There is no deployment script. We don't have to push the image because the image is in the Ceph store. And when you start Proxmox, it finds the image and boots on this image. So now we just have to fill the blanks. And we have to start lots of services and lots of VM to start the cluster infrastructure. So we have load balancers, keep alive. We have 8 keep alive. DNS, LDAP, SSH proxies, block and clustered NFS servers, mirrors, proxies, web server, Zabbix server, database, MySQL, Postgres, timescale, Slurm servers, login on devel machine, which are Slurm clients, and virtual pseudo-computing nodes because there is no power, no computing power, but you can debug with these VMs. There is a special trick for these VMs. I will explain later. We had to create some new services. For example, Slurm services or LDAP services are not on the GUIX services for the moment. We will try to upstream these changes. The interesting result is the fact that these machines are immutable. I mean, the configuration is embedded in GNU Store. You can see, for example, the NTP configuration here, the rsyslog configuration here. GNU Store is read-only. So we have immutable and volatile machines. I mean, when you want to change something, you don't have to touch this VM. We regenerate a new machine with the new settings. and it takes only some seconds to do that. We made the generation. Once the generation is, when the new image is pushed on Ceph, we just stop the old VM. We have a special shell to change the name. It's only a rename. So it takes 1 second. And we restart the VM, and we boot the VM on the new image. That's for stateless VM, but on some cases, we have to store state. For example, when you have to a database, for example, we have to preserve the state of the database between boots. In that case, we use special templates. We have 2 disks. One is volatile and generated by GUIX, and the other one is static. Don't change between the different VM generations. We have a special template for this, and we use LVM2. That's because we find a bug with LVM2 some times ago, so we have a fix pending on that. You have to be careful because when you use 2 disks, if you want to roll back to an old version, for example, you have to make snapshots of the static LVM volumes. I mean, if you change the version between 2 VM, if you want to roll back and get the data, you have to take the snapshot data. Make me think because I don't know how it's okay. For the whole cluster, we have a deployment. We mount a shared new store. Oops. Yeah. We have a special machine, GUIX store intra, where we have /gnu and /var gnu. All our machines mount this storage. And we also have GUIX daemon socket to point to this machine. We have consistent UID and GID because we use LDAP on the whole cluster. And GUIX now is running the GUIX daemon and export GNU and var GNU on NFS for the moment. NFS is not really a good choice for us because we also have CephFS, which is much more speedy and fault tolerant, but CephFS has some problems with GNUstore for the moment because GNUstore has tons of links and the metadata server of Ceph doesn't cope very well with this for the moment. So we have to rely on NFS, but as soon as possible, we will go for this. Mounting GNUstore on all machines works well with Fine Distro because there is no GNUstore, but when you have generated the machine with GUIX, we have a GNUstore, a local GNUstore. So how to cope with that? There is a special trick. You have to mount the shared GNUstore in a special path. Then use overlayFS to join the 2 GNUstore, so the global one and the local one, into another path, and then you mount this path in /GNU. So you are masking the local GNU with the composite one, and then it works. GUIX brings us also responsiveness. For example, in September, we had a security issue with OpenPMIX. We use OpenPMIX on our special Slurm version because the other cluster, which is Nautilus, which is the proprietary one, which is installed by a society, use PMIX. So to have our two clusters to communicate, we have to use PMIX. So in September, vulnerability in OpenPMIX here. So to fix that, it's quite simple, really. It takes me 2 minutes for doing that. So I have just to bump the version of OpenPMIX. You have just to inherit from a closed version. You change the checksum, and we change the public version, in fact. Okay. Once you do that, all the new VM generated use the new OpenPMIX, and the whole dependence is recompiled. So we have Slurm, OpenMPI, etc., with the new version. When you system administrator, we often have the question, why don't you use Ansible, for example? Because Ansible is a mainstream thing in system administration. Well, you can still use Ansible or Puppet or Chef or Salt or whatever. Nothing prevents you to use that. But it's quite a philosophical problem. The difference is, in one case, you generate a complete and fully configured system, written in guide, so you can make lots of intelligent things. You can also use GUIX deploy if you want to deploy massively. And when you use Ansible Puppet, you have configuration files specific to the system used, and then you modify and reconfigure a pre-installed system. I mean, you're taking a Debian or Ubuntu, you don't know how it was made. Okay, you modified to include your changes, but you didn't generate the base. One of the fun facts with GUIX is that you can target exotic architectures. For example, you can target ARM, you can target RISC-V. We have some interest in RISC-V because we think it will be something interesting in some years. So far for Foresight, you can try to generate images for RISC-V. And it's quite simple in reality. You have just to define an operating system the same way that we've done for Intel or AMD. But you only say, OK, I want to target RISC-V. And it works straight away. Of course, you can think, OK, but it does cross-compilation. And yes, it does cross-compilation. I have a nice video, but it's a PDF, so you won't see this nice video. It takes some time. It takes lots of time. I mean, 20 minutes, 1 hour, depending on what needs to be recompiled. And to start the VM, you have to make some changes. Because, for example, on RISC-V, you have to use OpenSBI, which is a standard interface to boot something on RISC-V. And we have to use U-boot, which is the same as a grub, but for RISC-V. And it works. And it's also a nice video we won't see. I don't know how much time. No, it's OK. So, in summary, there are a lot of pros. We are able to make composition of operating systems. We can inherit a lot of common properties in all OVMs. common core. We reduce the risk of errors to a small part. And it took us really long time to define our templates, but now we are gaining a lot of time. We can redeploy the whole infrastructure in some minutes. So it's really good for us. We have the total control of what is deployed, which in terms of security is really quite great. We can even, we have, for example, some specific kernel hardening on some servers. We can integrate specific software. For example, we have our specific Slurm integrated on all OVMs, so it's consistent. We have a lot of constants we can change. For example, networks. During the phase of test and deployment, we change the whole cluster. So the whole addressing has been changed. It only took us 2 minutes to change new networks, a new net address, and we only had to redeploy the whole cluster infrastructure. We have no configuration after the fact, so it limits the error. And we have system reproducibility because Time Machine is usable. We can generate our Zabbix server 6 months ago. So it's quite interesting. We can also make some simple rollback. I mean, you are deploying a new version, you see there is a problem, you can go to the last version, the previous version, sorry. And all the machine definition and GUIX template are in Git. But there is also some problems. Of course, Guile requires some learning. For some team members, it's difficult. They don't like Guile. They don't like GUIX. And they say, but what we are doing this that way, everyone is doing differently. So it's quite difficult to convince some people. When you encounter a service or a package you need, and which is not yet packaged, you have to do it yourself. And it can be quite time consuming. My feeling is that it's we need a global effort for that. So when you encounter this kind of service of package, sometimes you are tempted to deploy with ready-made Dockers or something, and try later when you have more time, which never happens. And it does not protect you against bugs because there is package update. GUIX is a rolling distribution. So it's so easy to deploy new VM, or push a button and deploy. And sometimes it don't work because software has changed, software has bug. But it's easy to roll back. And we also have another problem. We have to use Guile. We have to use GUIX. We don't have much people able to do that. It's a bus factor. How much people in your team can be hit by a bus? For the moment, we have 3 members able to generate packages on VM. So I hope the bus won't crush the 3 people in the same time. Thank you for your attention, and do you have any questions?
So thank you very much for this insightful talk. It's always nice to see a GUIX system working on production systems because I've only been tinkering with it on my own laptop. So let me grab it.
Hi, thank you for this nice real-world overview of HPC. I wonder why you have to reboot your machines when you do updates, because I thought you just, I don't know, put in some new symlinks and restart system services and then you're done.
Because we could do, we could only regenerate the system without regenerating the whole VM. I mean, you can make a GUIX system reconfigure, for example. But it's not taking more time for us because we have a safe storage. Sometimes we just kill the server. I mean, we don't make a graceful stop. We just kill it and we start. All our services are in high availability. I must say that. I don't know where it's. Oh, yeah. Much of it are, for example, we have 4 SSH proxies. We have 4 LDAP servers. So we just plug off the servers. The load balancer do its job, redirects the LDAP request on the other servers, and we just have to start the other. So it's more convenient for us to do this way.
I see, thanks.
So, first of all, thank you for your presentation. I have a lot of questions because I am actually working on implementing a Slurm cluster with GUIX. I have also defined my own Slurm service and everything. I mean, everything is working, but you probably are more advanced than I am in the road, so I will ask you later. But why did you mount the GNU store like in a safe storage instead of letting all the machines work for themselves in that regard?
It's for the compute nodes. Because we have 300 searchers. They all have a specific environment. So when they launch compute on our nodes, each compute node has to be able to access the profile of the user. That's why. Not sure I have well answered.
Yeah, that is okay.
Okay.
Hi, thank you for the talk. In my previous job, I was working with IBM mainframes, and I can tell you from experience that most of the time the machines were idling. So
it's not okay.
This is not well.
No.
So how much free capacity do you have?
Oh, the new one is not totally overloaded because it's brand new and not in production. It's pre-production for this one. Nautilus is just in pre-production state, but it's already quite loaded. This one is full.
Mm-hmm. Okay. So it's busy.
Yes. And GPU are hyper busy.
And well, what is the main bottleneck of your operations? Is it the development works which has to be done, or is it the restarts, or some other issues like capacity of the network transmission line, or?
It's a wall. We have storage is a big bottleneck, for example, because we have some jobs that are really heavy on disks. We have GPFS, we have CEFFS, and we also have BGFS, for example, for storing Scratch work. And as you have seen, we have different type of high-speed networks. We have Omnipath, Rocky, InfiniBand, depending on the generation of the cluster. And there is a lot of loads also.
Okay, thank you.
Thank you very much. So we're running a bit late, but yeah, maybe you can ask the question later.
At the lunch.
Thank you again, and
thank you very much.
And now Emmanuel is going to present how we can reconcile high performance computing and third-party libraries using GUIX. So take it away.
Thank you very much, Jocelyn, for the introduction. Thanks the organizer for the invitation and for the great conference you are organizing, both in terms of welcoming us and for the scientific program that has been so far. So I'm very happy to be here and share this moment with you. Yes, as Jocelyn said, the talk here won't be much about reproducibility than being able to produce something. So this is what I'm going to talk about, because for us, it's hard enough that we want to reach this goal. And basically, the thing is that there is something common in software engineering that is using third-party libraries or modular programming, that I will define more accurately later. And in high-performance computing, it happens much less often than in general computing. So why don't we use this general software engineering nice rule? So I'm going to try to talk about that. So it's a joint work with my colleague Ludovic here, Marek, who made a tutorial this morning, Gilles Marie and Florent Prévost. We are all at INRIA Bordeaux, and Marek is now in Strasbourg. So first of all, I will try to talk about separation of concerns. So separation of concerns, I'm taking the definition in Wikipedia. So in computer science, separation of concerns is a design principle for separating a computer program into distinct sections. So far, it's something that all of us think is normal, right? Each section addresses a separate concern, a set of information that affects the code of a computer. So a separate concern, that is a set of information that affects the code of a computer program. And so that leads to modularity. A program that embodies separation of concerns well is called a modular program. So that's not new. It has always been there, and it has been formalized by Dijkstra in 1982. So what are the possible opportunities that separation of concern provides is that when concerns are well separated, you have more opportunity to upgrade your code, reuse, and do independent development. In particular, what most software engineers do is that they focus on the core of their code and they use third-party libraries, right? And in my experience, neither myself or the colleagues I know do that very much, or have done that very much in the past in high-performance computing. So I will try to explain why. Actually, these are the two main reasons. Yes, it will be nice, but it's high-performance computing. I want to have full control. So for instance, if I'm doing an out-of-core code, so a code that uses disk to process larger problems, I want to make sure that my memory management fits the way I copy the data on disk. And so I will do, so I did that in my PhD thesis. So I worked 3 years on that to do better and larger scale sparse direct solvers. And actually, I didn't realize that maybe it could be more modular. So it was natural. And there is another reason for that, is that one more issue is that, okay, I'm going to use a third library to do the IOs, to do the memory management, but okay, so it will be one more issue when I will have to deploy this code, because will this library compile with this version of my C code and so on and so forth? And when I'm doing HPC, in the end, I'm going to a supercomputer. On a supercomputer, I'm using modules. These modules change over time, change over machine, and I am not the only user. If I do a library, I do it for users. So I don't even know their machines. I'm going to, how can I ensure that my code will be deployed in this case? So my experience, it might be the difference for others, but that in high performance computing, we don't do separation of concerns. Or we do it at a very little scale. For MPI, for BLAS, and for maybe partitioners, that's basically, I mean, 3 typical examples. There are few others, but we don't do that much. So actually, these concerns are even harder in other communities, so grid computing, now cloud computing. And so they have tackled this concern with more care. So that's good for us because I've been working on that for a long while and we can benefit from that. So we have people in the room here working with NIX and to deploy nice platforms, grid or cloud platforms, whatever, with NIX and other declarative systems such as GUIX. And we benefit a lot from their experience. But still, it should be simpler in our case, and we are not at the stage of modular computing. So, what I'm going to take next is, so what is our team? What are our objectives? And why we want, how we want to try to tackle modular computing and high-performance computing. So I'm in the Concast team, so it's a new team at INRIA Bordeaux. The first two letters are the only important letters. They are about composability. You can view it. I'm not expert enough in taxonomy, so it's a synonym of separation of concerns, modular computing or composability. Don't ask me any question about it. I will try to discuss in the next months with people expert in composability and this stuff. I'm not expert about it. I just try to use this principle. So basically, we want to do composability. So what we have been doing, we don't start from nothing, because in high-performance computing, what you typically do, you do MPI plus thread, plus typically when you do GPU CUDA, which is a proprietary software, and you do that at very low level. So something like 10 years ago, we started to do, we are not the only ones, but we started to put all our energy to say, okay, we stop doing that, we continue, but just a little bit, and we try to see if we can abstract that. So we try to abstract the architectures through task-based programming. Task-based programming has somehow also always existed. But only or no people were crazy enough to put all their energy and to say, okay, we are going to change the code like this, because when you do task-based programming, it means you rely on a runtime system. So how is it going to orchestrate your computation, because you don't have the control anymore, or you don't have the direct control anymore on the way you do scheduling, for instance. You don't have the direct control on the way the data is moved from your CPU to the GPU and so on and so forth. And we took this bet, and we are happy about it. Now it's more popular, but 10 years ago when we were doing this, people said, okay, crazy guys. Some of these people now are doing task-based programming, and they are doing like that very much. So we are happy of this bet, and we did part of the job, which is abstracting the architecture. We do that for linear algebra computation. Some of my colleagues do that also for multilinear algebra. For me, it's already hard, so I try to understand what they do and help a little bit, but I'm not expert very much expert in it. And we apply that to numerical simulation, and more recently, data analysis. So we made a team, so we decided to go one step further. So now we know how to abstract the architectures. If we want to separate the concerns, how about we abstract also the mathematics? So basically, we don't write, don't know for those who have know about iterative methods, you have Krylov subspace methods with weird names. You have conjugate gradient, GMRS, all this type of methods. They are actually just very simple methods if you use it as a composition of elementary operation. But not the codes are written like this, but not the books either. So the goal of the team is to say, okay, how if we could write like rewrite the math and the code in this method, so that we will have abstraction of the architecture with task-based programming and abstraction of the math. That will be our dream. And so we change. So we still do linear algebra, whatever, but we try to redo that in a composable way. Okay. And so if you do, so currently we have libraries. So if you have the slide, you will be able to click and to find what's underneath there. So you will have libraries for doing dense linear algebra. So Chameleon, for instance, it's a library that runs on top of multiple runtime systems, such as TARPU runtime system, that can do GPU heterogeneous computing, that reaches pretty good performance. We have also sparse direct solver, for instance, QRMEMS, that is led by Alfredo Buttari at Toulouse, and with whom we work a lot to do task-based sparse direct solvers. There are other PASTICs developed by colleagues in the Topal team. We have iterative methods. I'm not going to get into the details, such as we name it Fabulous Fast Block Krylov method. It's and we try to combine direct method, iterative method, and we make it in a software that is called that is a hybrid solver, massively parallel hybrid solver. It makes a huge stack. So not only we have the dependencies on the runtime system, but we have the dependencies on plenty of libraries. So it makes software extremely complex to develop. And sometimes you say, okay, but how about if I revisit my matrix vector product? Because matrix vector product, for instance, can be viewed like if you do, if you have plenty of stars and galaxies and so on and so forth, you have interactions, and you can say, okay, if stars within one galaxy, they are closer from each other, so I can just view them as a big star from the star that are in another galaxy, right? And that's called fast multiple method in a way. It's a view of it, and you can review your matrix vector product, and then how about I review all my codes with that? And so all these codes are developed or co-developed by our teams, our team, and they have very little overlap, except that they can use each other. And they are doing things that are very similar, like doing BLAS and so on and so forth. So even in a single team, it's hard to combine and to make a modular usage of tools. So that's the objective for our team. So we say, okay, how about during 4 years we keep this crazy normal environment. It depends if you can view it as crazy or normal, depending. There was this debate, right, before about should we take risk or should we take the usual? So we're going to take the risk during 4 years and see what happens. And in 4 years we can say, okay, it works, it doesn't work, according to our experience. So that's in our team, but as I said, we use runtime systems, so StarPU, for instance. We don't use OpenMPI, but other MPIs, or something that is other communication layers than MPI. So how can we move to that? We want to use, to detect the locality, so we use hardware locality HWLOC tool. We want to use a partitioner, but maybe this version of the partitioner for the spare direct solver, but the hybrid solver want to decompose it with another version which has another feature. So it makes things complicated, and all that we don't make codes to run them. We make codes solver so that it runs in application, and so we have colleagues in PO, for instance, that have a wave propagation code and that have to use that. Okay, so before I give you something, I just want to make a point on bitwise reproducibility, because it's what I'm going to talk about. I'm not going to talk about anything else. So you have people who are very enthusiastic about reproducibility in general. For instance, you can do on the website of Software Heritage and GUIX join forces to enable long-term reproducibility. It's great. It's a huge ambition. And you have people that say, okay, so I didn't translate. I took it from a list that we have in France about computation. And I don't think it's worth really translating it is, but basically it says, in many scientific fields, bitwise reproducibility is useless. I would say it like this. And my point is the following. We had also this debate yesterday. You remember about replicability, reproducibility with Sarah and Miguel, and was different terminology. Okay, for me there is one thing. I just want to have a reference point, which is right. And then, if I am able to have this reference point, then I can play around. Call it however you want. I just want to be able to have this reference point. And so, so the typical issue is that, as you have understood, we have, especially if you are at the top of the soft solver stack, like hybrid solver, you depend on spare solver, on dense solver, iterative, direct, and so on and so forth. You have to combine all that. So you have very complex software stack. And this stack is embedded in an application where it's very hard to deploy. Actually, by hand, one application managed to do it by itself without interacting with us, and it was a very experienced engineer, and it took him months to do it. And I think it's very good. I won't be able to do that myself if I didn't know the code. I wouldn't be able to do that myself if I didn't know the code that well. So our goal is simply to be able to produce a correct environment, correct build. And work done once in package definitions, so that when it's at Glycid, when it's on your supercomputer center, whatever, then it's validated by the author, it runs, and you have a reference point. Of course, if you want to change MPI or whatever, you can still tune it, but you have this reference point, and you can validate it works on this reference point. So once again, it's all about having a robust reference point. Ensuring an end user may have a correct and fully featured software, you will see that depending on the way we deploy, we don't ensure fully featured. So we say, okay, we turn that functionality off. We turn that other functionality off. We don't use this sparse direct solver because it's too complicated to deploy. We use this and that. And so we have like reduced functionality software. Okay, I want to do that on different machines. I want to do that in continuous integration. Will I be able to reproduce in time? How about the pre-processing and the post-processing? So you saw that a little bit with Marek. For those who attended his tutorial this morning. Okay. Another thing I want to do is, it's a very complex environment. So I am the developer of, let's say, Chameleon, one of the developers of Chameleon, and I want to change the way we do the tracing in Chameleon. So I use FXT, a tool for doing tracing. And, but I need for that StarPU, which is a runtime system, to change. So what I do is that, okay, I do some changes, I make an issue, and what I put in the issue is this code that my colleagues in StarPU don't know Chameleon or don't know that well Chameleon, but know very well StarPU, can exactly reproduce. So here I didn't put the channels for capacity, but if you add the channels with that, you can reproduce. Both teams, the developer of StarPU and the developer of Chameleon, can have an exact same reference to see whether or not it works. Okay, then you can turn around, play around. That's the point. So basically, here what it says, okay, I want a pure environment. I want linear algebra solver Chameleon. I want to use this branch that of StarPU for which I'm proposing a fix. And then I'm running, so within this line, I'm also doing the test. So PUTRF is a symmetric factorization algorithm on a matrix of size 4000, and then it's displayed. I also propose a nice display so that it's easily viewable, and with that, my colleagues can, in the issue, validate whether or not it's correct on the StarPU side and whether we need to progress. And that's a common reference. So that's what I want to explain in terms of reference. And when we'll have that, we'll do reproducible science. And that's a very nice goal. And we are very much willing to do that. But we need first to have that reference point. So here I'm going to tell a little bit about our quest. It started like after we had conclusive results with the abstraction with task-based programming and dependencies on many pieces of software, StarPU and so on and so forth, where it became harder and harder for our user to deploy the software. So we say, okay, how can we do that? So we basically try to work with CMake, then SPAC in 2015, and now GUIX for a few years. We never quit any of them. We improve them or at least maintain them. So I'm not going to talk a little bit about CMake, but CMake, it means, okay, we need to have some, I'm not, whatever tool, but a tool that has a core tool. So CMake is attached to a package, not to, in general, not to a set of package, right? In terms of what Conrad was saying, you know, you have different levels. You have the package level, and then how it interacts with everything. So it controls your package. And you need to have something that is very much versatile. So you need to be state-of-the-art on that. So for instance, Florent Prévost did a huge work, and before him, Cédric Castagnette did a huge work to have nice CMake things. And we even, at a point, we discussed that period with Ludovic Cortés, maybe in 2013, something like this. GUIX was just newborn, and said, okay, no, don't use that tool. It's not good for HPC. It's not. Try other tools. And there was not. We looked at other tools. There was nothing very much mature at this time. And so we did our own distribution with CMake. So you can imagine it was crappy, but it serves some goals. I'm not going to talk anymore about CMake, but then we, in 2015, SPAC, Supercomputing Packager, reached a certain level of maturity. And so we say, okay, how about we are going to factorize the definitions of our dependency with the tools whose goal is to tackle that. And so here is a solver, so one at the top of our software stack, massively parallel hybrid solver. So basically in Spark, so this is Python, so it looks nice because we are used to use Python, right, most of us, more than other Lisp or scheme systems. So it's at first sight, okay, it looks very nice, and it is. So you declare like, okay, I want to a master version, a developed version. I declare a 1.0 version. This is my preferred way of doing the things. So then I do okay. This is something that is both nice and a little weakness. But here, okay, I want to be able either to install my dependency on a sparse direct solver (MEMS) with or without MPI. I can use it in a local node or globally on multiple nodes. But I know that if I use it with MPI, it might be hard to deploy, so I want to be able to turn it off, right? So I do plenty of things that allow dynamically then to do some simple ways to tune the package deployment. So it's an elegant and compact definitions of variants, for instance, plus, months, MEMS or not. And also you have a compact definition of multiple versions. And that was a great improvement. We were very happy and we are still happy. We are still maintaining our Spark version because some users want to use that. But even the people we were developing codes with, like for instance Chameleon, the co-developed at KAUST, it's co-developed at University of Colorado, Tennessee, and some of our close colleagues were not able to deploy their own code because of this C dependency, of the variation on the libc, on Scotch, on whatever. And so for a hybrid server. And so we said, we went again to Ludo and we said, okay, you're sure there is nothing else we could do? And at the point, okay, he said, okay, let's try. We did some progress. And we started the adventure. So that's how the same package looked at the same time. It's a little bit outdated now, but it doesn't matter. So you still define where you, it looks like the same with some more parentheses, but it doesn't, once you are used to it, it doesn't change much about it. And what you look is that here we don't propose definitions of variants. We do, but it's not essential. And everything is on. Because we are sure that if we manage to deploy it on our machine, we'll deploy it anywhere. So that's the major difference, and that's why we put our, we're still happy with Spark, but we put 99% of an energy on tools like GUIX, because we want to have this robustness. So it's nice because, okay, we had talks of by people much more advanced than me in GUIX on containerization and everything like that. So basically, you have to tune it a little bit because your code is going to be compiled in an isolated build. So it will think there is only one core. So what you want to test your MPI code on 2 cores, and it will say, okay, no, you cannot. So you say, okay, yes, I force you. You will run on 2 processes, even if you don't have 1 core, to build it. It doesn't matter, trust me. And so you have some more things. So this is an outdated, but it's the same period at which we developed the Spark version, way of declaring dependency. And you see that you have the full set of dependencies, and we are able to fully deploy our code. So yes, main remark I can do that is that there is we have confidence on the deployment of the package with all its dependencies, which out of reach for us without a robust tool for ensuring a bitwise reproducibility, to come back to the original remark we had on the list calcul. And so in terms of Spark terminology, there is variance. There is work on progress with parameterized package. But it's less important because we managed to deploy with fully featured things. Still, sometimes it's useful. So, for instance, you want to change the configuration on whatever, and you have very nice transformation rules. So you can do help transform if you do GUIX shell or whatever other tool, and you will see like a rich way of playing around this reference point and trying to make it progress. Or as Jan was saying, you know, when you try to make an evolution of a software, you may have bug, but you have your reference point and you can play around to try to improve. So you have a progressive way to play around your reference point. Okay, so then what we want to do is this reference point, we want it to be clear, so we do use literate programming to do that. So we use in our case, org mode to do that. So we didn't reinvent the wheel. So you have people very early in 2015 in the papers. I've been working on that much earlier. Like Lucas Tanisi, Charno Legrand. So it's work in Grenoble. Maybe it's not hazard if it's in a location where many people work on grid computing and very much aware early about reproducibility. So in their paper, they already mentioned, okay, we want to address accessibility, provenance tracking, documenting extentability, replicable analysis, and so for that they use Git at that time and org mode, and it was like very nice. But so we exchanged a lot with Arnaud, and then Luca even went to help us in Bordeaux. And the thing is that with our complex software, we had only using the Git package itself, playing with the Git on the package, it was not enough. So we wanted to use, to change and to play better with outer loops of the environment, to reuse the terms of Conrad of the presentation of yesterday. So how we do, like how we play with other tools, how we do interact. And so we used, so that was in the context of the PhD of Louis Parel. We used org mode with Spack and Git, but we did Spack with it. And it was a really great improvement for our context than deploying the codes without any tool dedicated for that. And you can see here that you are able, with these few lines, to deploy the whole software stack. I mean, if it works, but you are able to deploy the whole software stack that we had for the thesis. So basically, you take Spack. We had here where we maintain our definition for our extension of Spack. Then we install it. Okay, you have to the negative signs here. Say, okay, turn that off because it's hard to install. Okay, turn that off, turn that off. So it's not fully feature installed. But for the purpose of the PhD, we were really happy about it, and so we could do literate programming with a certain level of confidence in reproducibility. And then, so that's how you do it on your laptop. And then when you are doing it on another machine, so for instance, that was at CNES, machine oxygen back in 2017, something like this. So you had to do some module load, and then you do the Spack load, and most of the complexity is embedded in the package definition, so it was very, very nice to have that. So yes, you have compactness versus step-by-step install, flexibility. You can use module, for instance, available and tuned by administrators. You have reliability, some level of reliability, especially because the modules provided by the administrator are well tuned, interoperable with Slurm and whatever. So you talk about PMIX. I should update myself on the topic for interoperability. I didn't know it had advanced that much. So, but whatever, you know, you have to talk with the daemon and whatever. You have the guarantee that the whatever is around your Linux kernel and your low-level environment is well done. But the interaction, the layer at which you do the cut might be hard to maintain. So that was the limitation. So we moved another PhD thesis, the one of Marek Felsoshi. So that was in the context of Airbus. So I highlight that just to say that, okay, of course we promote open source software, especially in the context of reproducibility. But if companies want to do and to make things reliable, they can still use GUIX to do it. They did it. It was done in the context at Airbus with Airbus code in the context of Marek thesis. So you can do that. And I'm not going to, so that was in the context of jet flow simulation, where we use sparse direct system to solve some finite element boundary element equations, so where you have sparse and dense linear systems that are coupled. And I'm not going to extend on that because you did it for those who attended Marek session this morning, or at least you started to do it and you have all the instruction to finish it at home. So I'm not going to make you lose time more than that with something part of you have already done. Okay, so now this is very nice, but how do I handle that on supercomputers? So, okay, if you are lucky, you are in Nantes, for instance, you have people who made GUIX available for you, done, okay? you have the perfect experience, a smooth transition from your laptop to your supercomputer. It means basically you don't change anything, maybe except if you want to say, okay, Jan is going to say, you try this version of OpenMPI because it was not pushed upstream in main GUIX, so maybe use this one instead. You have your reference point, but you go a little bit, but it's still a very smooth transition from your laptop up to your supercomputer. And GUIX is not there on some other platforms, so I'm talking also to system administrators and the scientific people of national and international platforms there. So is this possible so we hope it will be there soon, but it's not there yet on some machines. So what we do, there was talk about, you talk about it, other people, Nicolas also talked about it, about, okay, you do GUIX pack, and so basically, to come back to what Miguel said, you want to do reproducibility in a declarative way. GUIX pack is the tool. So you remember that was, we use compact definition, and we have a huge complex binary software stack. So we don't have a Docker image. From the, we generate something that is of the size of a Docker image, but we have a few lines of code that declare it. So that's what we do. I'm going to illustrate that with some lines of code. So we have a declared, to take the word of Miguel, precise or exact, declared exact deployment. So you can do that with multiple tools, Docker, tarballs, whatever. I'm just going to talk about singularity for the conciseness. 15? Okay, merci. Yes, just to say, because these are clickable links, so don't hesitate to go there. So here I'm going just to give you an overview, quick things, but if you want, you can go there, so on GUIX HPC info, where you'll have some information to do that. And another resource that is more subject to change and more partial or whatever, but it's where we try to collect plenty of recipes. So it goes from a single node execution, so you do an allocation of one node, to like an advanced singularity on a multiple node platform, or even if you want to quit your MPI and do something else. So it's a long thing that starts from hello world and that go to advanced usage of GUIX plus Slurm, soon with a PMEX instead of just Slurm by itself. GUIX plus Slurm plus MPI there. So we try to propose at least a way of doing things, and this resulting, it works and it's reproducible. You have a dependency that is declared there because once again, there is a cut. The cut is very low with GUIX, but there is a cut, for instance, based on Slurm. You have to connect to Slurm. And so here we assume that Slurm 22 is being used, and that's why we have a reference point, and we can change by changing the version of Slurm. That, in our experience, the only variation we had to make in time or on machine with a long time. So I'm closing this. So don't hesitate to go there. It's a clickable link in the slide that you will probably have access to. Here I'm going to do just a few snapshots of what we do. So first on Plafrim, so it's a tier 3 machine, so like a local machine, not even a regional machine. It's a machine that is like in our building at INRIA Bordeaux. So we have an homogeneous partition, so I don't have much time, so I'm just going to pass the technical details there. And then we have an experimental, an heterogeneous machine, so with GPU, NVIDIA GPUs. I'm going fast there. So what we do is, first of all, you do this instruction. So you do the starting point, describe. So you are in a certain version of GUIX, and you want to make sure you will be able in the future to do the time machine. So by default, do that so that in the future you can come back. Okay? And this is the result. It gives you a channel. So in our case, or you can, and this can be an output of this instruction, but it can be an input of a GUIX pool or a GUIX time machine then. Okay? So it's a cycle things. So we save it in this GUIX channels SCM file. So here, basically, what we use, is GUIX, core GUIX. We had discussions about channels before, so I'm not getting into the details. So you are using GUIX HPC. And also, for people saying, OK, GUIX is only free software. Yes, GUIX core is only free software, but it has a clear separation between what is free and what you do when you are not more free. And so you can use them, it's up to you. And here, in this example, I'm going to present example where we use non-free software, such as Intel MKL, because many HPC practitioners think it's important to use them. In our experience, it doesn't change anything, because we have a good reference point. We can change between OpenBLAS and MKL. We don't see significant reference as of today. And also CUDA, because a few years ago, it was mandatory for doing heterogeneous computing to use CUDA, which is unfortunately proprietary software, but it works in GUIX. Okay? I'm going to present result about it. So once you have recorded for the future your channel, you can just do something, once again, in the spirit of Miguel, that is very much declarative. You can do a GUIX shell where you export the manifest, just to store the manifest, where you say, OK, I want a dense linear algebra solver. I want sparse hybrid solvers. I change OpenBLAS by MKL, because we think, or some people think, it's very important to use Intel MKL. And a few utilities, like Intel MPI benchmark to do ping pong to test my Intel, whatever. A little bit of Slurm. It's important to interact with my low-level levels. If I have to change the version of Slurm, I will use the transformation with Slurm equals Slurm 23, maybe whatever. Here I don't need. So I store my manifest. And what I do next, so if I have GUIX on my machine, I'm done. If I want to use Singularity, this is the way we do. So we use, with Time Machine, the channels that we recorded before. To create, with GUIX pack, a Singularity image. So SquashFS is for doing something compatible with Singularity images. And then we copy this image under this file name. So that's what you do on your local machine. Then you transfer it to your distant machine. And so here, you have plenty of tutorials of doing Singularity with MPI, whatever. We didn't follow those advice because it's a different workflow that we use. What we do is basically we take a vanilla MPI, which is the MPI we are going to use to do this MPI exec, okay? Because this will be the starting point. So it's an MPI that you can configure with just a few lines. You see there is no option. We just use Slurm and an install prefix, and that's it. And all the important things to make MPI fast are within the ASM, within the table that we defined before. Because that we defined before, because both Chameleon and Mafis depend on MPI, the one of GUIX, that has been tuned to work across architecture that is extremely versatile. And if, for instance, in Nantes we need something else, we just would have the little change transformation that will ensure that we are fully compatible with a low-level MPI that is in Nantes. And so the results, so yes, the execution, sorry, the execution is there, so how to run. So how to build those vanilla, now how to run. So I use my host vanilla MPI to launch the thing. Does almost anything, just connects the MPI between themselves. I just Singularity exec and my image and the name of my executable. So here, for instance, it's the ping pong. And so question, do you lose performance? We are in edge performance computing, so we want to make sure, I mean, what's happening in terms of performance. So here you have what you have with modules in blue. So it's a throughput. We don't care about the units, but it's a throughput. And the higher, the better, right? But what we see is that whether you use modules or GUIX, you have roughly the same performance. And whether you use GUIX or GUIX with Singularity, you have roughly the same performance. So in terms of performance, you don't lose anything, or almost anything, using Singularity. Okay, now something more serious. We are doing like a wall solver, like a Chameleon solver, which so here it's on 2 nodes, and then homogeneous setups. So what if I use modules? What if I use GUIX? And what I use GUIX Singularity? There is no major difference. So this workflow works very well. What if I go to GPU? So once again, my manifest is not there forever. It's a reference point, but I want to change it a little bit. So here I say, okay, I don't use chameleon, by chameleon CUDA, which is, you were talking about inheritance, that inherits from CUDA, but just add up some non-tree packages, including especially CUDA. And so I do manifest for that, and we do the same thing. And this is the performance with GUIX and recherche module. So okay, which one is above is not significant, and we are happy with it. Okay, now you want to go to National Center of Computation. So I talked about CNES before, the thesis of Louis Porel. Now I'm talking about Idris, Machine Jean Z. So I'm skipping the details. So we take some advanced modules that were the most advanced modules at the time we did the experiments. And we compare what you do with modules, with what you do. So you are on 8 nodes, 32 nodes, and 129 nodes. So this is performance. The higher, the better, and number of operations you do per second. And you see that there is not much difference. So this time, the version with GUIX and Singularity. So there is no native GUIX here because there is no GUIX available yet at CNES or Idris. But still, you can today use GUIX to run on this machine, in this example with Singularity. So not everything is about performance, just to say another example with Compose. So Compose is extension of Mafis++ to do, okay, we want to do composability, and so we are going to do a range of algorithms instead of just a few algorithms. So rename Mafis++ into Compose to say, okay, we have plenty of algorithms. So this is just the example of a conjugate gradient, an iterative method. So this is, depending on the iteration, where you are in terms of convergence, the lower the better. And you see that you cannot make the difference numerically neither on this execution on 14 nodes of Jean Z. So just to mention, if there is no, I just talk about Singularity, you can go to this web page and you will have information if you do other techniques such as tarball or whatever you can do. If there is neither GUIX nor Singularity, you have also solutions. I'm not entering the details here. Just a few words on continuous integration and continuous deployment, because thanks to that, we are able to develop an entire literate code. So I'm going just to click here on the master branch of the code that is fully literate, and so this is the code that we have. It looks like a documentation, but it's a code. We are talking about documentation of code. So this is our code. And the whole code, which is a huge code, is not just a proof of an experiment, is developed with literate programming. And together, I will let you click on that because I have little time. Together with GUIX, we are able to integrate things such as, we were talking this morning about continuous integration, continuous deployment, results that we have indirect. So we deploy continuously our experiments to see, okay, for this variant, numerical variant of it, this is the performance I have, and this is the weekly bench that we maintain thanks to GUIX and org mod in this nice setup. So this is code actually. This is code. Yes, and you can have also, if you want to have you can, if you prefer the PDF, you can have also the full 700 pages PDF. So here I'm saying it's literate programming. I'm saying some parts are literate, dot are still more programming. So it's not because you have the framework that you don't need to write what your code is for. Okay. So my conclusion is that today, that was the presentation, we can already do high-performance computing with GUIX on supercomputers of our ecosystem. It worked, it achieved good performance. We didn't notice any significant difference in performance. So thanks to GUIX Pack, we have robustness in performance. Tomorrow, this is the hope, and we hope to interact with our community here. To have GUIX also available there, to add to robustness and performance, an enhanced transition from your laptop to supercomputers, to still have some versatility once you're on the supercomputer and not produce your image from your laptop, because sometimes you don't want to do these go and back things. So, and one will have that, will be safe to do composability and reproducibility. So we count on our community, so let's make this tomorrow happen together. So there is this national initiative that, so you have people in the room that you can meet, Bruno Raffin, Ludovic Cortés, and others that are involved on that, to have to prepare the venue of our exascale machine in France, and hopefully we'll have GUIX on it. That will be great, I think, a great thing if we can put all our energy all together to converge on that. Just something about literate programming, and because I have the audience, I think that is very scalable here today. For further joining literate and reproducibility study, for those people who are doing org mode, something that will be great is to use a cache. You use the hashing mechanism of GUIX and software heritage and everything to do, okay, I cache, but based on GUIX on your Nook store, or even on distant computer, with so GUIX on X, or even GUIX Workflow Language with presentation. So I don't know, no idea how to do that, but if we had that, we had very much declared presentation, to come back to Miguel words, with, without spending the energy of doing plenty of times, many times the same thing. So I think I have already late, so thank you very much, and let's have a good meal.
Thank you very much for your talk. So, except if someone has a very pressing question, maybe we can move this off stream, and then we can leave the amphitheater because we're already 30 minutes late. But maybe we can thank again the speakers of the session for their very nice talks. And so this was the last talk, and we'll have tutorial sessions tomorrow morning. But in the meantime, we have the gala dinner this evening, so it's at 7:30, right? And we'll probably be leaving as a group in about 30 minutes, I think. So if you want, we can maybe go there. But otherwise, thank you for attending, and let's move the discussion downstairs.
Ouais, bon. Non, mais c'est pas très grave. Au pire, je veux dire, si les gens ont des questions, oui, c'est ça. C'est surtout pour l'amphi, quoi, en fait. Parce qu'on est déjà 30 minutes en retard et tu vois, eux, ils avaient prévu d'être là jusqu'à 18h et on était un peu. Si ça doit marcher. Mais oui, non. Mais par contre, j'ai laissé 40. Enfin, je vous ai tous les deux laissé 45 minutes. Ah, c'est cool. C'était très complémentaire. Ouais. C'est beaucoup de trucs. Ouais, il a coupé. J'ai coupé la partie dans la voix parce que les graphes de performance. Moi, je m'en déjà que ça marche déjà.